competition is the world's landmark robotics competition for students.
In school, you read about stuff, but in FIRST as a whole,
The challenge comes out every year. Under strict rules and limited time and resources, you have to design, build, program, and test a robot.
There's no blueprint. We get a few rules and guidelines to follow, and then it's up to those students to find something that works.
There's nothing better than just seeing your robot on the field playing for the first time. They're all there like, is it gonna work? Is it gonna work? And then when it works, it's the best feeling ever.
You have mentors that are actually in the field that can tell you, oh, this is why this works, and this is the science behind it. And you're like, oh, wow, that makes so much sense.
They do a great job, not just about them, but about life, how to go through college, how to go through, a tough, physics class.
At face value, FIRST robotics competition is a robot competition, but at the end of the day, it's so much more than that.
People ask me like, oh, you build robots? I says, no, we're really running a business and all the things that go along with that.
We deal with a lot of marketing, social media.
I've learned business sides of things.
Problem solving, working in groups.
I'm learning how to communicate with people, how to reach out to local businesses.
So we kind of have robotics as the starting point, but we branch out to different areas and expand.
So the ultimate goal every year is always to get to the FIRST championship.
The FIRST championship is basically like the Olympic for robots.
There's hundreds of teams from all over the world there, and you get to see some of the best teams that exist.
It's very competitive, but you're friends with the people that you're going against. It's like a sport, but in its own way, it's better than a sport.
Being part of FIRST, it's really changed my life and how I think about myself, how I think about others.
Participating in FIRST actually taught me that I'm capable of doing anything that I set my mind to.
FIRST has really inspired me to give back in my old elementary school. I'm trying to help their robotics program that just started this year. I want those kids to have the opportunity to learn about STEM.
As a participant in the FIRST program in high school, you get access to $80 million worth of scholarships.
There are scholarships for colleges, universities, as well as technical programs.
It also looks really good on the actual application to be on FIRST.
FIRST does a really great job trying to open programs to make sure that you can actually accomplish anything in STEM, no matter where you're from, your background, your language, or anything like that.
I really do consider myself part of the STEM community, and I couldn't be more prouder to say that.
FIRST Robotics Competition is one of 4 engaging FIRST programs that shows students unique challenges and helps them learn new engineering skills and real-world skills that'll help them in the future.
FIRST is the future.
FIRST is accomplishment.
FIRST is passion.
FIRST is inspiring.
FIRST is changing my story.
In the heat of an ethical crisis, the right path is often not obvious. Your chances of doing the right thing are greatly enhanced if you have thought about guidelines in advance. Teams should be prepared for ethically complex decisions. Often, you have only one shot at getting things right. Imagine that after years on the first team, you are finally on Einstein and you have a good shot at being on the winning alliance. Then, you learn that your alliance partner has an illegal feature on their bot. What do you do? Or maybe your team is impressing the Chairman's Award judges with an elegant presentation, and your teammate gets overly enthusiastic and tells a lie about your team. What do you do? Gracious professionalism often involves thinking hard. Give yourself an advantage by thinking hard in advance. Spend some time on the canons of ethical behavior. Make sure you and your teammates are on the same page about complex issues. Good stuff is more likely.
Hey, all, we should be starting in a few minutes. Sorry, I just had to hop on here. And then we're going to start with an amazing presentation. So, let's give us about 3 minutes. Perfect. And if our presenter is here, we can get started. This is Sanjit from Team 503 on developing iOS apps in Swift UI. So sounds super cool. Can't wait to hear what you have to say for us, man.
Thank you. Yeah, thank you. I'll go ahead and just get started. So as you introduced, my name is Sanjit. I'm from FRC team 503 Frog Force, and I'm going to be discussing how you can use Swift UI for iOS development. So before we get in, I just want to give a small overview of what we're going to be going through today. So first, we're just going to kind of go through this, just an introduction, right, and a comparison. Then I'm going to talk you through an interactive kind of way of looking at the fundamentals of Swift UI, where we talk about how to mix together different views. Then finally, we'll end off creating a full to-do list app with the framework. So let's just go ahead and get started. So just as some history before, right? So the Swift programming language has been around for some time. And even before that, there was the framework called UIKit was the go-to for creating user interfaces, and it was a pretty expensive framework made by Apple. And one of the ways that people would use it was by using something called storyboards, and it was also known as an imperative UI solution. And what that means is like you tell it exactly where you tell the renderer exactly where things need to be on the screen, like how far away from the top, constraints similar to that. You have to set all of those yourself. And then however, in September 2019, Apple released a new framework called Swift UI. And one of the big announcements about it, or like the main things behind it, was that it allowed you to create these really robust user interfaces with very little code. And it was supposed to be this like revolutionary new framework kind of. And another very interesting part about it is that it's very similar to other very popular component-based frameworks, which means that it's easy to learn from there. So for this presentation, if you're a complete beginner to this, I'll be trying to make this as easy to understand as possible, but the optimal solution, or the optimal idea, would be if you have experience with Swift and possibly with some other UI frameworks. I'll be talking about what exactly those are, and there's a lot of them that you could use. And then if you've also done iOS development in the past, or if you've used Xcode or something of the sorts before. If you haven't done any of those or haven't done some of them, that's also perfectly fine. Don't worry about that. So before we go any further, I want to talk about component-based frameworks. So Swift UI is a component-based framework, and that's the reason I'm bringing it up. So about these component-based frameworks is the idea that everything or every element you see on the screen is made up of some sort of component. And the idea is there's system components like text, images, and other ones that are built into the system, but the user also creates their own components. And the idea is anything that you render on the screen is a component. So any combination of components that you make will also be a component. And then you can use these components inside your own components. So I'll be showing this kind of nested architecture in a second, but this is used heavily in a couple of different frameworks, and the two that I'm most familiar with explaining about is one called React.js, which is very popular. It was developed by Facebook some time back, or a while back. It was primarily for web development, and it's still like the core of it uses HTML and CSS. Now, the HTML is a little bit different, like it's embedded into the JavaScript, but the idea is still the same, but it's like kind of custom tags with your custom components. Then there's another one called Flutter. This was created by Google just a few years back. And this was made for cross-platform app development. So this became a very popular tool very fast because it allowed you to create these interfaces with this kind of expandable architecture. And it worked on both iOS and Android. And now it works on web and desktop as well, I believe. However, one thing that I found when I was using it, and this is kind of just how I feel about it, is that you oftentimes need a lot of code for just making a small adjustment. So while it's still a great framework, that was just one thing that kind of stood out to me about it. But before we go any further, I want to make sure that everyone has a firm understanding of how these component-based frameworks work. So I'm going to give you kind of a visual demonstration. So component-based frameworks like the philosophy behind them, I guess you could say, is very similar to that of behind like functions in regular programming. So let's say that I have a block of code that I want to repeat multiple times, but I want to change some small parameters, right? You wouldn't have to copy and paste the code over and over again. You just put it in a function, have those function parameters, and then call that. Creating these components is very similar, and in fact React, the framework I was talking about earlier, literally has components as functions. So the connection is very strong. So the idea is that if you, let's say that I want to render just a piece of text on the screen, so I'll just use the text component. Now obviously the syntax varies based on the framework, but it's generally the same idea. You call this render function with text and that's it. So I've got this text. Now let's say I want to add something more to this and add an image. Let's say I'm building a captioning app where I have a lot of images with a caption on top, or a title app. So now I've got this title and the image. But the thing is, right, not every image that I'm going to have is going to have the same title or the same image source. So I need to be able to make this, first of all, duplicatable. Then secondly, I need to make it so that it's variable too. The title can change, the image can change. So what I want you to realize is that this text and this image combination is what you're rendering on the screen. But this in itself, the combination, is actually a component in itself. So this component, we can actually represent it as our own custom component, as this block. So it's like taking out our block of code and putting it in a function. And then now we could call this function, like this custom component. Let's say I want to add another piece of text below it, right? This is saying like, this is my caption wall, and then showing like all these captions. So it's like that kind of thing. Then I can duplicate this, maybe add some parameters. So the idea is basically that everything is a component, even what you make, and it's all boils down to just combinations of those system components. And this custom and this text combination is also a component in itself. So everything really is a component, which is kind of like that. And then you'll see that Swift UI actually takes it even further. So when it takes it even further, and I'll explain about that in a second. When I say, I like to say everything is a view, and I mean like literally everything, and we'll talk about that. So where does Swift UI stand, like in relation to those, right? So Swift UI in some senses is very similar to those other frameworks. Like first of all, it's a declarative UI system. And what that means is, I found this quote on the internet, and I think this describes it the best. It's saying you tell the program what you want and it gives it to you. So if I tell the program I want to render a text block in the center of the screen, it'll render the text block. You don't need to tell it, okay, this needs to be 50 pixels from the top of the screen, 50 pixels from the bottom of the screen. The rest of it figures it out for you. So the idea is you tell it the layout and what you want in that sense, and you don't need to tell it any of the specific details like how to render it, like the positions, like the exact positions on the screen. So this is different from imperative UI, like storyboards, which I was talking about earlier. And then also it's component based. So just like how in React, the elements or components are called components, and in Flutter, the elements or components are called widgets. In Swift UI, they're called views. So they all have different names, but they really accomplish the same thing. That's that same component architecture. So we've seen the similarities, but what are the differences, right? First of all, Swift UI is a lot newer. It only came out with the release of iOS 13, which was just a year back. So it was able to learn from the pitfalls. I wouldn't say exactly pitfalls is the correct term. Pitfalls and just everything that had those frameworks, whatever the Apple engineers thought worked well, they implemented. Whatever they thought didn't work well, they implemented, and they put their own spin on things. And what this allowed them to do was it kind of created, like, I felt like one of the, like, a really great framework, just simply because of the fact that it's newer than the other ones. So it was able to learn from those past things. And what this allows them to do is the implementation that they came up with allows you to create complex interfaces with only a few lines of code. We're going to be making a to-do list app later in this presentation, just from scratch, and it'll only be around 70 lines of code total. So it is quite a big achievement. And the way it does so is by utilizing this thing called the builder pattern. So let's talk about it for a second. So this is like a pretty common design pattern, I would say. It's not used just for user interface stuff. It's used for everything. But the idea is that it's a design pattern that greatly reduces the amount of code needed to create complex objects. So not just like views in the UI sense, but just in general objects that have optional parameters. And what I mean by optional parameters is, let's say you have a car. You have a car object, you would create a car builder, and maybe you want to say add wheel rims. Maybe the wheels, or maybe like paint add paint color, right? Maybe the default paint color is already something. You don't need to change it, but you can already do something like that. So the idea is essentially all modifiers or functions modifiers, they return the class itself. So this is written in Swift, but the idea stands in any other object-oriented programming language where you have a class and you have some function inside of it. So something dot add something. At the end of it, I say to return itself. And what that means is that it's saying, I'm going to do whatever's going on here. So let's say this add something function changed a variable inside or printed something. What it'll do is it'll print it and then return itself. So it ends everything else by returning itself. And what this does is it essentially says this function is no longer a void function, something that you would in general consider to be a void function where you just do something and it doesn't return anything. It just does it. Well, is now returning itself. So what we can say is something like this. So let s equals something, like a new instance of something, dot add something. So what this says is now we don't need to use two lines for this operation. We don't need to say let s equals a new something, then say s dot add something. We don't need to say that. We can do both of them in one line. But for just one function, it doesn't seem as interesting. But when you start to get multiple functions, some that aren't even needed, like optional functions, that's where it starts to get confused, or that's where it starts to get interesting. Sorry, not confusing. So let's say I had another function called another property, right? That's just below here. So rather than saying let s equals something, then say s dot add something, then say s dot another property, that's 3 lines, and it's kind of cluttered. And like some people would say that it's necessary, some people would say that it's cluttered. But then the idea is with this, all you have to do is just type at the end of this dot another property, and it simply works. Like it's kind of cool. Like it just, because what it's saying is this something was creating a new instance of itself. Then it's adding something, but it's still returning itself. So this is still the same something, but with the property change, this first block. But then when we finally just add that another property to it. So it's just adding them sequentially one by one. And normally this is formatted with with like new lines and tabs, but I wasn't able to fit that. So this is just like the general representation. So how does Swift UI use this, and what does it actually do with it? So this thing on the side here, I call it the Swift UI canvas, and basically we're going to be talking about the how Swift UI works with this interactive kind of fashion. So let's first talk about what I like to call the anatomy of a Swift UI view. So if we take a look at this, each view starts off as a struct and that implements, or like it extends the view class. Then each view has something called inside of it called a body. This is going to be a variable that's also a view, and inside here you set it to whatever your object is. So the reason I was talking about knowing Swift at the beginning of the presentation, how that'll be helpful, is because some of the language features in Swift get heavily used in Swift UI because it really just speeds up your development process. But the idea is you're setting the body variable here to a new text object. And what that means is saying, I say var body equals a new text instance. But the thing is with Swift, you can use this bracket notation to say var body and then just type the text in here, and it just cleans up the code a lot. It has the same bracket notation as the outside, and I just think it's a really nice feature. But what I'm trying to point out is if you just said equals instead of these brackets and then just had a new text, it would still be the same type of thing. So I say var body some view, and then I say text hello. So you can see the text object just takes one required argument for the actual text that's shown up. You can see it now comes on the screen. So you'll notice that this is also centered on the screen. I was kind of alluding to it before, but the idea is Swift UI doesn't care what device you're on. It'll automatically be responsive to the screen size. So this is pretty cool. We're able to render text on the screen, but let's say I want to do a little bit more. Let's spice this up a bit with some images. I want to replace this text call with an image maybe. Let's set the let's replace the text with an image, with a new image call. So the way images work is they access your assets folder and they just load an image with that name. So if I just do an image call with the same type of argument, img, you can see now we get this nice Swift UI logo and it's just centered right in the screen. So that looks pretty cool, right? So we're able to render text in an image, but remember, if we wanted to build something more complex, we can't just have one piece of text or one piece of image optional, right? We have to have like multiple together. So how are we supposed to do this? How are we supposed to render two views at the same time? Let's think about this for a minute, right? How can I render multiple views together the intuitive way? If we think about it the intuitive way, you might think, okay, just stack text and image. But remember what we were talking about with the reason these brackets are here is only a language feature of Swift. You'll see that really something will start to happen. So let's actually try this. Let's put in text call and then an image right below it. So let's try that. And oh no, we got an error. Why is that? So if you let's think about why this error came, right? So the first hint would just be from what I was saying before with the body being set equal to the text. So now what you're trying to do is you're trying to say set the body to equal text and the image. You're trying to set it equal to two values. So try to think about how that would really work, right? But then to go even deeper, let's take a little bit of a closer look into how SwiftUI actually renders its views. So the SwiftUI render is in the end just rendering one view. Like you pass in a new instance of the canvas, and I can show you this when we go into the real app, but it's rendering a new instance of this canvas object. And what it's saying is it's rendering a new instance of this canvas object, and what it's doing is it's actually just looking for the canvas's body, this variable body. Then it's looking for the contents of the body, so the text slash contents. And why I said slash contents is because this text has some like actual stuff for the rendering. But the idea is it goes just the step-by-step fashion, canvas down to body. Now get the value of the body. But now consider what we were trying to do here, right? The text and an image. We're trying to set the body to two things. There's no way for this to render because it's only looking for one child. It found two, so it's just going to error out. There's no way for it to do that. And this goes back to what I was saying earlier about the declarative user interface. Because remember, we tell it only what we need to tell it, and it'll figure everything out for us. But remember, the key term is need to tell it. When we're rendering two views, we need to tell it exactly how we want it to look, we need to tell it what we want it to look in the layout sense, right? Not exactly like pixel by pixel what it should look like, but we need to be able to tell it that I want to render this view over this view. I don't want to like how if you pass in two views, how is the framework supposed to know that I want it to be one over another, or like vertically stacked or horizontally stacked or stacked in front like this? There's no way for it to know with just this without being explicit about it. So the way we do that is by implementing another thing. So SwiftUI has this built in, and it's called a stack. So stacks themselves are just one view, and the property of stacks is that they can take in multiple views. So the stacks can take in theoretically an infinite amount of views, but we're just talking about two right now. It's just got these two views, and what the stack does is the stack has this internal logic to figure out how to render the views together. So the stack renders the views together and returns it as one big view. So think about it in this sense, right? The way I like to explain it is like this. Let's say that you're working for your school newspaper, and they want to put an image on the newspaper, but you want to put two images on the newspaper, but they only have a spot for one. So you can't put both of the images and just expect them to figure out which one to choose, right? You can't expect them to do that. They're just going to give you them both back. They're going to say, no, give me one image. So what you can do is you can go into some collage editor and put the two images together and then send that image. Now it's one image, it meets their requirement, and now you've got two happy images in the newspaper. So I think that analogy kind of explains the collage editor in this case would be how the stack is, and then it's returning just one final output for the body and the canvas. So then again, we're talking about the explicitly denoting what if it's vertically, horizontally, or in front. So SwiftUI has three types: so V stack, H stack, and Z stack. So V is vertical, H is horizontal, Z is in the Z direction. So that's pretty self-explanatory. So let's talk about how we can use VStacks in practice. So let's try to wrap this text and image call with a VStack. So if I just wrap them like this, you can see now we got it. We got hello, and we've got this SwiftUI logo. And what you'll notice is that the hello and the SwiftUI logo, they've been combined into one view. And since the body in SwiftUI is rendering the one view you give it in the center, both of these together as a whole are in the center, not just the image and not just the text. It's their grouped together as a whole is in the center. So that's another thing you should notice. So we've talked about how you can use the system views as well as we've talked about how you can use some of the basic system views as well as how you can combine them together with the VStacks. But remember how earlier we were talking about that builder pattern, but we haven't seen it applied anywhere. So now we get to actually think about it, right? Because this looks cool and all, but what if I want to customize it a bit? What if my app is centered around the green color, the color green, but I don't want just every piece of text to be black, right? What if I want every piece of text to be green? So it's like an odd style choice, but yeah, sure, go for it if that's like how it works, right? But so let's try adding some modifiers. I'm going to reset this canvas back to being just a piece of text that says hello world. So this is something we've seen before, right? We've seen how to render text normally, but let's try to customize it a bit. What if I want to change the color of the text? The way I would do so is by setting the foreground color. So before I go any further into how we set the foreground color, I want to talk about how you can actually how colors work in SwiftUI. So again, when I was saying everything is a view, I meant not just how text and images are views, but also how the modifiers are views, right? Because those return themselves. So that's already an extension of that. Everything is a view. But now we go even further because the color objects, right? You would think like color.green, like if you use some other things, right? It would say like color.green is just some sort of number that returns the value for the color. Meanwhile, in SwiftUI, even colors themselves are views. So it's kind of interesting how you can think that colors, they're like views with special properties that allow them to be extra colors. But in it themselves, colors are just views that are just a rectangle of that color. So if I just wanted the whole back of the screen to be green, I could just say body equals color.green, and it would just be that. But now that being said, how do we actually set the colors of views to be those individual colors, like color.green? So SwiftUI views have two things. They have a foreground color and a background color. So the way I like to think about foreground color and a background color is with text, because the way they work differs based on the type of view. But with text, at least, when I select if like think about if you go to Google Docs or Microsoft Word and you highlight a piece of text, right? Only the background of the text changes. The actual color of the text itself doesn't change. That's what the background color is. It's just all that space behind the text changes color. Meanwhile, the foreground color is actually what you would think of as traditionally being the color of the text. So what I can do to change the foreground color of the text is just by typing .foreground color and set it to color.green right under it. And you can see now our text is green. So this looks great, right? But how do I take it even further, right? What if I want to add a nice border? What if I want to add a nice border around it? Now, this is where the magic of the builder pattern starts to come in, right? Because all I have to do is I have to type .border, set this color of the border, and that's it. So let's add a red border around it. I type .border with color.red. You can see nice. We've got this nice red border around it. This is like I kind of like this Christmas vibe, right? It's got this nice end of the year type thing, relates to what is going on now, right? But maybe I'm thinking, what if I want there to be some spacing between the text and the border? What if I want this text is kind of cramped in with the border? What if I want it to be a bit spacing? So the way you would do this is by using something called padding. So padding is in SwiftUI works the same way as it does in something like CSS, where it's just if I have padding around a view, this is my view, and if I were to just put something next to it, it would just be basically touching. But if I had padding, it just says, okay, anything that's around it, add like a force field around it, I guess, that says nothing can go through the force field around this amount away from it. So that's what padding does. But let's talk about modifiers order, right? Because we're going to be using padding, but let's try to do a small experiment about it. What does it matter if I do the padding after the border or before the border? Like what will actually be my final output based on how I do that? So let's try this, right? Let's add padding after this border function and see what changes on our canvas. So if I just type .padding at the end of it, you'll see nothing visually changed. Let's try to think about why that is. So let's look at this, right? when we call this border function, we're just creating a new view. We're modifying the text view, the original text view we had. We're adding the border and we're returning it. So we can think of this as just one view. Now we're trying to add padding around it. The border is already mixed in, so there's no way this padding is going to affect something that's already been made. So if we really need this border to be wider out here, what I want to do is I want to add this padding to be inside this, to be before the border call. So I just move it in like that. Now you can see the padding expands. And now we've learned that order does in fact matter when it comes to building your views. And this is going to be really useful when it comes to actually creating your views. So let's actually, with that, I want to dive into how we can actually do this in practice. So we've covered the core fundamentals of SwiftUI, but there's a lot more stuff because there's a lot more modifiers, there's a lot more views that you can use system. But I think the best way we can cover this is by creating an app from start to finish together. So let's just do that right now. I'm going to stop my share and just get that ready so that we can open it up. And I will just show you how we can actually do it. So yes, let's just give me one moment. And now I should be good to show it. Sorry, just give me one moment, please. Okay. Here. Okay, so if you all can see my screen, so now I've just created a new Xcode project, and the reason I was hiding that is because there's some personal information that'll be coming up. But the idea is I just set the language to Swift, the interface to Swift UI, and the lifecycle to Swift UI. The main thing you should focus on is interface and language. Lifecycle, it won't affect you because we're not working on with the lifecycle right now, but so you can work with that. So the first thing I want to show you is that in Xcode on Swift on here, you should you'll notice that what'll happen is we have something that we're used to before, right? There's this struct content view, extends view, and we have the body. This is what we've talked about already. But then below here, there's something that we might not be as familiar with. This is this thing called the preview provider. So you'll see in a second, there's a canvas on the right here that shows you what you're actually previewing. And all this is saying is this is controlling how the preview shows. And this preview is a live updating preview. So you can ignore this. You can delete it when you push your app to production. But for now, let's just keep it there. So let's actually continue with making our app. But the first thing I want to talk about is something called statefulness, because we didn't really discuss it in our first part, but it's a very core fundamental. So let's say I had a variable called text, and I decided to be a string, not string equals hello. And then what I do is I just set this text object to just take in text, not text. And you'll see if I resume this, what happens is it builds and this says hello. So now, but it gets a little bit interesting. What if I want to try to change this, right? So if I say on tap gesture, I say self.text equals there. You're going to see an error will come up. And the reason is it'll say self is immutable. And what that means is that you can't modify an object of self inside another variable. And the reason for that is because we haven't denoted this to be a stateful variable. So what does state mean? State, you can think of it as like, just not like United States, not like that, but like state is like either on or off. You can think of it in that sense, but just with any variable. So why do we have to denote certain variables as being stateful or not? It's because the thing is, when this changes, right, we want the view to re-render and say this text has changed its text. So just re-render, figure out how to render it on the screen again. But if we don't denote it as being a stateful variable, SwiftUI doesn't know that it should re-render it. It just knows that it's changed, or it's not even watching it. So if we denote this as an @state_var, and to be honest, SwiftUI makes it really easy, like easier than a lot of the other frameworks I've worked with, to make stateful to make stateful variables, you just add this at state annotation, and now it's telling the compiler or the renderer to say, okay, watch this variable. Anytime it changes, re-render any view that uses it. So now what's going to happen is if I press this play button and I click on hello, you can see the text changes to there. The only thing with the on tap gesture is just saying when it's pressed. So this looks pretty good, right? Let's clear this. And I'm actually just going to begin starting on making our to-do list app. So let's just put inside here maybe to-do list app. I'm going to put an exclamation point. The exclamation point is a little bit weird, but it doesn't matter. I'm going to put it anyway. So what I'm going to do is we want to render multiple views here, right? We've got this to-do list app working, like it says to-do list app, but I want to have some stuff below it, right? I need to include multiple views, not just this one. So let's create a VStack wrapping around this. So VStack. And now you can see nothing visually is going to change in our preview, but then as if I add something below it, like let's say I want to start adding our text field to import our, or to actually input our details, right? I'm going to say add a to-do. Then for the text field, we have to actually provide another argument, not text, not txt, text, and say self.text. You're gonna see an error came up. It will come up, and you actually might have seen a hint as to why the error came in the autocomplete. But basically, it's saying cannot convert value of text type string to binding string. So what does a binding variable mean? So bindings operate similarly to state variables in that it tells and that it is stateful, and when it changes, it'll re-render. But binding is also another sense. It's saying this text field has a variable called this text field has an input, has a text value in it, because you're editing the text value, but we need to somehow access this text value from the parent view, which is this content view. So we need to tell it that in this content view, I have this variable, and we're giving you the variable text field. So I'm saying you're allowed to change it. Because if I were to just pass in the variable, it would just be a read access. But now we're saying you have read and write access. You can change the variable as you please because the text field has to change it. And again, in SwiftUI, it's really easy. You just put this $sign in front of it, and it's just like that. So then if I try again, it'll work. And you'll see down here, it comes up as a text field, but it's not really what we would expect from a text field, right? We would expect it to look like the native text fields. And that's simply because it's declarative. You need to tell it exactly what you want. So I'm going to type at text or dot text field style, and I'm going to say rounded border text field style. So that looks pretty good. Now we've got our text field looking how we want, but we need a button to add it. So I'm going to be using something called a button here. I know it's pretty self-explanatory that it's a button, but before I was using something called an on-tap gesture at the end of it, a modifier for on-tap gesture. And the reason I was saying on-tap gesture before was just because that's the simplest way to create a button. The reason I prefer buttons over that is because buttons provide visual feedback automatically, like it'll dim out your view a bit when they press it. The on-tap gesture just does something on the action. So they work the same way, it's just buttons have that visual feedback that I prefer. So the way buttons work is you provide an action and the actual view. So for the view, I'm going to say just a text that says add, like this. And now you can see the add comes up, and it realizes that it's in a button, so it makes it blue. Then in here, I'm going to say self.text equals blank, because at the when I add the thing, maybe I want to clear it. So let's actually take a look at how well this works, right? If I press this play button, if I type something in here, I press add, and now you can see it deletes it. So we've got the editing and working. Now we just need to have some sort of way to add it to the list. Before we do that, I want to make this button, this add button, look a little bit better. So I'm going to add some padding. Padding can take some arguments too. I can give it this 5. I can give it a background color of green. And this background can be any view, but if I specify color.green, then that means that I want it to be a green color. Then I'm going to specify a clip shape, and this clip shape is you can think of a clip shape as being a cookie cutter. So if I have this pan of cookie dough, right, and I say, okay, I want all my cookies to be stars. I take a star cookie cutter and cut into it, and now I've got that cookie dough in that shape. But now let's say I want it to be a circle. I put that in there. What if I want it to be a rounded rectangle? So this clip shape, you can think of as being a cookie cutter, cutting it just to that shape. So you see when we had it as a circle, it came as a circle like that. So for rounded rectangle, we have to provide this corner radius argument, which I'm just going to set to 5. And then I'm going to add a shadow. And the shadow, I'm going to give it a color. And color.black will have the opacity of just 0.25. I'm not going to have any X and Y offset, but I'm going to have the radius set to 6. So this is how that works. And you can see how we're just stacking all these modifiers on top of each other. Then finally, I'm going to set the foreground color to dot white. This is just the text color. Something is weird happening. Color dot black, maybe. Yeah, okay. I guess it wasn't understanding that it was a color. So now you can see we've got our button and it's looking pretty good. If I play it, you can see we've got that tap action too, where it dims it out while it's when it's being clicked. So let's actually add some functionality. Actually, before we do that, I think I might want to have this text field and the button right next to each other. So the way we can do this is we can use SwiftUI's H stack. So the thing about stacks is that you can actually put stacks inside stacks. So this is where you start to build those really complex interfaces. So if I say H stack here, and I just wrap both of these inside the H stack, fix the indentation, then now you can see it works perfectly fine. They're both right next to each other. SwiftUI figures out how to scale everything. I don't like how it's right up on the margin, so I'm just going to add some padding. And now that looks pretty nice, or it will look pretty nice. Yeah, now it looks pretty nice. So that's already looking great. It's one thing I guess is not the best about this so far is just the fact that this to-do list app is our title, right? We want our title to be big. It's like the introduction to our app, right? We want to show this is a cool to-do list app. We need to give it a big title. So the way you specify that is just all these text things have a font modifier. So I can say .font. And what's going to happen is another language feature that I really love about Swift is that you can just type. It infers that this is the font type, so I don't have to type font.title. I only really have to type .title, and it's able to figure out based on the inferred type that it is of the title type. So this looks pretty nice. Text, we've got this, but now we need a way for actually listing our to-dos. So I'm going to create another variable. I'm going to call it @state_var to-dos. And this is going to be a string array. And the reason for an array is because we're just going to be storing multiple to-dos. And I'm just going to initialize this as a blank string array. Or actually, I'm going to give it some values like do the dishes and clean the car. Clean the car. Good. So we've got our to-dos set up. And now how are we going to display this? So SwiftUI makes this like, honestly, like, it's not even funny how easy it is. You literally just type list, and now you've got a list. And this is like the table view from UIKit if you've used it before. Then what we're gonna do is we're gonna use something called a for each. So for each has some weird syntax at the end of it, which I'm not it's like, to be honest, even I'm not exactly sure as to why it is, but you just, I guess, follow along. So you have to type this ID. So there's obviously going to be places on Google where you can figure out why this is. So the idea is you say something like this. You say for each in self.todos, and you say, so you're basically, oh, I meant to say in. So you're basically iterating through this self.todos list and you're putting them out. So you don't actually need to wrap ever need to wrap a for each in a loop. What a for each is just going to do is it's saying, like, what if I wanted to duplicate this one view 20 times? But I don't want to have to copy and paste it 20 times. I just use a for each loop. It's the same way you would use a for loop in regular programming. So you would use a for each loop here and say for each in self.todos, and then I'd say to do in, because this is like our like the current index or the current to do. So then what I can say is, for now, I'm just going to say text with to do. You should see what is going to happen is if I resume this, is we're going to get our two to-dos right under here, right? We got do the dishes and clean the car. And the reason I wrapped it in the list and not in just the regular for each is because when you wrap it in a list, you get this really nice scrolling thing. So you can be able to scroll through it and everything like that. So it all works. So This looks pretty nice, but remember, to-do list apps have an idea, right? It's telling you to do something, but you have to tell it, you have to be able to tell it that I'm done with it. So I want to try to add some sort of checkbox system. But the thing is, this is starting to get a little bit cluttered. I don't want to have all of this in just one large content view. So this is where we start to get into the part of like abstracting out views or extracting out views from in here and putting them in separate views. So let's say I create I'm going to create a new view. I'm going to call this struct to do item. And what this is going to say, this is going to hold all my code for creating my to do item, not var body. Sorry, my typing is slower today. Var body is some view, and I'm just going to have a text with hello, not j hello. So actually what I'm going to do is I'm going to have a state variable up here. Now state variables, one thing I can do, I'm gonna say to do is a string. If you specify the type but leave out the value or omit the value, what you can actually say, you can say my parent class or wherever this is gonna be implemented in can just pass in the variable. So if I say at state var to do is a string, then in here I type to do item. Then I have to actually say that this to do variable is equal to this to do. It's going to get, yeah, it kind of gets a bit confusing, but you're going to see that nothing will visually change on here. At state var to do equals is a string. 1 second. Let me just, wait, sorry. I'm just checking on something. Okay, so I'll just type. So it should be conforming to the protocol of view. I'm not sure why it was saying that. To do item, to do is to do. So this should work. I was not sure exactly why it was failing. Let me try building it again. Agent self dot to do's. To do item. Okay, let's just move on from this. Basically what I was trying to show is that if you put a view in something else like this, what'll happen is it'll you pull out a view and you put it in. If you pull out a view, you have some of the more system views in there, you can actually call it from other views. So let's try again and create a to do item here. And what I'm going to do is I'm actually going to create another oh my god, wait, sorry, I was being really dumb. I just have to say that this is a view. Okay, that'll work. I don't know why I wasn't realizing that. Sorry about that. We all make mistakes, I guess. So now what you're gonna see is that it all comes up as being the same thing. So this works. So now what we want to do is we want to create a checkbox. So there's no built-in, or there are built-in radio buttons, I guess, but they're not really what I'm looking for. So I'm just gonna say checkbox extends a view. And what we're going to use is we're actually going to use a binding variable here. Or actually, I'm just going to say a state variable too. Oh, no. No, yeah, so I'm actually just going to use a state variable here. So I'm going to say state var checked is a Boolean. And I'll explain why I was going back and forth on the whether I wanted it to be a binding or state, but we'll cover that. I'll explain that when we get to it. So what I'm going to say in here, I want this to be a button again, action, right here. This is our action. And then we need to make sure that we set the actual view for the button. And this view is just going to be an image. So what is this image view? So there's this, so system name is a set of images. So system name, the reason I provided it to be system name and not just actual image name is because image name will look through your assets.xcode assets, but I don't have anything in here right now. So if I say system name, what I can actually do is I can look for any of the operating system symbols. So if I look for an operating system like checkmark.circle, now all like iOS and the Mac OS and all of them have these symbols built in. So if I just call it, right, what's going to happen is it'll do that. So what I'm actually going to do is I'm also going to say check.toggle in the button. So toggle is just saying it's equal to whatever the opposite is. So you can also represent it as saying checked equals not checked. Then finally in here, I'm going to write this out as saying an H stack with the text. And the reason I'm using an H stack is because it's a horizontal stack here. Oh, I need to make sure that this is false. Give it a default value. And that should be good. Now, if I resume this, let's play it. Oh, I don't need to play that, sorry. You can see that now the checkbox comes. But let's actually make this interactable with this Boolean. So the way we do this is actually very simple. You just simply have to give it a ternary operator. So if I say checked, and you're basically saying if it's checked, return the check mark circle. If it's not checked, just return the regular circle. And we already have the logic implemented for toggling the check. So now if I play this, you can see they automatically go back. If I click on it, you can see it becomes checked. Now the table row is kind of shining. So the way I would just disable that is by saying button style is plain button style. So let's do that. And then there's one last thing I might want to do is maybe change the foreground color to dark green. And then also I'll set this to resizable. So actually let's look at this for a second. So if I type dot frame here and I say width equals 50, or I'm going to say 25, right? I want to change the size of this. I'll say width equals 25, height equals 25. Now what you're going to see is nothing actually changes on here. We kind of made the spacing more, but the size didn't change. And the reason for that is because in SwiftUI, we have to specify images to be resizable. It's like an extra way of safety to make sure that you don't mess up the aspect ratio on your images and things like that accidentally. So now if you take a look at this, right, I can click on it and it's all looking pretty good. So now we just need to finally implement the logic to add a to-do. And the lucky thing is it's really simple to do so. I'm going to make this just an empty array now. So if I just type string here, string, put this here, then I just say self.todos.append, and I just say self.text because that'll be the text field value. Now you can see everything will simply work. Like this is the core of our to-do list app. So if I play this and I type something in here, add it, it gets added to the list. This looks nice, right? But let's say this is not very user friendly. Wait, what if I want to be able to what if I want it to look a little bit better when it's adding? I want to add some animation. And then the lucky thing about SwiftUI is animation is also like dead simple. You literally type .animation, and maybe I'm going to use the spring animation because spring is one of my favorite ones. And you literally just add that to the end of the list, type it in, and you can see everything is added in, is animated in. So what we could do is we could take this a little bit further. I want to have some time for questions at the end because I saw that there were a couple, but I'm going to do one last addition to our app and basically say, what if we want the user to be able to remove a to-do? Like when they're done with it, or it's been a while, we want them to be able to remove a to-do. So let's try to do that. So what I can do is I'm going to say, I want them to be able to long press the to-do, and when they long press it, it deletes. Now, lucky for us, SwiftUI has an on long press gesture. So then inside here, we just type the code that we want for it to remove. So we want to look for their current to-do, which will just be this to-do. And we want to say, find it in the list and delete it. So what we need to do is we need to actually find a index. So I say let index equals, and then I'll say, where is it? It's to-dos. I should probably use self.todos here just in case self.todos.first index, and I have to say of to-do. So then the issue here is going to be that this is going to be called an optional value. So optionals in Swift, if you haven't used Swift before, it's like saying this might be true. Like optionals say that it doesn't have to be real. And by real, I mean it could be null because there might not be this value to do in there. Like Swift doesn't know that there's going to be this value to do in there. So what I can do is I can actually say if let. And what if let is saying if it is there and if it's not null, then perform what's inside this condition. Then I'm just going to say to-dos.remove and then at index. So then this is going to be our completed app, and you can see it's got the animation for the removing and everything as well. So if I just type this in here, add, right? Then let's say I want to remove this one. You can see it deletes it. I want to remove this one, it deletes it. Just click and hold, long press. So, and we can obviously enable and disable the done or not. So this is like to put it simply, how our app was built, right? Let's talk but this is really how you build an app from scratch in Swift UI. Now obviously obviously we need to keep in mind that this is very simple and it's not really got very much other things. Like possibly moving forward you might want to say like add an alert when they're deleting it or something like that. But the idea is the to-do list is kind of like the de facto when it comes to creating kind of UI tests. So that would be a good idea to kind of walk you guys through creating something like this. Now with that, I want to finish off what we were talking about before about how we can actually, I just want to finish off by just covering some final points about how you can actually use Swift UI in your real applications. So what's next, right? Oh, sorry, we talked about this slide. Okay, so resources to learn more, right? One thing I just want to make a note of, just for programming in general too, is like Google is your friend. If you have a question about something that's going on, you can Google the question and a relevant website will come up giving you tutorials or information. And some of the best places that I found so far is Apple's documentation. Their tutorials especially are really good. They have that, it's kind of like what I modeled my introduction with a canvas off of, but they have like this like the animated stuff at the side to show you what's going on their website. So if you take a look at that, that'll be great. Then next is Hacking with Swift is another website. Ray Wenderlich is like a website in general, but their Swift UI section is also really great. Then obviously Stack Overflow and the internet in general, just for questions. Then the other option you could have is you could contact me, and my email is down here, or this is my team email. So you can just contact FrogForce at frogforce503.org and just ask for me or ask for someone, and they can lead you to me and we can get in contact so that we can discuss more about Swift UI and how we could use it in applications. So with that, I just want to say thank you, and I'll answer any questions that you have at this time. But again, first, I just want to say a big thanks to Team 818 or 1816 for hosting, because they did a great job hosting. So yeah, I can leave this email slide up for a second and then.
Perfect. Yeah. Thank you so much, man. Amazing presentation. Really well done. We actually do have a few questions, so that's always fun. We were asking, one of the first questions we got was, what was the learning curve of Swift UI like? How difficult is it to learn?
So one thing I found when I was learning Swift UI is that it only took me about a month to learn initially, until I was like comfortable with really like just being able to kind of figure everything out. And the reason for that is because Apple's documentation is just so well written that if you have any questions, you can just go there and they can find it. But for the learning curve, I would say it's a lot easier than some of the other frameworks. And that's simply because it's really new. So there's not as many things to learn. So I guess the answer to the question is it's not very big yet. I would say if you're trying to learn it now, then learn the new features as they come, because once it gets bigger and bigger, it's going to get harder to learn. But at this time, it's very easy.
Sweet. Another question. What does one need in order to get started with programming in Swift UI?
Yeah. So I guess this was kind of, it might be so you should have or not, it doesn't need to be a very strong understanding of how the Swift programming language works in general, but if you do, that'll be really helpful. But I guess the first thing to point out is that you do need to have a Mac computer running Mac OS to create these apps, and you have to have Xcode. So if you don't have that, it might be a little bit of a struggle, but otherwise it's really just you need to have Xcode and Google at your disposal, I would say. Just Xcode and an Apple developer account, but you can get the free one and it'll be perfectly fine. Sorry.
Actually, I have a question about that. So the free Apple developer account, have they changed it where you can actually publish devices without it?
Well,
Or is it still?
so you can like anyone can publish to their own, like your, like if you have your personal phone and you plug it in, you can publish to that, but you can't, I mean, yeah, even they still make it so that you have to pay I think it's $100 per year to upload to the actual app store. But if you
Sweet.
just want to learn, it's free, and use it and put it on your device, it's free.
Awesome. Okay, so another question from chat. What is the point of the sum keyword?
The sum, well, okay, so to to be entirely honest, I'm not sure. I just know that that's the way that they do it. I'm sorry I can't answer your question about that. Sorry though.
Sure, no worries, man. Okay, another question. Um, so someone asked, what is the like? So this is only available on Mac OS, right? You can't program this on Linux, Windows, Android, other things like that.
Well, so you can run Swift on Linux, but I'm not sure about the capabilities like Swift UI on Linux.
Okay.
But but not Windows. No.
And is there another language that you feel has like a similar syntax to Swift, or is it completely unique?
It's not completely unique. I was strong in Java when I was starting out with Swift, and I was able to learn Swift very easily. It's the only thing that I found very confusing at first was just the concept of optionals. But syntax wise, it's like similar to, because they it's similar to, I guess, C type syntax, or so like you'll see in Java, JavaScript, those types of places. And also semicolons aren't required, I guess, is another note.
Do you have a recommendation for like something you would look at for a person moving from like Java to the Swift, because they're similar languages?
Yeah, I would say maybe I would just maybe say like kind of jump into it, because it's not too different, in the sense that um I would actually say it's probably more similar to JavaScript now that I think about it, compared to Java with the whole type annotation thing. It's quite similar to TypeScript with the way they define types, if you're also into that. But um yeah, like it's really just, I guess, just jump into it. Look up the same, like Hacking with Swift, um uh Ray Wenderlich, Apple's documentations, YouTube, Google. They all have great resources to learn, even from scratch or from another language.
Perfect. And last question, how has your team really used Swift on your robotics, or have you done that? How's that been used?
Well, so I know that my team has been looking, because we have a scouting app. We do have like scouting apps and websites, and I know that the programming team, or like the other side of the programming team, has been working to try to create mobile versions of those apps. I'm not sure if we've actually gotten much deeper into it, but I think this if we plan to do iOS only or something like that, this would be a great framework to work with for our team.
Perfect. Well, thank you so much for your time, man. That's all the questions that we have. Amazing presentation. Really enjoyed it. Thank you so much.
Yeah, thank you guys for hosting. I really enjoyed.
For sure.
That was great.
Bye. Thank you.
All right. So our next presenter will be me finding the document. 1 second. Because this is not accurate. Yeah. Oh, from our team. How to make your code work with Ryan, Richik, and David. And we'll get to that in a few minutes. Are they all here? Looks like might be missing. Oh no, everyone's here. Perfect. How you guys doing today?
Hi guys.
Sweet. It looks like Mr. Dave's just logging in. Ryan's logging in. We're looking forward to your guys' presentation. Should be super interesting. And once you guys are all in, you guys can start whenever you want to.
think Ryan's just logging in. All right, awesome. Should we go ahead and start?
Yep, you can go ahead and start whenever you want.
All right, so welcome to our presentation, how to make your code work, or how to make effective teams that create effective software.
Sorry, I'm muted. I'm Ryan Koo. I'm 1816's software lead for the 2020-2021 season.
And my name is David. I am a mentor for the Green Machines programming team.
And I'm Richard. I'm in software engineering on 1816, and this is my third year on FRC. So the mission of Team 1816 is to create bold, confident leaders who transform culture to promote value and celebrate STEM.
And our vision is to bring FIRST to new audiences, to be a role model for gracious professionalism, and to use our experience to expand FIRST and make FIRST available to all. Our core values are respect, trust, inclusivity, commitment, and joy of life.
So today we'll discuss some project management skills that boost the productivity and efficiency of your software team. Then we'll walk through best practices to make your code more reliable, resilient, and debuggable for a build season with fewer headaches and more time to develop new features.
So first I will talk about project management and workflow. So before we actually get to writing any code, it's important to organizing work and planning ahead ensures that you know what you're doing, what you're going to do, and you can use your time more effectively and efficiently. So then that brings us into why is project management important and what benefits does it bring to your team? So organizing your work considers the bigger picture and sets realistic and achievable goals for the team. It facilitates communication for maximum work efficiency and success while minimizing your risks, like eliminating idle time and ambiguity. So everyone has sort of an idea of what's going on for the day and what others are working on as well. And what that also ensures is that it prevents multiple people from accidentally working on the same feature. So then you have more lost time, and then sort of everything starts to break down. So how should a team go about organizing a management system, and what tools could they use? So there are two tools that you can use to organize your workflow. And one is using Kanban boards, which provides a glanceable visual overview of tasks. And what that does is it sort of visualizes what needs to be worked on, what's going to be worked on, and how much you've accomplished. And it's essentially a tracking work in progress, which means you know exactly what everyone else is working on, and it makes your backlog controllable. And I'll talk about your backlog later in the presentation. And Kanban is organized with specific cards of like to-dos and in progress. And as those cards pile up in the done column, it's sort of satisfying to watch, and it sort of boosts your team morale to continue, progressing and keep working. And another organization system is using Scrum, which divides your work into time-based sprints. And what sprints are they're a goal with the intent to completely finalize a feature in a relatively small time box. And that ensures that teams are prioritizing specific tasks, ensures focus, and makes your list of to-dos more digestible and distributable.
So the first time you're setting up your project management system, it's a good idea to sit down and have a brainstorming session with your team. So what do you see coming up? What tasks do you need to do? So you compile the list of these tasks. This becomes your backlog. So how do you create good tasks or good issues, as we call them? Issues should be three things. They should be specific in the task that they describe. It shouldn't be called shooter, but instead it should be called create the subsystem class for the shooter or calibrate the shooter velocity. They should be actionable. It should be a bug that someone can fix or a feature that someone can code. And then they should be relatively short. Like they shouldn't be long, broad tasks that take a long time. Ideally, they should take no more than a couple days between beginning the work and completing it. And this duration of time is called your cycle time.
Okay, and we'll just show like a live demonstration of how you might be, what your project board might look like. So this is for our 2020 season, and as you can see right here, we have 4 different columns: to do, in progress, testing, and completed, or just done. So, so as you can see, the contents of each of these columns have these little cards right here, which are called issues. And if I go over here, this is when you're creating an issue, this is what you might see. And I'll sort of walk through the creation of like, let's say you're creating a new feature for your code, and how you might go about specifying what kind of information is going to be going into this. So if you see right here, you have your assignees, and this is just sort of identifying who's going to be working on what, and how many people you can assign up to 10 people in this issue. So let's say I'm going to be working on this, and then now you have your labels, which clearly categorizes your issues by types. Let's say this is a feature for addressing a bug, or let's say you're creating a new feature to add onto your code base. So let's say this is an enhancement, which is how we organize ours. And you can also label it by the area. Let's say this is like, you can label this as a subsystem an issue, or you can also highlight the priority of this issue. Let's say this is really high, everyone should be working on this, or someone should be getting to working on this as soon as possible, something like that. And let's say something is, so you need to program the turret for this, or yeah, sure. And then you have your milestones right here, which are deadlines essentially. As you can see right here, we have various deadlines that when passed by, and this sort of ties in with the sprints in the Scrum framework, and you're selecting your issues for a fixed time frame in which your team is going to be working through that time frame and then completing it by the end. So let's say this is an issue you want to get completed by end of preseason. You probably don't want to have these milestones like 2 months in advance. I guess you could, but you want to set the time frame for this as really short as possible. So like a couple of days is usually the max that you want these issues to be living for. And then we're gonna go ahead and add this to our project board for the 2020. And then for title, you want to be as specific as possible to ensure clarity of like amongst your team of what you're going to be working on. Let's say I said this is turret, but so you want to create unit like on glance, everyone knows what this is going to be. Let's say everyone knows what I'm going to be working on this issue. I'm going to be creating unit tests for testing specific parts of swerve drive. Like let's say one unit test for one of the motors in the swerve module, and then another unit test for the another motor for the other swerve in the swerve module. And then when you're creating this issue, you'll see that you'll see this board and all that. And then we're going to go ahead and go over to our project board and refresh that. And then you'll see right here, it popped up in the to-do list. And in the progression of your project should flow from to-do, from creating and assigning the issue to in progress, which notifies the team that someone has picked up the feature. And then you have this optional column of testing, which we added, and then going to completed, which means the feature is ready for deployment to the robot, and etc. So another cool thing about this project board, in order to ensure focus on a specific task or set of tasks, which also aligns with the Scrum framework for sprints, is you can click on these milestones, and what that does is it filters your project board for specific tasks for this week. Let's say we're on week 10, and we have these four features to work on. And what this does, it helps your team stay on task on the current development of the development flow, and it helps prioritize tasks. So if Richard, you want to add anything to this?
Sure. So another important thing is we take a look at the to-do columns. A lot of them don't have assignees in the bottom right, and that's perfectly fine, because in your to-do you can create a backlog of tasks that anybody can claim. But by the time it's in progress, it should definitely have an assignee, because then you know exactly who's working on it.
Yep. So
I'll add one thing too, real quick, about like the testing column. One of the reasons we added it was for a couple of reasons. It's always good to have someone else like test your code. So that way you have other team members that will get a chance to see what that ticket was about, understand what was done. So that way you're more, your rookies can learn what's going on and help make progress with stuff. And it also helps put a checkpoint. If something breaks down the road, you know that, well, someone tested it, so it worked at one point. So what happened?
Yeah. So another important thing to note is that we just showed an example of how a team might organize their workflow, but there isn't just one way to do it. As long as it fits the needs of your teams, personalizing your organization to meet your team's needs, for example, like small teams versus larger teams, is really crucial. And another thing is making sure everyone's on board with your chosen project management strategy is it's not going to work if your team's not on board with it. It's important to check in with your team once in a while to see if they're still committed, and if they're not, trying to figure out the reason why. For example, when it was my first year on the team, we tried a different project management system, and not everyone was entirely on board with it, so it sort of fell apart. And sort of by the end of the season, there wasn't really, that initial organization wasn't really evident anymore. And once you've identified why not everyone's committed to this organization system, it's then your next step forward is to how to increase this commitment within your team, and what do you need to modify in your current system in order for this to work.
So you're applying that same engineering design process to your own project management, where you try it out, test it out, identify flaws, and modify it to make it work better for you. All right, so next up, we'll take a look at writing more resilient and safer code. So what is safe code? Safe code means that your system is much less likely to fail, and when a component does fail, your system continues to function to an extent. So there are two key components to writing safe code. First of which is writing well-structured code. Your goal should be to write dry code. Dry stands for don't repeat yourself. Removing like as much redundant and duplicate code as possible leaves less room for error, and if there is an error in it, it's easier to fix in all places by just changing it once. Extract reused code to methods and classes, and your IDE might even have a refactor for this, which makes this really easy. Abstraction ties right into writing less repetitive code. Abstraction is all about thinking about problems at a higher level. When you piece together more complex components, instead of building from the ground up every time, it's easier to solve problems and harder to make errors. If the construction industry couldn't buy prefabricated I-beams, we would have a lot more faulty buildings. And encapsulation ties in with abstraction. So encapsulation is all about hiding internal behavior to higher level code and exposing only what endpoints, which are methods and data, are necessary to do the job. You might have heard this called black box design. Encapsulation boosts the safety and security of your code by making it impossible to accidentally modify a value that shouldn't be modified. The second pillar of writing safe code is fault tolerance. There are two components to writing fault tolerant code. The first of which is graceful degradation. Graceful degradation is when your code doesn't fail when running on different hardware, and instead moves to a lower standard of operation when something is missing or faulty. A perfect example of this is autonomous fallback. For example, if you're running a more complex auto that requires your robot to run a path and it requires the gyro sensor, but your code can automatically detect that you're not receiving a signal from the gyro sensor, or the gyro sensor is reporting an error code, then your code can smartly switch to a much simpler drive straight auto that doesn't require the gyro sensor. And instead of just not moving at all, you're still getting those points for crossing that line. The second key component of writing fault-tolerant code is failure-oblivious processing. This can take many forms, but in robotics, this primarily centers around mocking your hardware. Failure-oblivious processing is all about like continuing as normal and not noticing that something is wrong. So with mocking or ghosting your hardware, if certain components of your hardware are missing, let's say motors or solenoids, you can create virtual classes that simulate your hardware and allow you to continue to run code as normal without littering your code with if checks everywhere. We'll talk more about this on the next slide. And furthermore, manual overrides are a good idea for any critical automated systems. For example, if you have a turret that relies on vision to aim, it's always a good idea to have a manual override for the driver in case that fails.
Yep. So let's look at a code example of an application of all this fault tolerance and graceful degradation and failure oblivious processing. So this is Robot Factory, and what Robot Factory is it's essentially a class that reads a configuration file that we set up for each robot we deploy our code on, like our competition and practice bot, and also K9, which is a mini bot that will showcase later in the slide in the presentation. And essentially what we utilize Robot Factory to access all our hardware, like motors and solenoids. And for each robot, we have a different configuration file, and we can disable and enable certain hardware through those files by just manipulating one value. So walking through this code, right here, the return type is this is the method of how we create solenoids. And the return type is iSolenoid, which is an interface. And an interface is basically a template for a class. And it just defining our return type as an interface, it guarantees that the return value could be one of multiple classes that is implementing this iSolenoid interface. So, walking through this, if the solenoid is defined correctly, it should return a class called solenoid impl or implementation, which implements this iSolenoid interface. And this is our way of constructing a real life solenoid object. So what is a class that like we input right here the PCM ID and the solenoid ID, and then it starts actively communicating with actual hardware. Now, this is one part of the logic. If we move on to the next, let's say if a subsystem or component is disabled or it's not defined, as you can see right here in our in this condition, Robot Factory then creates creates ghost hardware, so the code doesn't start yelling at us and just continues as normal. So what this ghost solenoid class is that it's a virtual hardware. So it's sort of a parallel to this solenoid implementation class, except that it's not actually communicating with real hardware. So what is the point of all this? In FRC, null pointers are a common exception, especially when hardware is missing. So what this does is just hardening our code against all those avenues that might create problems with null values. And then another quality of life thing, if you see right here, we have this @non-null annotation. And what this does, it prevents null pointer exceptions by having your development environment warn you if your return value, such as like right here, can potentially be null. And when you designate it, when it shouldn't be returning anything null. So it's just telling you, hey, this thing is returning null. You should probably do something about this. So that's just another way to alert yourself that you're potentially vulnerable to a null pointer exception right here. And its counterpart annotation at nullable makes sure that any code calling this method properly handles a null value. So let's say this indeed does return a null value and it's following intended behavior, then something using this method, it's warning you when something is using this method that it should account that this return value could potentially be null. So we're going to see these principles in action with Mr. Day. We're going to show this code running on an actual robot. So if Mr. Day, you want to share your...
You can stop sharing so I can share. Okay, so he mentioned one of the reasons why we do this is our team builds 2 robots every year. And the programming team, we don't do one robot and then the second one. It tends to be that each of these robots are being swapped back and forth between different states. So as we're coding things, we have different robots that have different, different pieces of subsystems that are completed on them. So one of the things that we always ran into is your teams will sit there and you'll have to go into the code and start counting a whole bunch of chunks of code out. And then, we'll put it back later on and inadvertently you forget that. And I think it's a really bad habit to get into because something like that may happen at a competition. Someone will go into the code, decide they're going to quick comment something out because they're going to go test it on the practice field. And all of a sudden you forget to comment it and you go out to a match and all of a sudden your robot's not working. So the reason we designed this whole ghosting thing, it's a lot like mocking. If you're doing unit tests and familiar with that, it's like creating mocks. But rather than that, it's all just right in the code. So this different configuration on these robots allow us to go back and forth. And this is a robot that you're looking at that I actually built for myself. I've only been mentoring with the team for about 4 years. So I built a robot at home so I can play with it and learn how to code everything to help people out. And this year it's been really handy since we're all in lockdown and we can't get into our school to do things. This robot, I've deployed last year's code to it. So our normal robot it's got a shooter, it's got a turret that's, it's got the different motors for the drivetrains. I think all in all, we've got roughly around 16 motor controllers on the robot. And this robot only has 3. I've got a left, a right, and then I've got a turret that's up on top. And so without any code changes, I could just deploy this to this robot. I'm going to enable an autonomous path right now. And you can see it, really loud. But you can see this is running the code directly as is. We're not getting any faults. There's no errors that are showing up in the logs. It allows me to test some of the basic functionality of I've got vision, I've got a turret essentially and 2 wheels, so I can actually test some code here that way. And we've been using it on the team just as they're coding stuff up this year. During our meetings, I'll take and deploy it to this robot and we can test things out just to make sure it works. It's the end of that demo. I will stop.
So what Mr. Day just did there is we have our actual competition code on there and he's running that, and then what it's doing is when we're running a more complex spline, it's sort of recognizing that it doesn't have those components necessary to run the autonomous, so then it's falling back to a more basic one. So then with that run, this brings us to advanced debugging and logging section.
So let's talk about Badlog. Badlog is a logging library created by an FRC alumni from FRC 1014 that tracks numeric values throughout the lifecycle of your program and then publishes them in a visual format to allow you to easily analyze it and notice errors. So there are 2 parts to this. There's the library that you add to your robot code, which is available at the first link. And it's really easy to add to your robot code. You just go to your build.gradle file, you'll find the dependencies block, and you add this one line, the implementation, and the dependency link. And then the second part is the command line tool for visualizing the output of the logs. You just download it from the GitHub link and it's available on all platforms.
Okay. So this is another code example of how we might use Badlog. So what bad log automatically tracks certain values throughout the life cycle of your robot program. And then it periodically saves the values every loop when you call logger.log. For example, in your robot.java class, you're going to have the periodic telya, periodic autonomous methods in there, and you're going to call logger.log there. And then what that's going to do is it's going to update those values every loop. And setting it up is really easy. Right here, you have the variable mlogger is calling mlog.init, and then your file path. And what this does is just initializing your log file and then creating topics. So going on to the creation of the topics right here, you see there's various methods that you can call to create various sections, which then when you boot up the Battlelog Viz, it's going to show up, it's going to visualize these topics in a graph format. And if you look over here, these weird arguments with the double colons are called suppliers. These suppliers are interchangeable with this, which is called lambda notation, and they're just references to getter methods in your subsystem classes. So then Battlelog uses these references to or suppliers to track and log these values. And then you see all this green text right here with the turret/desired and turret PID heading /robot is just configuration for like the title of your different sections. And then right here you see native units, degrees, and all that is just specifying the degrees for your the axes of your graphs. And these native units here are just the native units for the Talon SRX, I think, which are in ticks. And then if you look over here as well, this join colon pigeon/heading is just joining this heading section that we create right here. So right after Mr. Day ran that code on K9, we were also logging through Battlelog, and I think Mr. Day should have pulled the Battlelog file off of there and then ran it through the Battlelog visualizer. So Mr. Day, if you want to pull that up.
You just stop sharing first.
Oh, sorry. Oh.
Okay, so what I'm going to show you is this is actually off of that example repo in his slide. It's just a test program that we created to demonstrate how the logging works. So this is the output of that program. One of the reasons why the logging is really important is one of the things we ran into this last year with our code is we thought that we had our IMU, we use the pigeon from CTRE, and we thought we had it in a relatively stable position inside the robot. But we discovered that when we started driving through the switch area with those dividers on the ground, our turret stopped auto aiming and following properly. And we ended up putting some things into Battlelog here to do this. So that is the example program that's up there, sort of simulates tracking a turret while the robot's moving. And then it also, if you push your controller joystick 1 button, it will actually reset the pigeon to simulate a fault. So the log, I mean, we actually put the date timestamp for the file name. So if you look at the sample, you actually see how we can do that. This is helpful just because you have a record now of what's going on. We use this logging a lot for PID tuning. So that's one of the things we do right at the top. We print out what our current PID values are. That will allow us to go back through time and decide that, yeah, was this better? Was this worse? We have a really easy way of looking at it. The other thing that's important in here is we put logging for timestamps on here. And there's one line that's inside of here that will actually put the timestamp on this x-axis, which makes everything more sane. If you don't do that, Badlog will log every time you log a new file, it puts it. So you have variable times, so the ramps, slopes look weird, all things look weird. So that's something bare minimum I recommend. You can tell if you're overloading your program. If you saw the presentation we did yesterday about vision, and we mentioned don't plug a camera into your RoboRio. You will see your robot loop time go up quite substantially when a camera is plugged into that and you're trying to use it for the driver station. So this gives you a handle on how quick your robot's running. You have all this information in the driver logs, but what's beneficial of having it here is you have it with all the rest of your data. So you can look and say, oh, hey, our RoboRio was having a really hard time processing and we had loop time problems. Then you go look at your other data and you can say, oh yeah, this all this stuff started behaving poorly. So we have to improve our loop times. So just to show you what's going on in the graph here, these are the two things we were tracking. So one is the pigeon and one is the turret position. So what this actually is doing is the difference between robot and turret. This had to do with calculations inside the program. It was basically saying that while the robot's moving at this angle, during this entire run, I should mention too that the robot was sitting on basically a turntable, and I was spinning the robot while I was running the program. So these should follow each other. So the one to the turret is I was doing calculations to figure out where the turret should be based on the robot's heading and just overlaid the two of them. So it becomes very evident if there's a problem in your code or something of what it looks like. But you'll notice that things are, that we're moving and the turret is here. This turret output is actually the motor controller output. So this is a position that we're feeding out to the turret to try and follow what's going on. And so it's got the desired and the actual. And this HTML graph that they created is amazing because you can just click on and turn off one of them and say that I just want to see what was desired or I want to see what's actual and turn that other one off. So if you start combining a whole bunch of things on the graphs, you can turn them on and off. We generally do the drivetrain on one graph, and we'll put all the motors that are on there so you can see what's going on with each one of them. And you'll notice that what happened here is all of a sudden it's like, this looks abnormal right in through here. And you can actually zoom in onto a part of the graph, and the entire graph, all of these things will zoom into the same time scale. And you can sort of see what's going on here. And this is also printing out the error of our positioning in the actual, here's what we're telling it to do and what it's doing. And it's like, oh, it's a big error right in here. And the robot has to try and catch up to it. And so you can see what's happening. But one of the things we're like, well, what was causing this? This all looks really flat. And sometimes you want to log additional things to make it more evident. So this error right here is the status of the pigeon. And if we were to reset the zoom, you have to go find where you zoomed it in on, it becomes really evident inside your code that a 2 status for the pigeon means that it's operating normally. Number 1 means that it's initializing. And this is actually something that we ended up seeing in our robot. We went over those bumps, and all of a sudden we saw that we would lose the pigeon like this, because if it has a lot of vibration, it says it's way too much and it wants to recalibrate itself when things become stable. And you can even notice what's sort of weird about this graph, and by doing this, you actually learn a little bit about the devices, because they don't talk about this in documentation. It looks like this thing's back and operational, but it actually wasn't. It really didn't get happy until a good 3-4 seconds later. So even though the status was okay, it was still initializing. Okay, that's all I had. I'll restore it back to you guys.
So yeah, it's really all just all self-automated. You just add a dependency and then create the logger, add values to it, and then it'll periodically update. And then what it'll do is give you this really nice visualization of what's exactly going internally on your robot. As you can see right here, like Mr. Day when he was talking about the mapping or graphing the intended or desired left velocity, right, or like your desired heading, pigeon heading versus your actual pigeon heading. You can see right here we also have I don't know how long ago this was, but when we were testing autos, you see that our the trend of our left velocity and right velocity, or desired, was a lot different from our actual left velocity and right velocity. And then right here, we just look through this and we can tell that something was wrong, and then we start troubleshooting the error from there. And right here, you can see this is the velocity error, I think, from your between your desired and actual. And usually 150 is not too much. Usually they go up to like, they can go up to like 700 or 500 or something. I'm not completely sure.
So yeah, the log file that Mr. Day was showing, along with the code that generated it, is available at this GitHub repository on our team GitHub that we've linked up top, the green machine /logging demo.
Yeah. And that's all the code for the logging
So
demonstration that we just did.
Yeah, the error that is in this velocity, we generally use this when we do the PID tuning of the robot, and you're never going to get rid of it just because of the slop in the drivetrain. Depending on what your drivetrain is, how well it's built, is it gear, is it belt, things like that. So there'll always be differences between what you command the drivetrain to do and what it actually reports back for values. So you're just trying to minimize the error. And one of the things you can do depend on your tuning. Your error could be more positive and less negative. We just sort of try to center it. When we go through all the tunings, like let's try to minimize the error and try to have the min and max be about equal. That way we know we're about as best as we can be.
Yeah, and usually when we're tuning our PID gains, we're doing it on blocks, and then we're going to minimize this error. But then when we put it on the floor again, there's got that additional factor of friction, and then those error values start increasing again. Then we got to retune the PID gains, and then also we have another field that we go to called where we have like the foam ground, where there they could add like additional friction to our wheels, and then that air starts going up again, and then we're going to have to retune the PID gains for that specific instance. So that's just the process of troubleshooting, and this visualization just helps you facilitate that in a much nicer, neater way. So other debugging tools that you could use are the robot logs that are accessible through the driver station. And what you can look for is events like the start of your autonomous mode or the start of your teleop. And it's really useful for figuring out what might be causing a crash. It's really convoluted, but trust me, looking through it is well worth your time. For example, we had a pigeon failure at our Lake Superior Regional, like Mr. Day was referencing during our 2020 season. And looking through this, we saw error code 9, a pigeon is missing. So then we started looking through this, and there are also additional tables that this log provides that show like the utilization of your CAN bus. And we found out that the pigeon problem wasn't exactly tied to this CAN bus problem, but we had a CAN bus utilization of like over 98%. And what that does is you're overusing the CAN bus at that point. You want to typically stay between 60 and 70%. And once you hit 90, 95, well, 90 plus, really, things are going to start getting slowed down. You're going to see much more errors as things just aren't able to keep up, as the CAN bus system isn't able to keep up with all the hardware trying to update and get those values from the RoboBrio and etc. So another useful debugging tool, that provides sort of visual feedback, are LED strips. And we started doing this a couple of years back. And RGB LED strips is really helpful feedback for drivers and programmers in the audience. And you can indicate various colors for different operation modes. For example, for teleop, we indicate the color as green, and that color can start telling, gives representation of what's going on internally when the robot starts acting weird. And also, we turn the LED strip red when software has detected a failure. That sometimes might go unnoticed, unless like, I guess like a subsystem of your robot breaks off, then you obviously know. But if like something's wrong with it, but if there's some logic error and within your software, then that LED starts turning red, and then you'll know specifically when that problem happened when you look through the logs and then look at the timing. An additional tool you can use is through the shuffle. You can utilize shuffleboard widgets, and that there are various widgets that you can use. And one we use a lot is publishing Booleans and other values. And what that does is it provides real-time feedback for drivers and operators. So the Boolean box widget can turn red or green. For example, we use solenoids for our collector for 2020 bots. And solenoids have just two states, true or false. So that's perfect for the Boolean box. And let's say your code is turning the solenoid state to true, but the Boolean box value doesn't update. Then you'll know specifically, well, you have a specific idea of where in your code that that there's some logic faulty, and then you can diagnose it, and then your next step forward is already planned from there.
Make one quick comment about the LED strips. Is one of the other things that we used it for was for vision feedback. We had two different colors for vision. One is saying that it was enabled, which of course, I mean, if your green lights turned on this last year with those code, with the current rule changes, you'd know that someone's trying to use vision. But then we also would indicate on our main LEDs of whether or not we actively saw the target. That's really nice when, if you're filming your matches, you can go back and review code and say, see where it's losing your target. And you have a quick, easy way of doing it and correlating it through that visual logging as well as inside of our logs. Because really, if we go through whether it's bad logs or this, you still don't know things like the vision of, where were you on the field where it stopped working, and why. Was there something in the way or things like that?
One thing I want to add about bad log is if you're doing a lot of intensive processing, bad log can contribute to latency, especially the more topics you have. So it might be a good idea to disable non-essential logs for computation use to make sure the experience is as low latency as possible.
Yep. Then it's sort of not exactly a double-edged blade, because once you start getting, like Richard said, a lot of processing, then debugging or the logging might start to play a factor in that latency, and you might want to disable those non-essential logs. Okay.
All right, so today we talked about how to make your team more productive and cohesive with project management strategies like Kanban and Scrum, using tools like GitHub projects, creating issues, tracking milestones and labels. And then we talked about making your code more resilient with good software design practices and fault tolerance, and using things like failure oblivious processing and graceful degradation. And then finally, we talked about tools and practices to collect more information, debug more effectively for when things do go wrong, as they inevitably do.
Yep. If you're interested in some of the code we used today, if you have any questions about it, we can go more in depth with that right now. And if you'd like to learn more and try it yourself, you can check our code out on our GitHub page, Green Machine /Zodiac. Zodiac is our 2020 code base. And also the slide deck from this talk will be published on our website, udinarobotics.com.
Any questions?
All right. So yeah, we actually do have a few questions. Thank you guys so much for that amazing presentation. Super helpful, really detailed, really nice done work. One of our first questions was from one of our people in the chat who said, how do they get rookies involved in this? Because a lot of the stuff you talked about was very, some of it was more advanced coding practices. How would you guys recommend getting all members of the team on board with this and utilizing it fully?
On board with all of it, or just like project management?
That all stems from project management, really. Before you actually get into any coding during your season, you want to ensure that you've established throughout your team that this, like I was talking about the project, establishing, like personalizing your organization system for your team. And this is a way to get rookies also involved because you can assign specific tasks for rookies. I can also show, like, I think it's better to show an example. If we go to our 2021 code project base right here, we have this label right here, add source module definition to robot factory. And this is we've labeled this as a good first issue. And what that's signifying is essentially a good way to get rookies more involved into your current development for your code base and start getting some like on-hand experience. If Richard wants to add anything to that.
Yeah, so it's all about instilling that culture and that habit of project management. You know, this is something that you do not just for yourself, but for like the productivity of the entire team. And like a good way to do that is, you know, to start talking about this before you even really start coding and with the rookies, and also like pairing them up with a veteran member. And like in the early days, you know, pair programming, walking through it with them, reminding them to make sure they're updating the tickets on the project board, and you know, moving the statuses.
Yeah. So typically, like when we actually start getting into coding practices, what we do is we pair them with a veteran and then walk through sort of construction of the like walking through the contents of Robot Factory and you manipulating those values on those configuration files for different robots. And then what we do is we go ahead and actually we look at past code and then we have them sort of replicate it with a veteran on hand. So then they sort of get a sense of what's actually going on in the development process for the build season.
Do you have any other questions?
I think one of the benefits too of having the board like that, one thing I've seen as a mentor with a lot of the team members is you start them out, they're using these things, they're working one-on-one with someone. Eventually by having this Kanban board there, they start seeing issues and they'll go grab something on their own that's maybe more advanced, and it gives someone a chance to really excel and go outside their comfort zone to work on things. So it helped a lot to accelerate the rookies.
And I think this kind of ties into that. One of the questions, another question was, what is, like, do you specifically recommend GitHub issues? You've used a lot of that here, or is another project management solution like Trello or something else equally as efficient? It's just about having project management in the first place.
It's definitely just about having project management in the first place. It's about what works best for your team. We use GitHub extensively for our code and commits and branches, and GitHub issues ties in nicely with that. So that's why we prefer GitHub projects over Trello. But Trello, Jira, there's a ton of those systems, JetBrains, UTrack, they all work great, and all of them have similar feature sets.
Yeah. What we're building off of what Richard just said is just having that project management system within your team. Like you could be the best programmer in the world. You could write really beautiful, efficient code, and but if you don't know what you're doing, then you're not really coding anything at that point.
Sweet. And the last question of today, I think that we got so far is what's the biggest thing to look for when debugging, like in a robot, when you're looking at the logs, looking at bad log, looking at the driver station? What do you look for?
Okay.
Abnormalities.
Yeah. So going back to this, it's really intuitive, really. If you look at it, it looks weird, and it looks weird, it's most likely going to be weird. Like right here, there's this big gap between your desired and your actual. Yeah, then there's a problem. We look through the drivetrain code and try to play around with values. This specifically was testing for our PID values. So then we go to our configuration file and then play around with the p gain, or the I think for this one we would adjust the derivative, not the derivative, right? The
p gain, yeah.
Yeah, the p gain.
So yeah, that applies specifically like to PID tuning, but in general, what you're looking for is abnormality. So that counts as an abnormality. And if you're going through the robot log, what's really helpful to look for is exception stack traces. They're going to be highlighted in red. It'll say what the exception type is. It'll actually, if you expand it, it'll say what line it was caused by. So it's often helpful to go directly to that line in your code and see what's wrong there.
And also, it's good to know that logging, like debugging tools aren't restricted to just logging or a bad log. You can have various print statements, such as like system.out that error, which prints out an output to the console in red when you're I don't know, looking through logic and you're putting that print statement out. Then then you can locate that print statement and where in the logic that it where how to fix that, and some logic faulty or something like that. Like it's supposed to reach like a certain value in the logic, and so then you put a print statement there, but if that print statement never is output to the console, then that there's going to be issues, or where the issue is.
I think another thing, as far as like you said, what's important to look at for debugging and logging, I think it depends on what stage you're at in your robot, right? I mean, whether you're at a competition or you're the initial design of your robot. And the graph doesn't necessarily, if you see something abnormal in the graph, it doesn't really even mean that it's a coding problem. Sometimes it could be a robot design problem. Early this year when we were doing our shooter, we didn't have Falcons around, so we decided to use 4 775s. And with the weight of what our shooter was, the mass that was there and the speed we were running, we discovered we were pulling close to 200 amps with those 4 motors. And we were having problems keeping the robo reel alive from the voltage drops that we had. So you could have mechanical binding problems. You just don't have enough power to do what you're doing. So it's important to, when you see those logs, don't necessarily jump to it's a problem with our code. Involve some other people from your robotic team, the mechanical team, and see if you've got something simple like a wheel rubbing and on the side that's really causing problems.
Yep. And then another great thing to look for is if you're using CAN devices, like motor controllers from CTRE or Rev or Pigeon IMUs. They often self-report error codes, and if you do get last error on them, they'll provide an error code, and you want to make sure if that's okay or not.
Yeah, that's a really good point. You just use the indicators on your robot a lot of times. If someone wired a motor backwards and you got one motor running backwards, you can see that on the motor controllers.
All right. Thank you guys so much for your time. Thank you for all those questions. Really helpful. Super knowledgeable. Thank you guys so much.
All right. Thank you.
Thank you. Just moving forward here, quick reminder, if you haven't already had a chance, and check out 24 Hours of STEM challenge at our website, 24, that's numbers 24, hoursofstem.org. The challenge is open to all age groups, and you get to win Lego Mindstorms. So do that. Super fun. 4 lucky teams will win a Lego Mindstorm EB3 kit. And I think Sam's going to roll a video here about that, a little bit about EB3 Mindstorms themselves. So looking forward to that.
The next that we're going to dive into is game design. And we're actually going to be using some units called EB3 Lego robotics kits in order to do that. Now, there are lots of ways to make a good game. The things that we're going to focus on today are making a game that's not too easy and not too hard, a game that involves some thought, but also some physical movement. All right, so we have some EB3s that are hooked up to ultrasonic sensors. Now, ultrasonic sensors are really cool because they use echolocation, similar to a bat. They send out a lot of high-pitched sound, and then they listen for bounce backs, and that's how they measure the distance between the sensor and the object in front of it. Now, I pre-programmed some of these so that they measure a 20-inch distance, And what I'm going to do is I'm actually going to use 3 of them to design a sensor maze. Okay, and then you'll all at home get to see me try to solve my own maze. We'll see how that works. I'm going to put them pretty close together, and not going to lie, I'm a little inflexible, so we'll see how it goes. Okay, so I'm going to angle my camera a little bit around the Whimsy Makerspace so that you all can see my course. There we go. As you can see, I put one EV3 already on a chair and one on a box back there. I'm just going to go ahead and turn them on. Let's see. But if you can see, every time they're triggered, they turn red as well. Now I'm getting a lot of false positives, so I'm going to move one a little bit further back. Let's see, and this one isn't working, so I'm going to turn that one off. Sometimes that happens as you're programming. Maybe I added in a bug into my code. So my main challenge is I'm going to use this sensor and this sensor, and I'm going to try to get past the maze. And sometimes what happens here is one actually goes off and triggers the other one a little bit since they're sound-based. Okay, so I have them set up now. I'm going to see if I can get through the maze. Let's see what happens. Stretch a little bit, gotta warm up. Okay, here we go. I didn't make it. But that's okay, because it means that I just need to go back to my game design and I need to position these differently to make them perhaps a little bit easier, or maybe I just need to stretch a little bit more so that I can go through the maze a little bit more easily. Great. So thank you all for tuning in for Game Design with EV3s. The next activity.
All right, so that was a super fun video with EV3s. Again, if you haven't checked out the challenge already, check it out, 24hoursofstem.org. Super helpful. Go win some Mindstorms. Okay, so our next presentation, or Sam's got another video. So we'll pass him off to that. Let's see what this is.
While I do not think carefully defining gracious professionalism is essential, talking about it is very important. I think one of the main strengths of gracious professionalism is its dual modality. Gracious is mostly about feelings, both yours and those of others. Professionalism is mostly about knowledge and its application for good. Combining the two is important, so learn everything you can and experience helping others as often as you can. Being an effective contributor is a huge part of feeling good about yourself. Rational self-esteem is a big deal, and it is a likely outcome from practicing gracious professionalism while busting your chops in first. That's good stuff.
Perfect. And that really fits well with the next topic, building and sustaining an effective FRC team with members from Team 1816 and 2177. So how you guys all doing? I mean, I'm part of it too, I guess, but our other MC left. So I'm emceeing. How you guys all doing?
Good.
Perfect. Well, we're basically right on time. I think we can get started.
Okay, great. Ian, thank you very much. Let me share my, well, let's do some introductions first and we'll share my screen and we can do that. So thanks for being here today. We want to thank you again, the organizers of 24 Hours of STEM for giving us this opportunity to present. It's been a great, what is it, 21 hours or whatever. We're kind of heading towards the home stretch here, and we again really appreciate this opportunity. So we're going to talk to you for the next hour or so about building an effective and sustainable FRC team. And I'm joined by 4 really amazing students on 2 teams, 1816 and 2177. So I'm going to ask them to introduce themselves first. So start with Grace.
Hi, my name is Grace, and I am a freshman on the Robettes.
Maisie.
Hi, my name is Maisie Mishi. This is my 2nd year as a team captain on Team 2177, the Robettes.
Ian.
Hey, my name's Ian. I'm a freshman at 1816. I'm one of the assistant captains, member, and yeah, fun to be here.
Great. Prudence.
Hi, I'm Prudence, and I'm one of this year's captains for Team 1816.
Great, good. And I'm Yoji Shimizu. I'm a volunteer with FRC, as also do some mentoring as well with 1816 and other teams in Minnesota. And so let me share my screen and we will get started. So again, we are going to talk to you today about a couple of items that are really focused on how to make your team work well, be sustainable, and be impactful. I think it really sort of the messages here. So we are going to focus on the importance of mission, vision, and values. We'll talk a little bit about team retreats, and then also focus on the importance of continuous quality improvement in the form of team building, even and especially during a pandemic. And we'll focus on these 3 topics. I think what we're going to do is we're going to probably pause between each of those and have a little bit of discussion. We've got some questions, and hopefully there'll be some additional questions in the chat. We encourage everybody who's watching on YouTube, if you have questions, to just please put them in the chat. There will be an opportunity as well during the presentation for you to actually participate in some of this in the presentation, which we'll get to in just a few minutes. So I think if there's one key message maybe that we have for you, is that really building an effective and sustainable FRC team really focuses on this question. You know, what is your team all about? What do you want your team to be able to do? What impact do you want your team to have in the community? And the way in which you can begin to think about this is really to think about what is your vision, your mission, and what are your values. And let's just quickly kind of define what we mean by each of these terms. So when we talk about vision, we're really talking about, in the future, what is the world going to look like as a result of the work that you're doing, right? You've heard Dean Kamen talk a lot about the fact that the vision for FIRST is really to transform our culture so that Ian and Maisie and Grace are as recognized and celebrated for their accomplishments as LeBron James and Brad Pitt, you know, and Meryl Streep. That's really what the vision is ultimately for FIRST and its role in the world. So every team sort of has this idea about what their vision of what the world is going to look like in the future. And the way to kind of realize that vision is to have a very, very clear mission. And the mission is like, what are you doing actually right now? What do you want to accomplish in order to kind of help realize or move towards that ultimate vision? And then when we talk about values are things like gracious professionalism, and we'll talk about other kinds of values as well. This is actually how you're going to go about doing the work. Actually, how will you actually accomplish the mission that you've set for yourself? And so this is the entirety of your team and sort of what your team is there, why it exists. And this is really important for everyone on your team and everyone outside of your team to really understand. This is what this particular FRC team is really focused on. So this value really kind of focuses on that, as well as the culture that you create in order to kind of carry out your work. So when we talk about a mission, we're really talking about, you know, having a very clear mission statement, a statement that really describes a team's fundamental and unique purpose. And this is hopefully a very cohesive statement that really describes exactly what you do and why you exist. And many effective mission statements really focus on three things. One is kind of the cause, like what is the who, what, and where. The action in terms of what you're actually going to be doing, and then the impact, which is what is the change that you hope to see as a result of the work that you do. So I'm going to show you actually the mission statements for both of the teams that are here with me today. So this is Team 1816. Their mission statement is the mission of Edina Robotics, first Team 1816. The green machine is to create bold, confident leaders who transform culture, to promote value and celebrate STEM. And the Robettes mission statement is our mission is to inspire girls of all ages to incorporate STEM into their lives and to revolutionize the perception of women in STEM. And I've tried to color code the components of the mission statement that focus on the cause, the action, and the impact. And I think you can see in all two of these mission statements, it's very, very clear what the cause is. For example, it's STEM, or specifically women in STEM. The action is really creation of bold, confident leaders, or inspiring girls of all ages to incorporate STEM into their lives. And then there's a very clear kind of impact that's really articulated in both of these mission statements. One is to transform culture. The other one is revolutionizing the perception of women in STEM. Right, so these are very effective mission statements because they really focus and outline these three topics: the cause, the action, and the impact. Now, in addition to the mission statement, it's really important to talk about values, and we're going to spend a little bit of time talking about how you can actually, as a team, identify what are your really key core values. And when we talk about values, we're really talking about principles or standards of behavior for a person or an organization. And these are principles that are important for guiding and dictating your behavior. They help you as a team clarify who you are, what you stand for, can help you in making decisions, particularly difficult ones, and help determine if you and your team are on the right path. So this slide kind of outlines a particular process that's been used by these two teams and a number of other teams through kind of a set of facilitated sessions in which a team kind of goes through an iterative process by which they identify a large number of the values that are important to team members, and then go through a series of discussions and exercises to narrow down that larger list of values to a final set of core values and a set of statements that really allow the team to identify their key core values. This is a process that involves hopefully the entire team and the mentors, so that there is really significant buy-in in the overall process that takes place. So I'm going to take you through a couple of ways in which we kind of do this, and then ask the teams to maybe talk about their experiences with developing these core values for their teams. So the first thing is to generate this kind of master list of values. We've often utilized a kind of a Google survey or a form in which we send out ahead of a large team meeting or a team retreat, and just ask each person participating in this exercise on the team, including mentors and coaches, to identify a certain number of values that they really find to be important in their own personal life. So these are, 4 or 5 kind of top values, and we provide a couple of prompts and questions to allow the respondents to think about these carefully, as well as a TED Talk to kind of get people into thinking about this in the appropriate frame of mind. And once we collect all those values, you end up with a pretty large list. You end up with, depending on the number of people that are participating, it could be anywhere from 30, 40, maybe even 60 or 70 kinds of values. And so the challenge now is actually to figure out how are we actually going to whittle those values down to sort of the ones that are the most important and the most critical for the team. And so this is done by basically an exercise in which we ask each person participating in the meeting or the retreat to pick 4 or 5 from that list, that overall list that's generated from that survey. So that you can do this, for example, in person with these large Post-it sheets and some of these sticky notes or sticky dots that allow everybody to kind of put a dot next to their top 4 or 5 values. But I'm going to show you an electronic tool that you can use. This is a tool that in which you can actually do virtual voting with virtual dots, essentially. And so I hope that our great technical staff here at 24 Hours of STEM will be able to kind of put this link in the YouTube chat and ask anyone who's watching to kind of go to that link. You can enter your name here in the upper right corner or your initials, and then you will be given 4 virtual dots, essentially. And we'd ask you to pick your top 4 values from this kind of short list of values that we've kind of just put together randomly. So these are like 24, 27 types of different values. Just pick your top 4 different ones. And then that will allow us to kind of show you kind of the way in which you can kind of begin to narrow down this ultimate list of values that's shown here. So I'm gonna give everybody a few minutes to kind of just kind of go through this. I think it's important to note that you can do this in a number of different ways. We've had experiences where the team has wanted the mentors to kind of work on this independently from the students. We've had other experiences where the teams wanted to do both of them together and have one kind of common list of values through this exercise. So there's lots of different ways by which you can approach this, this exercise that works well for your specific team. Again, it's really dependent on you and kind of how you would like to have this done. So let's give it another minute or two. I know there's a little bit of delay when we are broadcasting over to YouTube. So I want to be sure that we give people some time to kind of do this. And you will, the other thing that you'll notice that in many cases, when you put this larger list of values together, there will be values that look very similar to each other. And that's okay, because that's part of the process, is actually to get a complete list of all of these different values. Some of them are going to be very similar to each other, and that's actually probably part of the point, is that you begin to kind of see whether there are relationships or commonalities between some of the different values that are shown. So let's see what I can do here. I'm going to see if I can go to this. Where is it? What did I do with it? Here it is. All right, let me go to this screen and see how we're doing with this. All right. Okay, so let's kind of work through this. And so here you'll see with this particular online tool that we're using, this is actually a tool called Dot Storming, and it's actually a pretty interesting online tool that we use for a number of different things. There's also a wall mechanism, like a big post-it board that you can use for electronic kinds of meetings. So a little plug for this little handy tool. But every person who voted for one of these values is represented by a dot, essentially a black dot. So you can rank these, and basically you can see here that there's a smaller cluster of values that were picked by multiple people that were participating in this particular exercise, right? So based on this kind of voting, you can begin to narrow down the values that you want to focus on and really discuss further. And again, this is completely a team decision in terms of whether you want to, at what point do you want to make that cutoff? So for example, here it might be everything that's above 2 dots, you might want to continue to consider. That would be, 11 values here that are shown. But again, that'll be a decision for you as a team to make, to try and figure out what works the best for you. But we've taken, this larger list and basically narrowed it down to a much smaller, more manageable list to continue with the exercise. So let's see here. Here I am. Okay, so that's the approach. And then the next step is basically to break up into kind of smaller groups, to take that shorter list of values, in that case it was like 11, and put them into sort of clusters. And again, it's because some of those values are going to feel very similar or have a very similar meaning to you. And so the point is to identify those common values, put them into clusters, and then identify one particular value that's the most important. And then once each small group has done that, we get back together and we discuss what each small group came up with in order to see if there were common clusterings or groupings that took place. So this is one example from a team that did this exercise. They broke up into 5 small groups, and we've tried here to kind of color code the different values that were common and identified as being common across the different subgroups. So you can see here determination and hardworking were put together by all 5 of these subgroups, and others were put together as well, like commitment and dedicated were often paired together in these different 5 subgroups. So there's a lot of discussion that takes place at this stage, trying to figure out, okay, can we come to an agreement about which groups make the most sense? And for this particular team, this is what they ultimately came up with. They came up with this cluster here that was highlighted by supportive, another one that was determined, passionate. And then they actually went back and added some additional values after this discussion and ended up with our common core value of integrity with these other kind of sub-values in that group. So this is where, over the course of about an hour and a half or 2 hours, you can get to this point. And then you'll need to actually kind of finalize the values and kind of draft some statements. And this can involve either the entire team or a small subcommittee of teams. Teams do this in a lot of different ways. And as I think you'll hear in a few minutes, the amount of time involved in kind of creating this part of final step can vary a lot from team to team. So, but ultimately you want to get to somewhere between 4 to 8 kind of core values that are really critical for your team. All right. So I'm going to turn it over to the Robettes now to talk about how they went through this process.
Thank you. So as you can see, we have 5 core values. So we fall a little bit in that mid area between 4 and 8. They are confidence, integrity, compassion, perseverance, and curiosity. And just like Yoji was saying, we did form like small statements and little definitions. Those are confidence, being pride in our skills and abilities, both technical and non-technical. Integrity is doing the right thing, not necessarily the easy thing. Compassion is treating others with kindness and empathy. Perseverance, bouncing back and never giving up. And curiosity is an eagerness to learn and find new solutions. We began our process towards defining our core values in September of 2018 at our annual team retreat. We had 2 members of Green Machine along with Yoji come to present on core values, and they helped kind of guide our brainstorming and narrowing of our ideas. And we did take the pen and paper process of big Post-it notes up on the wall with stickers instead of the online option. At our following team meetings after the team retreat, we took time out of the beginning to discuss our ideas that we were left with after that narrowing process. We grouped together main categories and we whittled down our options until we landed on our 5 main core values that we have today. And our team is always led by the principle of student-led, mentor-guided. And we strive to include everyone's voice in all of our team decisions. So every student had the opportunity to share their thoughts and ideas throughout the whole core value defining and narrowing process. We did face a few challenges, however, when we started thinking about our core values. First, as with any team decision, not everyone gets their way all of the time, and sometimes it's disappointing to see that the team goes with a choice that doesn't necessarily reflect your own ideas. However, everyone on our team handled it really graciously and quickly got on board with our new core values. More prominently, however, we did spend a long time narrowing and weighing down our choices, and we got very caught up on the connotation of different ideas. For example, we compared compassion versus kindness versus empathy for probably an hour or 2 because they're so similar. And I think had we been a little bit more decisive and let go of kind of those small particular nuances in words, we would have had our core values a lot quicker. And the impact of our core values is really important. They guide us through the ups and downs in our season. And like Yoji mentioned, they hold everyone to a standard of behavior. So no matter what's going on with the robot or the team throughout the course of the season, we all agree to treat others with respect, and we all strive to maintain an open and curious mind. We use these core values extensively throughout our season. For example, in the past few years, we've encountered our fair share of robot-related mishaps, from brownouts to coding glitches. My freshman year, we put an entire elevator on our robot, only to find out it put us about 20 pounds overweight and had to scrap the entire idea. Perseverance, however, helped us get through those times because we commit to asking, where do we go from here and how do we fix the issue, rather than dwelling in our mistakes or giving up on the challenge completely. And lastly, as Yoji mentioned, our mission statement is what we do and our core values are how we do it. And in that way, they're really great balances and complements to each other.
Okay, so at 1816, we start every single presentation, whether it's a sponsorship or a general informational presentation, with our mission, vision, and core values, because it's key to our team culture and our team sustainability. We also bring them up when we present to our own team, like when we did a scouting and strategy presentation, or even like at our own team retreat. And then these are very important because they show what we stand for and they guide us in everything we do, from how we act at outreach events to what events we even participate in. Next slide.
So our core values journey has been kind of very similar to what Maisie was talking about. This was all really started in fall of 2017 when we started talking about how our team wanted to operate and how our team wanted to basically be as an organization, as a larger group. This was all happened at our team retreats. And this was kind of led by students and then developed more into these smaller subgroups and then come back with a final list of values and statements. This was presented to the entire team for feedback and all voices were heard. That was really the core intention. And we actually do revisit these core values every single year to ensure that they still fit with who we want to be as a team and that every member feels comfortable and gets their voice heard in the consideration of these values. Core values, like with any FRC team organization, are used daily in everything a team does and a group does. And again, we revisit them each year, facilitated at our team retreat and other things like that, which we'll talk about a few slides down.
Okay, great. Thank you very much. So again, just kind of a very quick summary about this in terms of just the timeline that's typically involved. You know, there's some kind of homework, if you will, or some kind of pre-work prior to kind of a team meeting. This workshop that we have facilitated for a number of teams typically takes about an hour and a half to 2 hours. And then again, as you heard, there's sort of a variable amount of time that's typically taken by teams to kind of complete this final step, which is to sort of finalize those values and draft these really important statements. This can all be done virtually, actually, in our current kind of working situation. So if it is something that teams are interested in, we definitely have resources that are available to kind of help teams in doing that effectively. These are actually many of the teams over the past 2 years or so that we've worked with here in the upper Midwest of the United States on helping them kind of develop these core values. And again, we can help with facilitation of sessions, but also we have resources to allow you to do them on your own as well if you're interested in doing that. So I think maybe we'll stop for just a minute or two and just maybe have some discussion. And I guess I wanted to ask both teams kind of what kinds of items or maybe artifacts or things that have you kind of set up that kind of remind you in your environment that you work in about what your core values are? How have you kind of approached that? Maybe we'll start with the Robettes.
Sure. When we created our core values that same year, once they were finalized, we had some business students who worked on making little posters. They're 8.5 by 11 laminated posters. And we have, I think, 2 or 3 sets, both hanging up in our workspace and our meetings classroom where we begin and end each meeting as a visual reminder of what our core values are. In addition, this year, we have also been putting the core values in all of our weekly team emails, just so that people can practice them and look over them and be reminded each week what we're working towards.
Great. Green Machine, any comments there? What have you been doing?
So one of the things our team does is that at competitions, every team member is required to wear their team lanyard with their name and then the team number. And then on the back of those lanyards actually has a list of our core values. That way we can always go back and refer to them the entire time we're at competition.
Great, thank you. I've seen lots of creative uses of core values. It's kind of a good kind of marketing kind of approach for your business team or your marketing team. I've seen banners and pits. I've seen all kinds of different things that people have used to do that effectively. Can you describe maybe any specific examples? I know, Maisie, you talked a little bit about competition and kind of how one particular core value was really important for you. Are any other examples that you can think of where having the core values was really, really important?
I
know Rubet's kind of talked about this a little bit, so I guess I'll take this one first. For us, the core values really, really are important. Now, like I don't, off the top of my head, there's definitely a bunch of examples where core values have been needed, but more generally, I would say that core values should really be applied to everything. When we're talking, like, for example, our team retreat. Core values are the very core of our team retreat. If we don't talk about core values, it's not a team retreat. It's just a meeting about team history. So having that core value talk, in addition to that, makes each member feel comfortable with them and even down the line when we're solving a problem, say on the robot, and something's not working, and there needs to be a communication between build and CSP or software and coding and business. And when all that needs to happen, the core values facilitate that communication. They tell us how we need to act in that communication, and they basically make it more accessible for every member to feel like they have a voice in our team.
Great. There's another question here about how do you gain team buy-in to engage in this activity?
So I think it's really important that you emphasize the importance of the core values, and then more people will feel like, okay, maybe this is important. And when you are referring to the core values in like almost everything you want to do or everything you do, and you bring them up all the time, then especially new team members can kind of see the importance of the core values and how they affect your team.
Great.
Yeah, I think on our team as well, it's just that repetition and making sure that people know the core values and can define them and apply them in their own lives and their own work. Every week, usually at our wrap-up time, the last 10 or 15 minutes of our meeting, we will go through and quiz people on our core values to make sure that everyone knows them and everyone knows what they mean to themselves individually and personally. And so I think, just like Prudence was saying, the repetition and making sure people understand that there's something they should know is a really great way to kind of increase buy-in and make sure people understand the importance of the core values.
So before we move on, maybe Maisie and Prudence, I'll ask this question of both of you since you participated in the initial development of your team's core values. I think one of the aspects of this question is sort of like, if you've never thought about this before, and then all of a sudden the proposal is, let's spend some time developing core values. Did either of you and your teams have any resistance to that idea? Like sort of, you know, why are we doing this? It doesn't make any sense. It doesn't have anything to do with robots or something like that. Was there a need to kind of be persuasive in some way to kind of convince the team members that we should be spending some of our time on this?
I mean, there's always a few people that are always going to be like, why do we need to do this? It's not related to the robot. Why should we even bother? But one of the big parts of our team is how much outreach we do and how involved we are in our community. So when we bring those things back up, it kind of shows like, yes, this is really important and it's what makes our team the Green Machine.
I think on my team, for reference, I was a sophomore when we began this process. And I don't really remember anybody being resistant or hesitant to just kind of dive in and start. I think something that really helped involve people and get people excited was that everyone got to be involved. Everyone got a few stickers to voice their own opinions. And during those subsequent meetings, everyone got to kind of pipe in and talk about the definitions and the nuances of all those different words. And I don't really remember anyone being hesitant because I think we made it fun and interactive enough to the point where everyone felt heard and felt like it was a worthwhile exercise.
Great. Okay, good. Thanks. All right, so let's move on. We'll come back to this, I think, with some of the other questions that are coming up. So let's move on now to sort of team retreats. I think you've heard that both teams kind of use their team retreats as with kind of addressing core values or developing them, but also reinforcing them over time. I know both of these teams are really believe in team retreats as a really important kind of mechanism for team development and team effectiveness. They're often used as kind of a formal start to the competition season. It's a way to introduce rookies to the team, establishing and discussing and modeling team expectations and behavior can be very important for things like strategic planning and thinking about what you want to accomplish over the coming year. And then there's a really important aspect of team retreats in terms of building relationships, right? And creating the community and culture that you're seeking, not only between team members, but also between team members and mentors and coaches. And so having a lot of fun is also a very important component, I think, of team retreats. So so there, some logistical questions about retreats, like, like when do they happen? Where do they take place? What do we actually do during the retreat? How long should they be? Those are all kinds of things that teams are beginning to think about. And so I'm going to start with the Green Machine and maybe have you talk about your team retreats.
Okay, So in general, our annual team retreat is usually an overnight, but this year, because of COVID, we ended up doing it all online with an extra in-person but socially distant outside activity. And it's really a great opportunity for us to introduce our rookies as well as go over some basic safety training and rules. And then the biggest part of our team retreat is actually focused on core values and team history. We work on questions like, what does it mean to be on our team? How do we act as a member of the machine? And then walk over parts of our history, like how we founded or who our mentors are. We're able to introduce the rookies to our team culture. This helps them integrate into our team and become more comfortable. And then, as Ian said earlier, we go over our core values and make sure that everyone agrees with them and that everyone understands what they mean. And then this whole team retreat is really allowing us to collaborate with each other and get to know each other. Next slide.
Yeah, kind of like the Green Machine, our retreat is actually held on school campus. And we're lucky enough to have a meeting space and a classroom that allows for both indoor and outdoor access, as well as a restroom and a drinking fountain. And it's usually held about 1 month into the fall season, which helps us set up for a solid year. And in a normal year, it's around 7 hours to allow for a full day of a team retreat and fit in all the projects and activities planned. But this year we had to shorten it to 4 hours because of reduced contact and exposure time. And every team member and mentor is invited to join us. And we generally have very good turnout, but the retreat actually usually falls on the date of our brother school STA's dance. So we have people popping in and out. But we build our retreats around a central idea or project, which these last few years have been our core themes. We've been crafting and refining our mission statement and beginning our core values process and working on chairman's executive summaries to help guide what we do and why we do it. This year, we focused on foundational teamwork skills and communication. We talked about how different people communicate different skills and ways of thinking and problem solving to the team. And we need to be aware of how we communicate with one another in order to make sure everyone's ideas are heard and valued, strengthening the team as a whole. We also do a lot of team bonding activities and we play all kinds of games as a team. And we usually share a meal together, which allows for some great memories and time to be in a community together. Of course, because of COVID, meal sharing is not allowed. And we also set aside a lot of time to discuss safety and update our team's personal safety initiative to help prevent and mitigate harassment.
Great, thank you very much. All right, so you've heard about a couple of these kind of team retreats and the way that they work. These are some images from some of the different retreats that they've held. Let's maybe spend a few minutes kind of talking about some questions that have come in about this. So one question is, how do you keep students enthusiastic about retreats if you hold them every year?
I think everyone on our team kind of looks forward to our retreat. It's where us as more veteran members are able to actually meet the rookies and kind of get an idea of what this incoming class is like. And then it's also because it's separate from our school and it's separate from really building the robot. We get to do lots of fun activities and get to know each other a lot better.
Grace, did you have some comments?
Yeah, I feel like for us, we've done a good job making our lessons and the things we're focusing on, our central themes, fun by doing a lot of retreat games that help us kind of get the message across while still having fun and bonding as a team. We've done a scavenger hunt around the school campus and this game called Ridiculous Advertisement, where it's it would practice presentation skills, but it's like a two-sided candle. How would you market it? And we also played This or That, where people would choose summer, winter, Starbucks or Caribou and have to argue their point. And we'd also do funny skits to get a message across and enlighten members about safety and core values while putting on an 80s training video or something.
Good. Okay. So it sounds like sometimes, at least for the Green Machine, you have overnight retreats. Others maybe have just a single day retreat. Is there any, what do you think? Any pros or cons versus, between those two types of retreats?
I think, each of our teams does differently, right? I mean, the Reds, they do not overnight, we do it overnight. I think the real benefit of overnight would be the taking it outside of your shop space. When you're building a team, you're not just building a robot, you're building a group of people, and moving them outside of that space of we're just building robots and into, like, say, where we have an overnight at like a hotel or a part member's cabin or something. Moving that allows people to know them more as people, unless it's just robotics team members. And it also kind of simulates, in a way, the actual event, like the actual events that we go to. I mean, we spend time overnight at regionals, at Worlds, places like that. And so having an in-person retreat kind of simulates that in a way and allows us to know where issues might arise, get people comfortable with each other, and also just like encouraging more collaboration and less just of a focused, targeted, robotics-based event. We talk more about core values, I would say, than we do actually about building robots at all.
Yeah, and I think that's a really good approach. We never really thought about doing an overnight just because we have a pretty big team and a lot of people kind of have conflicting schedules. So we want to make sure that as many people can go as possible. So we just want to be respectful of everybody's different schedules and what's going on in their lives. And also, I feel like having it in the workshop it's a nice way to kind of get a little hands-on, and we don't actually start like building the robot or anything, but it's just a nice way to say, this is our workshop, and it's not always going to be about just building robots. When we're in here, we're also here to have fun and work together as a team.
Good, thank you. So maybe that Grace, your comment maybe leads to the next question, which is sort of how is a retreat different from a team meeting? What's the difference? How would you define that difference?
Well, team meetings, I feel like we do a lot of the same team building exercises by making time to connect with one another and practice strong presentation skills. We have like a silly question of the day each week so that team members can share more about themselves. And at the end of meetings, we also ask students to tell everyone their favorite part of what they did at the meeting. And we have a lot of the same kind of bonding games and stuff. Like we play a game called Yes and, which encourages confident speaking. And I feel like these games really help to continue the message that was free and just kind of reiterate it throughout the practice to motion and applying it while actually building your robots. This year, we've also had to kind of restructure our break time because of social distancing protocols and staying safe. So we've actually been playing a lot of Just Dance to get ourselves moving and laughing with our teammates in an organized, more safe way.
Good, thanks. I know both teams have had team retreats this year, even with the pandemic kind of happening. What adjustments did you make? Did you feel that they were effective even with this kind of unusual online kind of world that we're currently living in? Ian, maybe start with you.
I think that the benefit of having in-person retreats is that people are able to get more comfortable with each other. It's a little bit difficult to have that same experience when I only see the upper fourth of a person's body and really only know them by the top part of their shirt. But outside of that, I would say that it's definitely still entirely relevant to have. I think that we weren't able to have a full in-person retreat and the same overnight experience I was talking about. Having an in-person, even an online retreat allows us to do really what the retreat is all about, which is establish core values, make team members introduce each other, know their names. Scavenger hunt helped with that. Get to know some of your team members, and also just become comfortable as a group. And I think that an online retreat still does that, and was still effective in that case.
Maisie?
Yeah, Grace mentioned a lot of changes that we did have to make, shortening things, doing kind of a different structure than we usually do. We've even had to move to a new space. So this year we had to move it to our actual build space, whereas normally it is in a separate building on our school campus. And I think it was still equally as effective. We're fortunate to have a space where we can social distance, we can split up groups, we can have access to the outdoors so that we can do more activities and team building games in a safe environment. And that was kind of our main goal as a leadership team going into the retreat, is how do we keep everyone safe, but also engaged. And so we did have an in-person retreat, and I think we did get a lot of good benefits out of it that we normally would. We still focused kind of on coming back together as a team after our 6-month kind of absence because of COVID. And I think it was still a really great experience to be able to do those team building activities and games and getting to know our teammates after so long a period apart.
Great, good, thank you. All right, so let's move on to the third topic, and then we'll kind of come around and open it up for even more general questions. So you heard a lot from both teams about the importance of team retreats for building community and making sure that everyone knows who they are, they're comfortable working with each other, they understand sort of the common expectations for the team and being a member of either the Green Machine or the Robettes. And so you've already heard a lot about the importance of team building, right? And team building is really critical. I think a lot of times we maybe going through these kinds of activities, I think some people may think these are really not, they're just kind of silly and maybe not really relevant to kind of the way in which an FRC team works in terms of building robots. But I think team building is really critical in terms of this engagement and sort of building this culture and building this community that will be really effective as a team working together and moving forward. And so I'm going to ask both teams to maybe talk about some of their favorite team building activities and the things that they are using to kind of promote this kind of cohesion and collaboration. So let's start with 2177.
Yeah, so I think we've mentioned a lot of like the regular meetings already, kind of like the question of the day, to kind of just break the ice and get to know one another as not only teammates but as people, and talking about the wrapping up and connecting it back to our core values even as we continue to build and make our way throughout the season. And just practicing like games like the yes and to build confidence and speaking while also just kind of having fun and being silly. And we've also done a lot of fun games at the retreat. I know we've mentioned like presenting skills and the bonding activities like the this or that and ridiculous advertisements. And we usually have a bonfire actually, but with COVID we couldn't do that.
Grace touched on a lot of really great points as to why team building is important. Those presenting skills, confidence, relating them back to our core values. In addition, we kind of have this miscellaneous column of other activities we do that don't necessarily fit under our regular meetings or our retreat. So in the past, we have tried doing a program called Robo Sisters throughout the year, which pairs up an older and younger student from different sub-teams to help create friendships, bonds, and do fun activities with. And it's been really fun when we've tried it, although we would like to add more events throughout the year where these pairings can be together and maybe do some more activities. But our students have really enjoyed that. In addition, our school community is built on Salesian spirituality, which is the idea of being our best selves and serving others with love. And our students take this responsibility to carry it into robotics by honoring our core value of compassion, which asks us to treat others with respect and empathy and kindness. One of the best examples of this manner of team building is our chairman's team. We have had some really amazing chairman's leads who know how to connect people with personal and heart-to-heart relationships. So before COVID, our leads took students to a local Caribou Coffee for chairman's and coffee sessions, so it was a little more casual and a little more fun. We've gone to Super America before it turned into Speedway to go get milkshakes before sitting down to write chairman's essay, which is one of my favorite memories from robotics. And they are really good at reaching out to students personally to highlight their talents and ask them to apply those individual talents to chairman's. As well, kind of in that space, we've had team lunch tables during our distance learning period from March to June for the whole team to be able to connect still while we were separated and couldn't be together in person. And these activities where we're just reaching out on a person-to-person basis really build a strong group who is focused on being friends and companions on our journeys throughout the year, as much as they are focused on being leaders and team members.
Great.
So really good examples for right there. We do a lot of the similar things. I kind of wanted to talk about like really two very, very specific team building activities that our team does that I think are semi-unique and are really effective. This first thing is this implicit bias training, which is a training that we've done, we're doing on repeat this year, started last year. And that's basically where we had a professional come in and talk to us about how implicit bias affects us, affects our team, and how we can combat it within our team as a whole to basically make sure that everyone feels comfortable and that we have a positive working environment. At a core of it, robotics is a group, it's an organization, and each team needs to feel comfortable with one another. And this kind of training really helps emphasize and make people feel more comfortable in the same space. Another thing we do to increase like the sense of community is game nights. These are online social events that are led by team leadership, and they really build teamwork and collaboration, especially in times of COVID or time of COVID, like now, like pandemic, we can't see each other. So these online game nights are really easily had, and to an extent, help replace a lot of the team building activities that we do in person. It increases team engagement, builds team relationships, and there's so many online games nowadays that it all works out. You can do a different game each day, and we've had some really positive feedback from these. So super cool.
Good, thank you. All right, let's stop here and have some additional discussion about team building. And maybe I'll start with you, Ian. What are your favorite online games that your team has been using?
So we've really been talking about two right now. We did Minecraft as a team building activity. Obviously that depends a little bit on who has an account and stuff. Because the biggest problem we actually had, like logistically, was that we can't mandate team members to buy video games. I wish we could, but we can't, because that's not really in the scope of robotics. So we're basically that's a limitation on this, as always. And so we were able to get people all hooked up with an account. A lot of people had multiple. That all worked. And Among Us, which is also popular right now, it's a little bit harder to do because you need some sort of like breakout room system if you want to do that effectively. But a lot of the popular games nowadays actually work really well, and a lot of them are free as well. So super helpful with that.
Good. And then I have to ask the Robettes this question, like, what are your favorite Just Dance songs?
Oh my gosh, there's so many. But I myself, I cannot do like some of the Rasputin Russian Queen ones. Those are just really hard. We've had to ban those to like prevent any broken legs, but yeah, it's really fun.
I would highly recommend All You Gotta Do by the Just Dance team. It's a really great upbeat song, and it really just kind of gets you moving and gets you laughing with your team.
All right, maybe you need to put together a list for the rest of us to kind of practice on. So the Robettes approved Just Dance song list. So, I also want to maybe go back to both of you about team meetings and sort of structure. It sounds like for the Robettes in particular, it seems like there's a very you always incorporate certain kind of team building activities into each of your team meetings. Can you talk a little bit about that? Kind of how you approach that? What do you do at the beginning? What happens in kind of the middle or the end? You know, what's your thinking behind the way in which you structure those team meetings?
Sure. So we always have the first 15 or so minutes of our meetings during the fall, which is kind of our introductory and training season. We always have a question of the day. We just kind of come up with a silly question like, if you could live at any time period ever, when would you want to live and why? Or if you could change your name to anything, what would you change it and why? And they're kind of silly questions. They don't mean a whole lot, but it's a good way to practice standing up in front of the team, eliminating filler words like keeping your hands in the presenting triangle, like we like to call it. And it's just a fun way to get to know your teammates. We all say our name, grade, sub-team, any leadership positions we hold. So it's a good way to just get in front of the team, practice presenting and practicing those communication skills in a safe and supportive environment. And then we have our hour and a half to 2 hours of sub-team time where we break up, we work on robot projects or business projects. We send out newsletters and do our kind of specialized team projects. And then at the end, we always have wrap up, which is 10 to 15 minutes at the end, kind of like intro, where we come together. Like Grace said, we invite students to share their favorite part of the meeting so that they can share what they're passionate about and share what really excited them about learning that night. Or we'll talk about who can tell me the team mission statement, who can tell me the core values. And again, it's just a great way to encourage students to try to present and kind of give us back those core values and repeat back the mission statement in a safe environment where if you make a mistake or you forget something, you're always going to have someone to help you out. And I think that's just a really great way to help build those presentation skills and those team bonds.
Great. Prudence, anything about Green Machine's team meetings?
So we usually do our team meetings before we split up and like Bill goes to do build and etc. And then the way, the way we do our team meetings is that we will start off with a list of basically everything that happened that week or anything that's upcoming. And then if we had participated in an event, we'll usually call on like a few people like, hey, what was your ideas on this? How did it, or would you want to do it again, etc. And then we end up talking about like, we'll have a different thing that we'll learn about. So I know prior to COVID, we were doing a lot of core values. So we would split up into groups and then talk about our opinions or answer the question before we could pick one person from our group to basically respond for the entire group. And then we might have a couple minutes beforehand or afterhand, and that's when we're really encouraging interaction between different sub-teams.
Great, thank you.
I think it's also good to point out that team building activities don't necessarily just have to be games. Hearing from team members on the things that they worked at is, in my opinion, just as powerful as having a group game, because it allows team members to feel comfortable communicating with the group as a whole and telling about what they've learned and how they've been a part of the team. And so that kind of, those just people telling about what they've been working on as well just builds community to an extent.
Another question that came in is about, let's see, how effective would you say are your team building activities?
I'd say that ours are pretty effective just because when we do a lot of our team building activities, it's not necessarily related to the robot or I guess, yeah, the robot or the competition. So we can kind of separate from the stress of build season and then focus on getting to know each other more. And then once someone starts laughing or whatever, it's a lot of a brighter and lighter environment for everyone to collaborate in.
Yeah, kind of what Prudence was saying. I feel like our team building activities have been very effective at just kind of getting everyone comfortable with each other and sharing their opinions and just being comfortable working as a team and getting to know each individual.
Great, good, thank you. All right, we've heard a little bit about the impact of COVID, and maybe we'll come back to that in a bit, but I think the last slide here, we'll talk a little bit about how to do this effectively in this kind of virtual world that we're kind of in, and maybe wrap up there and just have some final questions. So one is just remember that there's a lot of things actually that can be done in the virtual space. So the core values work can be done, a lot of regular team meetings, workshops, and discussions, they can all be done virtually. So you can continue to work on some really important topics and initiatives right now. It's very important right now, since you've heard already from these two teams that it's challenging and it feels really different and feels not so great to not be together on a regular basis. So it's very, very important to be intentional about finding ways to kind of stay connected right now. The meeting structures that you've heard about are probably even more important in the online format, where you really want to have a very clear agenda, a very clear purpose, because everybody is kind of really tired of the sort of the Zoom kind of format for everything. We are, all of us, students, mentors, everyone, we're doing a lot of this kind of screen work and virtual meetings. And so you need to be respectful of kind of the fact that people are tired, I think, in a lot of cases, and you want to be mindful of those limitations. So every minute that you spend online should really count and really be meaningful and important. So there's really not a minute to waste there. And then I think the final point is that you can be pretty creative with technology, and there are some opportunities that exist with virtual meetings that maybe didn't exist before. Those are simple things like the online games that you've heard about, some of the team building activities, using breakout rooms and other kinds of things. But maybe more importantly is that you can actually connect virtually with other people that you may not have thought about doing in the past, right? Where you had an in-person meeting and it was really who could get to that space to meet with you, but now actually you can connect with people everywhere through these virtual means. So it can be with other teams, either in your local community or actually in the country or throughout the world, as we're trying to do now with 24 Hours of STEM, right? So this is a really great opportunity that you can use and take back to your own team in terms of, you want to learn a little bit more about what this particular team is doing, you can reach out to them and ask them to kind of meet with you virtually to have some multi-team kind of interactions and meetings and guest speakers that I think can be very, very helpful and a really great opportunity that I hope will continue even after we're kind of back to maybe a more normal kind of working and living environment. So there are I think some positive things that can come out of what we are currently kind of experiencing. So with that, let's see, I went way too far there, didn't I? Again, we want to thank you for the opportunity to kind of present. I know we've got a few minutes left, and please check out the 1816 website and the 2177 website if you want to learn more about what these teams are doing, and feel free to reach out to us by email as well, or social media. So let me see if there's one final question maybe that I'll kind of bring up here is, this is a good one. So we were in a meeting with a sponsor, and the first questions they asked about were whether our team had core values. And if we don't have core values yet, can we use the core values from FIRST, right? So it's an interesting question because, FIRST does have core values. Obviously, gracious professionalism is kind of a fundamental core value for all of us, but FIRST has also kind of identified some key core values for their program. And I would say that's a good starting foundation in terms of a way to we're all part of the program. We all buy into the mission and the vision of FIRST. So those core values can form a solid template or foundation for your team. But I think at least my experience with facilitating these core values with teams is every team has a different set of core values when they go through this exercise. It's very unique to each and every team. So it's kind of a good place to start, but I think there are lots of benefits from going through this exercise on your own to try and figure out what's unique to you. I don't know if the other students have any comments there.
One thing that kind of reminds me of, and I've talked about this a little bit in past seasons, but an example from my own team of why it's important to also consider those individual values that are really important for your own team. Our core value of confidence is about being confident in your abilities, what you can do, what you can learn, what you can teach. And in my own experience, before I joined the team, a lot of young women are taught that confidence is only about how you look, or how you present to the world. And through robotics, and especially through robots, being in an environment that encourages me to learn more, be on top of kind of my own learning journey, and being a self-advocate for myself has really taught me that confidence can be so much more than that, and can really apply to all aspects of my life, not just how I look or the way that I sound or what I'm wearing. And so I think that's a really good example of why sometimes looking at specifically what your team is trying to accomplish and how you can best get there is really important when you examine your own personal core values.
Great. I think that's a great place to stop. So again, I want to thank the 24 Hours of STEM organizers and Ian and Prudence and Maisie and Grace. Thank you for being here with us today. And I think we're going to turn it over to Alex and Ian, right, to kind of hand this off to our next host team. So
Yeah,
thanks again.
Thank you guys so much for being here. We're going to hand it off to 971 and them all. Thank you guys so much for watching. Again, if you haven't entered the Lego competition, that's a great thing to do. 24hoursofstem.org. Great Lego competition. Win yourself some Lego robots. Have fun. All right, and we'll see you guys. I think next presenter is basically already here too, so we'll just hand it off to 971.
Be quiet. All right, hello, I'm Mira from 971, and I'm going to be your MC for the next few hours as we wrap up the last 3 hours of 24 Hours of STEM. It is my pleasure to introduce our next speaker, who is Marshall from FRC 900, who will be presenting on neural nets, ROS, and zebra corns. So
Hey, Mira.
Marshall, take it away.
Absolutely. I guess I'll take questions as they come up. So from you, so just let me know if you have anything that comes out of the live stream.
All right, sounds good. We're excited to hear your talk.
I'm excited to hear my talk. So let me share my screen. Actually, let me get this going first. How's that? So hopefully you guys can see that. A couple weeks back, I was actually asked by Sarah if I was interested in giving a talk, and she didn't really know what the subject should be, and I didn't know what the subject should be either. But this is a talk I've been actually eager to give for a while, and somewhat for selfish reasons. And I'll explain more throughout the talk, but I have a lot of students that don't necessarily know the history for the team and how we've ended up where we are and doing the things we're doing. So this talk is kind of my opportunity to give back to my students, but I'm hoping others learn from this, not just about, my team, but I hope they learn that, they can tell their own stories as well. And that's kind of what this is. So the title of the talk is Neural Nets, ROS, and Zebra Corns, oh my. So obviously a play on the Wizard of Oz. And then for me, I wanted this to originally be a bedtime story, mostly because I have a little one now and bedtime stories are awesome. But, it's bedtime somewhere in the world. So obviously I'm Marshall Massengill. I'm a mentor for the Zebra Corns based in Durham, North Carolina. And with that, I'm going to get going. So, as all bedtime stories begin, once upon a time, there was this guy named George Watts, and he's one of the kind of founders of the Durham area in the sense that he was an individual that was very influential with the area here and getting things off the ground back when it was kind of a much, much smaller community. So George Watts made a lot of money along with some other folks in North Carolina off of tobacco, but he actually went and founded this awesome hospital in downtown Durham back in 1895, and it's called Watts Hospital, so named after him. And among its many, many, many things that it has done throughout the years, Watts Hospital was actually free for a lot of residents of Durham who couldn't afford to otherwise get health care, which is kind of cool. So it was a private hospital for a really long time. And then over the years, things changed, and eventually it became something that the state owned. And it actually acted as a teaching hospital for nurses for some time. And in fact, we still have a Watts teaching hospital here in Durham, but it's not this one, it's a different one. So some time goes by, as all stories evolve over time. And in 1978, a bunch of old guys in North Carolina government got together, and they set about envisioning what the state of the art would look like for, and keep in mind it's 1978, so the state of the art at the time, this is a world pre-internet, basically. But they envisioned what the world would look like with students who had been through a program where they had gotten a lot out of it and had been able to take advantage of a proper education and go through and get kind of a very well-rounded experience. And they started up two schools. One was the North Carolina School of the Arts, and then there was this other effort as well called the North Carolina School of Science and Math, or North Carolina School of Science and Mathematics is the proper name, that got started at this time. So the school didn't actually get started and off the ground until 2 years later in 1980, when the first 150 students came to the school. So in the School of Science and Math, it's a bit unique. Students from all across the state apply to attend the school in their 11th and 12th grade year. It's tuition free. And in fact, it's the only school that's in this national consortium of secondary STEM schools, which keep in mind that when the school was created back in 1978, we didn't have the word STEM. So we didn't understand that engineering and technology were part of this. So we just had the science and math. But so back then, these students came from all over the state after applying. They applied in their 10th grade year, and they're accepted for their 11th and 12th grade years. So the first year that the school opened, it only took those 11th grade students. So it was the first graduating class. So when they applied, the students were asked as a student body, who do you want what do you want the mascot to be? How do you envision the school? And there was lots of debate among the students. And in fact, one of the ideas that I know got put out there at the time was being known as the Free Radicals, which I find hysterical, and others might as well. Eventually, though, they settled on being called the Unicorns, which is unique, and we'll get into a little bit later how that's changed, or hasn't changed for the school necessarily, but it's changed in other ways. So, this is a very special place. It was envisioned at the time that the students who were here would be up late at night debating grand ideas and kind of keeping in the tradition of colleges and universities like MIT and others. And there's lots of literature online that's been published over the years that's available to explain kind of how the school started. And it's, like I said, it's part of this consortium of schools now. In fact, it's the founding member of the National Secondary Something Consortium for Secondary STEM Schools, NCSSSMT or something like that's the acronym. And there's states now that have copied this idea and very successfully put it in play for themselves. So continuing with our story, some more time goes by, and some notable characters start to appear here. And most importantly, an alumni from our school graduates by the name of Carl Ryden. Carl graduated in the class of '89, which that's important because we'll get back to him in a little bit. But FRC has its inaugural season in 1992. That has absolutely nothing to do directly with NCSSM other than the kind of founding principles for NCSSM are seen through first. They're not necessarily something that first looked at, but I like to believe that there was a predestiny to what was going to happen here. And then class of '97, another notable alumni graduated, Christina Koch, who most recently was on board the International Space Station. And you can see her there in her NCSSM alumni shirt floating around in zero gravity, which is kind of cool. And I really enjoyed. We actually did a downlink event with some students and got to talk to her. It was very exciting. So continuing our story here, 2002 comes around. And at the time, FRC was in its infancy. in a lot of ways. And in fact, we were maybe the third or fourth team in North Carolina at the time, but an FRC team gets created at NCSSM. And this FRC team gets the number 900 for various reasons. Based at the time, basically, you didn't really have much choice, but you were given a way to a number based on where you entered. So as you can see from the picture, it's our first ever robot built largely with 80/20 extrusion. Sponsored by NASA, as all rookie teams seem to be, and GlaxoSmithKline, where we got some mentors. But you can see the robot and kind of, it's not the best example of a fantastic FRC robot, but what's notable about this is that the students that helped create the team had previously been trying to create a BattleBots team somewhat unsuccessfully. And prior to that, had actually been building an electric car, which at the time in 2002, they were trying to do so by converting a different car that had somehow ended up in the hands of the school. So, but the team gets started, and it's interesting. It's known as Team Infinity at the time, not the Zebracorns. So some more time goes by, and in 2005, the icon kind of gets created. You can see the pants appear for the first time. This is the first award that the team's ever won in its history, and it's the Imagery Award. So it was won by telling the judges this fantastic story of how we're a horse of a different color, because we're not quite a unicorn in the sense that the rest of the school is. We're just a little bit different. And most notably at the time, the team is made up of just NCSSM students. So nothing's changed in that regard at this point in time. So it's still only about 15 students a year that are on the team. Hasn't really grown much since the beginning. Maybe there were 10. Still, not too big, still growing, changing, but still part of NCSSM and slowly beginning to evolve. So now we're going to fast forward a little bit more, and we're going to get to kind of a more modern era of things. So we get into 2012, and 2012 is a year where myself as a mentor and others on the team got back involved, kind of after stepping away, but not really for a bit of time. We finally get really back involved with things, and at this point in time, the team has been opened up to students outside of NCSSM. So non-NCSSM students are coming from the Durham area and kind of the Triangle area to be on the team and participate and be a part of it. And what's notable about that is that these students aren't just thriving, like they're not just joining the team and being a part of it. They're joining the team and becoming a core part of it. And a lot of a goal. So we needed something to aim at. We had a student on the team at the time whose name was James Parks. James joined the team not as an NCSSM student, but coming from a different background, and in fact being a part of an advanced group coming from a what's known as a middle college or an early college program. James was like, hey, let's try this stereoscopic vision idea that I've had. So bought a bunch of Axis cameras because that's what everybody in FRC at the time was using. And we started to use them for stereoscopic vision processing. In fact, in the picture there, you can actually see 3 of these cameras that are on the robot. One was aimed downward for the driver, and the other 2 were set up to actually do to take pictures so that we could do distance calculations on the laptop. So, and again, of note this year was the epiphany that the ethos of the team doesn't necessarily come from the NCSSM students or come from NCSSM. It's coming from something else. I still don't know exactly where it comes from, but I do know that it takes a lot more than just NCSSM students to kind of make all this come together. Of note, though, what you see there with the 3 cameras, we did actually manage to make this work. The robot was fairly accurate as far as targeting goes. I won't say we did anything amazing as far as winning an event, but we placed pretty high that year compared to prior years, and we were starting to kind of make a name for ourselves for doing something interesting and unique. We placed the cameras as far apart as we could. That had to do with trying to get the distance calculations as accurate as possible. And we played around with a bunch of interesting other sensors that year. One of them was a gyroscope that we had put on our turret for the robot to actually help with positioning. We ended up not using that. We ended up just using an encoder to do what we needed to do. But the gyroscope was fun to play with for a time there. We did run into some problems, most notably 2012 being the year it was. There was the event that took place on Einstein later, and then bandwidth caps came after that. So at the time, there weren't really bandwidth caps, but it turns out we were eating up a lot of bandwidth trying to stream 3 different data streams of video back to the driver station to do calculations with. We programmed all of this in LabVIEW, and LabVIEW was kind of where we stuck with things for a while. So if we fast forward another year and get into 2013, we needed to move to onboard processing. And we realized that after 2012, where we had issues with the bandwidth limits on the field and with the robot. So we started looking at these tiny embedded computers. And at the time, there was no Raspberry Pi that we could go grab, or at least not one that we know today. So we ended up using this thing called a Panda board. And the Panda board actually did pretty much what we needed it to do as far as processing the video goes. We hooked it up to a Logitech webcam, and in fact, in the picture there, you can see the big green LED rings attached to the camera that's behind it, and then the boards inside the robot, inside of a case. And it worked pretty well. Wasn't fantastic. We tried to use network tables to transmit data around, and we ran into a lot of trouble with running network tables with the Panda board. And at the time, network tables is not what it is today, but we ran into a lot of issues with it. And we realized we needed to change a few things and get to a point where we could evolve a little bit further. But we had a lot of fun with it. The robot was not particularly successful for other reasons, but that's okay. Of note, we did solve our bandwidth problem. We were not the ones hogging all the bandwidth on the field. That was other teams that year, so it was good. So fast forward another year, and we're in 2014. And this is one of those years where we realized that we didn't really have much need for vision processing, at least to start with. But we had an idea about how we would use it. So at the very beginning of the season, we started off with this robot that could throw the ball, basically a full court shot pass down to the human player across on the other side of the field. And it worked pretty well strategically. However, we didn't really have much of a need for vision processing, at least initially. We started off by working on alignment and just having our human player kind of put their hands up and lean one way or the other to tell the driver how to turn the robot so they could get in line. And that worked pretty well, but it wasn't as fast as we wanted it to be. So we actually, the whole goal with this robot was to get cycle times down as basically as minimal as we possibly could. So as soon as the ball was in the robot, we wanted to be able to fire it across the field, get it in, and pass it off to somebody else who could put it in a goal. And then do that over and over and over and over. So one of the things with this robot, though, was that, to get vision processing on there, we needed to attach the target to something that wasn't a target. And we opted for using the retroreflective tape because at the time, that's kind of what everybody in FRC was using. The vision systems are kind of geared towards it. Most of the code was. So you can see in the picture there, one of our students wearing a what appears to be, and in fact is, a Frisbee from the prior year's game that we had coated the inside of with retroreflective tape. And we did that so we had a nice round target that we could aim for and find. So we would do this, and the beginning of the match would start, and we'd basically get the robot where it needed to go, and then we'd auto-align to the human player wearing this Frisbee. And it was basically a necklace, looked kind of like a clock that Flavor Flav would wear. If you don't know who that is, then look up Public Enemy. But the human player would wear this around their necks, and we could target them. And the robot would snap to alignment by taking a single frame image, and then assuming the person had stood still, and in theory they were, at least approximately still. They didn't need to be perfectly still. Then the ball would get fired off towards them. So it consumed very minimal bandwidth. The processing was actually done on board the driver's station laptop, and it wasn't really done on board the robot at that point in time. But that's important because we realized, bandwidth limitations are an actual problem. We need to do something. We can't send a stream of video. We have to do this with like a single frame image. So the robot did really well. We came close to getting into the finals in the first event we were at, Palmetto, and then in North Carolina, we actually won the event, which is the first win in the team's history, which is a big moment for us. And then at championships, we did pretty well. I would have loved to have been on any other field than the one we were on, but the robot did well enough that I was happy with it. Students were too. So basically this year we decided to, the vision challenge for us was how do we make the human player a target? And we did pretty well with that. So fast forward a little bit more to the summer of that year, and we signed up to be one of the teams that was trialing the beta Robo Rio at the time. Because previous to this, we'd been on the C-Rio, so we'd been using LabVIEW. So we're still using LabVIEW on the Robo Rio, but NVIDIA had come out with these embedded processors at this point in time called the TK1, which is part of this thing called the NVIDIA Jetson line. And the TK1 is notable because it was kind of their first foray into embedded systems processing. You could get them inside tablets too and other things, but we were using the dev kit version. This picture is actually something I posted on Chief Delphi way back when, at the end of the beta period. After we'd converted our 2014 robot to using the Robo Rio, we started playing around with how do we get the vision processing back on board the robot. So we took the TK1 and we wrote some OpenCV code for it and married that up to something that at the time we thought was fantastic and brand new, known as 0MQ. And MQ stands for message queuing. 0MQ is kind of like network tables, but a more standardized version of it, I guess. I don't know. It's different software. For us, it worked a lot better. I didn't have the issues that network tables had. It was multi-platform capable from the get-go, and we could get the binaries on board the Robo Rio, which the Robo Rio was now running Linux, so it was very easy to get everything over. It worked with LabVIEW after we got the binaries over and could issue the commands, and it worked on board the Jetson because the Jetson is just a Linux system that we could compile things for. So back to onboard processing, still using a Logitech webcam. And specifically, I don't remember the one at the time, but I'll talk more about those later, I guess. But yeah, onboard processing's back on and we're having fun with it. And we spent that summer working on this and we were very excited when we finally got it in a state where we could do it. And you can see from the picture, all we were really trying to do was get the robot to align, not actually fire anything, because that wasn't the important part of this. It was just proving out that we could do it. Which, by the way, at this point in time, James, who I mentioned previously, is now a mentor for the team after having graduated and gone off to community college. And James is doing some awesome stuff as a mentor where he's kind of encouraging these things. Austin Page, who's in this picture, who now is a mentor for the Howdy Bots down in Texas, was also encouraging all of this craziness, and so was I. There's just lots of kind of insanity from everyone all around for encouraging the nonsense at this point. So 2015 happens, and it's notable in 2015 for a couple of reasons. And in fact, I'm going to play this video. I don't believe there's sound. Hopefully it lets me play it. So both of these are actually videos. We're going to start with, I'm going to mute that one for a second. We're going to start with this one. What's notable about this video is we're using onboard vision processing using the TK1. We've got that same Logitech webcam. In fact, at this point in time, I know for a fact we've upgraded to the Logitech C920 or possibly the C910 at the time. But those are tend to be our go-to webcams these days when we absolutely need one. But it's on board the robot, it's done on the Jetson, and it's using this thing called cascade classifiers to determine where these recycle bins are. And that's notable because the recycle bins didn't have retroreflective targets on them. And this is really the first instance that we're kind of aware of a team that's identifying a target that doesn't have the kind of normal retroreflective tape that you would have on an FRC target, which is pretty exciting. I mean, it works pretty well. You can see from the video, when the robot moves, it kind of loses its confidence level in the recycle bins that's there. It picks up some reflections, it picks up other things. But for the most part, it kind of knows where the recycle bins are and how to get to them. And it's pretty simple programming. It's not particularly complicated. So we're still using 0MQ at this point to send the data between the RoboRio and the Jetson, and that's notable because we've kind of given up on network tables at this point. 0MQ has proven to be really robust for us and extraordinarily fast at getting us the data that we're after, and we're not running into issues with delayed data or having to flush anything. So we're able to get what we need from it, which is awesome. So I'm not a big fan of Recycle Rush as a game for lots of reasons, but I will say this from a standpoint that we were able to demonstrate what we were doing at championships to NVIDIA, it was awesome. What you're going to see in this other video over here is actual footage from the championship event where our robot shockingly worked with its gigantic arm that it had on it for grabbing these recycle bins. And when it did that, it was able to pick them off the stack and autonomous. We could get, I think, 2 of them pretty easily. So it's not particularly fantastic or snappy in terms of speed, but it was doing what we set out to do, which was great. So, and it worked to prove to NVIDIA that, hey, somebody's doing something like this, which is a big deal at the time because they were struggling to find teams that were kind of pushing the envelope in terms of what they were doing with computer vision technology. So it was cool to be kind of recognized for that. Other things I can tell you, we went through championships and obviously the Harpoon story that some people know and love, which is documented well on Chief. I wrote a big long post about it after it happened, but we were involved in an effort with Team 1114 to basically rebuild an entire robot using effectively harpoons to fire at the recycle bins. And notable, I guess, is that 1678 was working with another team, and the number escapes me off the top of my head, to basically do the same thing, although a little bit different. They weren't using harpoons; they were using a different system on the other side. So it was got into what is effectively a literal arms race for who can get these recycling bins as fast as possible. So this was kind of cool that it played out the way it did. So we'll move forward a year. And this is something that was pretty amusing and a lot of fun for me. So in 2016, we started playing around with neural nets after playing with cascade classifiers the previous year. And cascade classifiers are kind of like neural networks, but a lot more primitive in that there's no real machine learning going on to get cascade classifiers to function. I have no idea why my camera keeps pointing over that way, but cascade classifiers, again, slightly more primitive than neural networks, but we started playing with them. And at the beginning of the season, one of the things I did was I put a post out there asking for teams to send us pictures of their game pieces, their boulders. I might have worded this not so well to get a lot of ire from various moderators, but it was still a lot of fun. We went through this entire process of needing training data. And this is notable for a lot of reasons because for machine learning to actually function, you need a very large data set. So we didn't have enough images on our own, and we actually wanted, when we put out the request, we legitimately did want images from other people who had game pieces. And the game pieces weren't impossible to find, but they were hard enough to find at the beginning of the season that, people had to have them. So we asked for images of people who had picked up these game pieces and could take them. We actually set up our own chroma key system. So the chroma key is that purple screen that you see there, sometimes known as a green screen. We set up our own inside of our lab with a lighting source and played around with taking pictures at different angles. And then we didn't play around with the lighting at the time, although I think we would do that now if we were redoing it. And it was really exciting because we were able to kind of move things along in terms of, recognizing a game piece that doesn't have any vision tape on it. And not only that, it's a gray ball on a gray surface. The field that year was gray carpet. So gray ball, gray carpet. Turns out it's really hard to do this and do it accurately. We kept refining the model. I want to say that we're probably close to 500 hours of machine learning time, GPU time that were put into training this. And we also that year switched it up from using a Logitech camera to using a Stereolabs Z. And the Stereolabs camera is back to stereoscopic vision for us. So it's back to something we're very familiar with, but in a nice condensed little package that fits on a robot and fairly easily and can be mounted. So what did we get out of all of this? Well, the entire season went by and we struggled with mechanically with a robot for one, and we struggled with other things that year as well. But we finally got to the end of the season and we were able to actually demonstrate our robot automatically targeting, locking on, and picking up a ball using neural networks and the cameras that were on board the robot. And it was extremely exciting for us. There's a couple of these videos that are out online on our YouTube page. It demonstrates that this is something that's doable. And that's exciting for lots of reasons. And that, once you figure out what the process is, you can start to make the process faster to get there. So we learned a lot during this about the images that were required, the data processing, the workflow, how to get students excited about it, what it would take to actually do this going forward. And we also learned something else was very important to us. Data matters. And it's not just the data, but how you keep the data, how you store the data, how you inevitably need to replay the data or use the data and access it. All of those things matter throughout the course of the robot in getting it to this kind of state of advanced programming. So those things are extremely important for this process. So, all right, we're going to move forward another year. In 2017, a couple of our students that summer had gone off to a summer camp at MIT. And the summer camp's called Beaverworks. And at the time, they were held in person. I think the last 2 years, they haven't been. But the Beaverworks program is phenomenal. And at the time, they were playing around and using some work from this guy who runs a website called Jets and Hacks. He had built a little remote control platform car, and it was using an NVIDIA TX1, a Stereolabs Z, a LiDAR from, I don't remember, probably SICK LiDAR. Anyway, he's using all the same stuff we're using, and two of our students went out and participated in this. And when they did, they came back and were like, oh my God, this thing Ross, we need to use it. We need to look at it. And we should be using this because it solves a lot of our data problems. And simultaneous to this, I had a friend who was actually an alumni from NCSSM, graduated the same time I did. And he had been in California working for a startup doing embedded systems design for robotics work. And he's talking to me about ROS as well and saying, oh my God, this is fantastic. You should really look at this. You should be using it. I kept telling him, I don't think this is something we can do because it doesn't really work in FRC and, it's not really designed for it. So we started poking around. We found this thing from Tufts University called ROS for LabVIEW. And it works. And it actually does what it's supposed to do in the sense that it's able to send and receive messages. And ROS is a message-based system. You can create nodes, and it works. There's some problems, though. It doesn't do everything we need it to do, and it struggles in other areas. So bottom line being that year, we ended up trying to put 2 NVIDIA Jetsons on the robot. We tried it with 2 Zs. We ended up having to take one of them off just because we weren't really using it and able to do what we wanted to do. One of them was set up to detect the balls on the field and actually go towards them. and the other camera was set up to aim for the goal and give us distance. We ended up sticking with just the one that was going for the goal. The other one we ended up having to take off for various reasons, but the idea worked. It was there. It was just trying to get all that working, particularly with ROS for LabVIEW. It was a real struggle. So, but there were some things we proved out to ourselves that year. One, we could be very competitive with it. We ended up being a part of the winning alliance for North Carolina, going on to championships and competing with a couple of great teams there. And it was a lot of fun. We had a lot of fun with this robot. So, but the ROS for LabVIEW thing left some, it didn't give us everything we wanted. It gave us ROS, but it didn't give us all of the tools that we were hoping we would get, and it wasn't as easy of a time as we wanted it to. So I need to answer another question next. What is ROS? So ROS stands for the Robot Operating System, and the first thing I have to say, because it's almost obligatory, is it's not really an operating system, at least not in the way that Windows or Linux or Mac OS is an operating system. ROS is more of a framework. It's more of a set of middleware for helping program robots. And it's built with the kind of explicit goal of enabling general purpose collaborative robot programming. And that sounds complicated, but it really isn't. It's designed as a means of programming robotic software such that lots of people can be involved in the process and join in on the effort. And it's plumbing, but it's not plumbing in the sense that it's just pipes connecting things. It's plumbing in the sense that it sets up standardized message formats and sets up a standard way of doing things such that you can kind of get on with the task of programming it, so that you're not stuck in that world of how do we program a robot. You're actually involved in it. It's a lot of tools too, and tools are the important thing here. We missed those when we were using ROS for LabVIEW because LabVIEW itself doesn't enable those tools to function, sadly, and it doesn't give you that capability. So the capabilities are all of the ROS nodes that exist out there in the world, and there are a lot of them. This is all open source software, so there's this huge community, so that the capabilities come from all of the packages that exist, and then the ecosystem thrives off of that. So, and the ecosystem is now growing by leaps and bounds. I would say that when we started using ROS, it was primarily an academic tool, but I think that's nonsense. It's actually used more by industry than it is by academia. And that shows by the number of people attending ROSCon every year and where they're coming from. They're not coming from the academic world. They're coming from the professional world, and they're building real robots with the software. So ROS isn't an operating system in the sense that Windows is. It runs on top of Linux, and it's a set of programs and kind of bits of code that help enable everything else to function smoothly. So one of the cool things that it did for us was it helped moved us forward from using just one programmer or two programmers programming the robot to where we actually had about 15, which is very exciting. So we finally abandoned LabVIEW for 2018. And what's notable about this is basically we went back to the drawing board to try ROS again. We had a lot of issues. Turns out when you have to compile an entire set of code for the RoboRio that's never been run on it before, there are lots of problems with the control system and getting it to behave properly. But we learned a ton. And between our first event, our second event is basically I won't say a completely different robot, but it behaved very differently because we were able to get the programming under control. What's very exciting about this is that we were able to actually drive the robot at our first event, although it struggled mightily, by just changing a configuration file for where the nodes were and getting them to start up on the right bit of hardware. So starting up on the RoboRio instead of the Jetson. So of note, by the end of the season, we were able to get to a point where we could do this. And that's all automated actions inside of ROS. Guiding that robot to the cube, getting it to pick it up and place it in the right position without the arm interfering with anything. So the nodes ran on the Jetson and the TX2 at the time, or sorry, on the TX2 and the RoboRio. So we'll move forward in 2019. We presented at ROSCon. This is a big moment for our team. We took 3 students, I should say we took 2 students and then had 2 others meet us there, so 4 total, to Madrid, Spain, and they presented at ROSCON in front of this group of roboticists from all over the world. So people from Toyota and Sony, as well as Google and Apple and Microsoft was there talking about ROS for Windows at the time. It was a really big deal for us. And in fact, the guy you can see in the slide that was actually introducing us is one of the founders of the OSRF, which is the Open Source Robotics Foundation. And he introduced us because, he felt it was a big deal that we were being a part of this. They'd struggled to kind of be a part of the world of FIRST and FRC for a time, and seeing somebody kind of take their vision of what robot programming should look like and implement it was a big deal to them. So, of note, in 2019, one of the things that changed after we had been to ROSCON and talked to some folks at championships that year as well, we were able to kind of work on a rule change where CAN signals could be sent not just from the RoboRio, but they could also be sent from the Jetson or from another coprocessor. And that's actually part of the rules now, where the enable signal has to derive from the RoboRio, but the actual motor controller signaling, the things that the motor controller is being told to do, those can come from a coprocessor. And that's really important because suddenly we're able to do things a lot faster than we were previously able to do by sending messages directly from the coprocessor to the motor controllers. So I suspect other teams are going to eventually take advantage of this in their own way. We did, and we're continuing to, because it's a huge improvement in terms of directly accessing those devices. So the RoboRio still handles I/O, and it still makes the safety light blink, but that's kind of all it does now. And more notably, we have lots more students writing code now. We've got about 30 contributors to the code base at this point, and I'd say about 15 to 18, somewhere in there, active student participants per year, which is crazy to me. So, okay, 2019 happens, and we did okay, but not great with the robot. Just didn't perform as well as we would have liked. But the programming was sound, and the robot did what we needed it to do. Move forward into 2020, and this past year we published 2 white papers that are of note. One was somewhat of a joke, I guess, although the content, I assure you, is not completely. We published it on April 1st, and the joke was that we were running neural nets on the RoboRio. Well, it turns out it's not really a joke. We were actually running neural networks on the RoboRio. We were doing that with an I2C color sensor from Adafruit that they're like, I don't know, 15, 20 bucks or whatever. But the little color wheel this past year that we were all supposed to spin, we wanted to play around with sensing for it, and we felt like we were getting a range of values for the color sensors we played with, and none of them were making us happy. So we kind of jokingly talked about throwing a neural network at it, and it turns out not only can you do this, it works pretty well to help kind of solidify whether something is a blue or a green or a red or a yellow. So very specifically, we built a neural network to learn from the data we got from our color sensor. We've made that code available and the data available. And yes, it really does run on the RoboRio. I won't claim it runs great. I will claim that it runs well enough to do what we needed it to do to prove out that it could work, which was pretty exciting. So, and we've actually talked with some folks from National Instruments about that because they were pretty excited about it. So it is something you can do. You don't want to do that for all of your sensors. You wouldn't want to do that for encoders because it doesn't make sense. But there are certain types of data where maybe you've got an analog value. Throwing a neural network at it's not the craziest thing in the world. I don't necessarily know that I'd go out of my way to do it for a color sensor, but we had some students who were bored and wanted to see what they could do, and we needed a white paper to publish on April 1st. So we really did do this. It's there, and it works really well. But because ROS is no longer something we debate about, it's no longer I don't know how other teams are, but there's always debate about something, right? It's part of the chaos of running an FRC team. And I imagine a lot of teams debate their drivetrain. You know, are we going to do Mecanum? Are we going to do West Coast Drive? Are we going to do Swerve? Well, we for a little while had the debate on, well, we could go back to LabVIEW, and we don't do that anymore. We're at a point now where ROS is the thing that we're going to do, and we're going to program it using C++ and Python and all of the other languages that we need to do it, because it requires about 4 different kinds of languages to actually get to a place where things are working pretty well. So you need to know a little bit of Bash scripting, you need to know a little bit of Python, a little bit of YAML, and a little bit of C++ to do what we do. But we're finally at a point now where ROS has enabled us to take action with the data we're collecting. So we can record this data in what are known as bag files, and we can do that across the board with all of our sensors because they're all set up this way. And they're all using these standardized data formats. So what that's starting to enable is what you're going to see. Oop. Let's go back here. It's supposed to be a video that plays. There we go. So this is a video of another team. Sadly, the Zebracorns in 2020 did not get to compete, so we were reliant on video from other teams. But you're seeing our efforts with our neural network to classify images and then use them on the field. And what's kind of note here is you're seeing us identify things like red tape corners and blue tape corners, and the driver station lights and the team numbers and the port covers and other things. These are objects on the field that don't have retroreflective tape. They have no notion of any sort of targeting idea off of them. In fact, it's kind of terrifying because they're not necessarily guaranteed to be standardized between events, although hopefully they are. But we're at a point now where we can identify these things using neural networks. And this is data that we've collected from images that people have taken of the field, images that we've taken of the field, images recorded by our robot and recorded by others. And we take students and we have them label that data as training data for machine learning. So, and that's where we're starting to really utilize neural networks. And it's where ROS is allowing us to spend more time instead of being worried about, how do we program the robot and use this thing? It's, all right, we've got this massive data. What interesting stuff can we do with it? And we're getting we're getting closer and closer, I guess, to a point in time where we can really leverage this data and do really interesting stuff. So we actually put out our paper this past year, ZebraVision 7.0, which is insane to me to think that we've been doing this kind of stuff for that long. But the paper details our efforts with machine learning and classifying this data, and then what we're going to do with it. And what we're going to do with it's going to be really cool is we're getting to a point where we can leverage it for finding our location on the field. And once the robot can localize itself, it's then just a matter of figuring out where the target is that we want to go after and then interact with it in some capacity. And we've proven that we've got automated interactions. I went over that earlier. We're getting to a point where we have localization, and now it's a matter of getting all that to kind of work together simultaneously. So in the next slide, I'll show you a picture of my awesome 7-month-old. His name's Logan. He's downstairs somewhere with his mom at the moment. Logan is the perfect example of neural nets in action. Though he is not a machine, he is a human being, I think, pretty sure. He is learning actively and learning to crawl and kind of be active in movement as a person and doing things. So it's very exciting because Logan's provided, at least for me, this insight into how human beings learn that I didn't previously have. And I'm enjoying being a parent and watching him do these things, not just because I get to be a proud parent, but because it's really cool to see a toddler, or not a toddler, but an infant pick up things and learn to pick things up repeatedly by failing. And it's exactly the same process that we apply to machine learning. So you can see in these two pictures, he's there being cute with his little stuffed animal that he was given from the NCSSM Foundation folks. And then not too long after that, he's on the floor kind of flailing about and crying because he had fallen over and didn't know how to right himself, couldn't turn back over. And this is not uncommon. This is something that, we all go through as little ones, and we learn from it, and we make these failures repeatedly over and over until our brains start to form connections to the point where we're able to move past it and get to the thing we're trying to do without even really thinking about it. And that's exactly how neural nets and machine learning are applied. You know, it's the same kind of process where you have to give it lots of input data to get to a point where there's useful output data. And it's not necessarily guaranteed that all giving a machine learning algorithm a lot of input is going to generate good output, but it'll generate some kind of output and it'll be interesting. That's the hope anyway. But you have to have lots of data to give it to get to a point where you can do that. So the other image that's here is talking about kind of the basics of neural nets. We actually did the last 24 hours of STEM Talk. We had two fantastic students, Yashis and Gabe, who did a phenomenal job talking about how neural nets can be used in FRC and kind of what this image is and what you can get out of it. But there are inputs, there are outputs, and in between there are all these kind of hidden networks that are generated from the kind of connections that have to be formed. So one more video and then we're getting close to the end of things here. I don't know if there are any questions, but if there are, let me know. So machine learning, back to this, we're getting to a point as we approach the future of things where we're seeing more and more of this from industry. And I can speak to this professionally, not just from an FRC standpoint, but we're getting to a point where, hopefully this video plays. Whoop. There we go. I don't know why it's not doing that, but there you go. So anyway, the video that's here is basically the same neural network that I'd shown earlier, but this is actually a later iteration of it after we had done some more training. Of note with this, again, it's not our robot, it's someone else's robot. In fact, it's 5172's robot. But you can actually see the power cells being identified, and importantly, you can see them being identified kind of midstream as they're firing them, which is pretty exciting. You know, we also identify other robots based on bumper color, so red robot or blue robot based on the colors. Anyway, point being, we've iterated on the neural network. We're still iterating on it. We're still adding images to it. As part of the paper release, we released all of the data that we had and released the full net, so you can actually go do this on your own and run it on your own computer if you want. Yeah, so that's pretty exciting for me to see this kind of get to that point. We're starting to see now industry using these same computer algorithms for machine learning to move to a point in time where we're using it for everything. So it's not just that I think this is the future of FRC because it gets rid of the green lights that blind everybody and get everybody angry, but it gets to a point where we can apply this in the real world and we can apply it to other real world challenges. So I think it's a very exciting time for kind of where this is headed. And I look forward to seeing kind of the next couple of years transpire and see where teams take it. Because I think now that we're putting data out there, there's going to be more teams to start to do this, I hope. So that to me is pretty exciting. So with that being said, I know that I've talked for almost an hour now. I want to kind of wrap things up, and if there are any questions, I'll get to them. But to end my bedtime story and hopefully put you all to sleep, I just want you to know that everyone lives happily ever after, and that's the end.
Thank you so much. All right, we do have a couple of questions for you, and we have about 10 minutes left. So the first one I have is, what does network tables do, and how is 0MQ better?
Network tables is the system that WPI-lib provides that they've developed for sending data from your robot or from another system to your robot and back and forth. You have to use it when you're using the driver station. There's some things that come over it. It works well enough. They've redesigned it over the years. Back when we first started using it, it was not in the state that it is now. But 0MQ, in my opinion, is a lot better just because it's more robust and it just seems a lot faster to me. I'm not gonna, if it works for you, use network tables. I know that network tables is built into the Raspberry Pi, what is the Limelight, the camera that everybody uses these days. And then it's going to be built into, I guess, Photon Vision and whatever the other ones are that are coming out now. So it works really well for that. But from my experience, I feel like 0MQ is a lot more reliable. I say that technically, zero MQ is used in industry as part of some software called Salt Stack as well, and that's being developed now, which is pretty exciting. There's a lot of cool things where it gets used outside of the world of robots, so go play with it. I'm not telling you go use it over one or the other. It's what works for you. So if Network Tables is working great, keep using it. Don't stop on my account. I'm going by my experience. So.
All right. Let's see, another one. Do you find the simulation aspects of ROS useful for FRC, or are those something you haven't tackled yet?
That's a great question. Yes and no. We used it really heavily in 2019 with our robot for actually making sure our arm didn't interfere with basically when our arm was down all the way, it could potentially interfere with something, and if it was up all the way, it could interfere with something else with the carriage moving back and forth on the system. So we ended up having to work around that using some motion profiling stuff. We actually prototyped that using a simulator inside, something that was available for inside of ROS. It's basically a 2D simulator though, not a 3D like full field super robot simulator that I think everybody thinks of. I do think those aspects are going to be very useful for teams. I'm more interested right now in the simulation stuff that WPI Lib has actually developed and put out there. I suspect we're going to adapt that to work with ROS for us because the simulation layer can act like real hardware. So for us, it's just flipping a switch to go from one to the other. ROS is just kind of code on top of all of that to enable us to do things differently and better. Well, I say better, it's not necessarily better. It's better for us because we have a large programming team and it makes our lives easier. But if you don't have that, if you're just a few people, go play around with the simulation stuff that WPI Lib is doing. I do think the aspects of simulation are fantastic. I think it's one of the reasons that I harp on data as being so important is simulation allows you to actually take advantage of that data in an environment where you don't have access to hardware. And that's very important. So.
All right, thank you. Here's another one. How much time is spent labeling data by hand to train these networks? Is it built into ROS or using a separate software?
It's separate. It's not directly inside of ROS or anything like that. We actually use the paper, the ZebraVision 7.0 paper, which all of that is available at team900.org/labs. We keep an entire section of the website devoted to these papers, and they're out there and available for all of you to go look at. And the code is as well. It's all linked there. If you struggle to find anything, we've got an email address for contact. But yes, labeling data by hand takes a really long time. We are very fortunate that we have students that's the thing they wanted to contribute. And I promise you, we're not holding them hostage or anything like that. I know labeling data sounds like it's a tedious, boring job, but I am sure that all of you have the student on your team that would love nothing more than to sort all of the screws that have been dumped out in the random assorted screw bin or whatever it is. Those students on our team, they really enjoy labeling data for some reason. So we actually had a couple this past year who did a phenomenal job just going through and literally dragging a square around a thing and then attaching it to a label. And there's some tools that we use for that. They're detailed in the paper. I don't remember the name of them off the top of my head because there's a lot of them out there that I've encountered. So I don't remember the one we were using, but they're nothing particularly special and they're not particularly related to ROS. So.
Are all of your students running pure ROS, or do you find some use ROS for Windows? And if yes, have you found major differences between the two of them?
There are major differences between the two. We've only just started playing around with ROS for Windows on our driver station, and we haven't gotten as far with that as we'd like yet. There are some reasons we can't do that due to the port limitations that are in place on the field, just to be completely honest. If I had my way, I would remove them, but I'm not in charge. So yeah, we're working on that. Most of our students run a VM of some sort, or they run a dual boot laptop, or they have a dedicated system for running Linux of some kind. Most of them are running Ubuntu. I think we have one that might be running something else, Arch or Alpine or whatever, I don't know, some other Linux distribution that I'm not familiar with. But basically, for the most part, we run Ubuntu Linux, and we run typically a version behind whatever the latest long-term support release is. So right now, I think it's 20.04 is the latest long-term service release. We are running 18.04, and that has to do with the version of ROS that we're using, which is ROS Melodic. We can't upgrade yet to Noetic for reasons of the Jetson. So there's a bunch of dependencies that we now have, which is fun and aggravating and provides for challenges. So long answer to that, yes, they all run it natively, but through a VM on top of whatever operating system they're running. We run VMware Workstation Player and VMware Fusion Player, which are free for personal use these days. So go out and download them and start playing around. So, and we also will run Docker as well. We have a Docker image that we share with the students that we actually run inside the VMs, or they can do things natively depending on their comfort level. So I say natively, it's still inside of a VM. So.
All right, this will be our last question. Can we use our AWS credits from the kit of parts for machine learning?
This is an awesome question. Yes and no. Yes, in the sense that I believe SageMaker is available. No, in the sense that you can't just get a random GPU instance and apply it to it. I wish you could. I'm working on that. I'm actually an AWS Cloud Ambassador, and it's really cool that you asked that question. And I get to talk about the AWS Educate program. So AWS Educate, if you don't have a teacher who's involved in it, have them email me, and I can help them set up a classroom in AWS Educate as part of the schooling, and they might be able to get you more resources that way. So it does, I will make a note to that. It does have to be part of a school. You can't just be a community team for that one, unfortunately. So important to note.
Awesome. All right. Thank you so much, Marshall. I
You're
hope you
welcome.
all enjoyed this presentation and learned something new. I definitely did.
Very cool. Thank you guys for having me. This was a blast. I'm not as well planned out as I was hoping it was going to be, but I had a lot of fun, and it's definitely the talk I've been most wanting to give for a while. So I'm very happy I got to do this.
All right. Yeah, thank you so much. So just a reminder to everyone who's watching, if you haven't already had a chance, please check out the 24 Hours of STEM challenge at our website, 24, that's the numbers 2 and 4, hoursofstem.org. The challenge is open to all ages and groups, and 4 lucky teams will win a LEGO Mindstorms EV3 kit. So if you haven't checked out that really cool opportunity, you definitely should. All right, and then I'm excited to introduce our next speaker, Mike Corsetto from 1678, who will be presenting on iterative design. So welcome, we're so excited to hear from you.
Thanks, Mira, I appreciate it. Are you able to see my screen right now?
Yep.
Awesome. Well, thanks for having me, and I'm looking forward to going through this iterative design talk. Let's see, so brief introduction here. My name is Mike Corsetto. I am the lead technical mentor for Team 1678. This is my 17th season in FRC. Actually, I think just wrapped up 17, going on to 18. And I've been mentoring the team since 2008. In my professional life, I'm a mechanical engineer and a manager at NovaSource. And a lot of this talk is credited to inspiration from Karthik and his strategic design talk. I use that as a springboard for a lot of my talks and the various different topics that I like to discuss as key elements to running an effective FRC team. So yeah, we'll just dive right into it. And what we're hoping to talk about today, we'll talk about what iterative design is at kind of a base level. We'll spend some time talking about the prerequisites to the iterative design process. So again, we're talking about iterative design in the context of FRC. So that has some very specific boundaries to it. And one of those is how you set up your entire season after kickoff. So we're going to talk a little bit about how iterative design has some prerequisites that you need to go through first before you start iterating and making your way towards a competitive robot. We'll talk about the importance of setting your scope and why that matters and how that can make an impact in your program. We'll talk about the idea of failing faster, why failure is something to embrace rather than avoid. We'll talk a little bit more in depth on the prototyping process, a little bit of what 1678 does for prototyping and what prototyping really means in the FRC sense. And then we'll be looking at how do you determine success in the iterative design process. Kind of, when do you say enough's enough? Let's move on to the next thing. So yeah, let's dive into it. So I wanted to share a story about Kyle Maynard. Kyle Maynard is a quadruple amputee, and he's also a mountain climber. The guy has a lot of really amazing stories, and he had one quote that I just wanted to share to kind of launch this talk. He says, "Failure is inextricably connected to any major success I've ever had. I don't think failure is sometimes part of the process. It always is. When you feel you can't go on, know that you're just getting started." I found this to be pretty inspirational, and in particular, the emphasis on the fact that failure is always a part of the process stuck out to me when I read this particular quote. And I think going in this talk, we're going to see how failure and failure is inextricably linked to iterative design, which is a requirement for developing any FRC robot. So hopefully we're setting some baseline here. So what is iterative design? All design of a product is an iterative process. Everybody does this. People do this in their everyday life without realizing it sometimes. They try something out, it doesn't work, they make a correction, they try it again, maybe it works, maybe they need to correct again. That's like a very, very basic version of that. The key to the iterative design process is to repeat the process or parts of the process to improve the final result. So we'll talk in just the next couple slides about what that process is, but to iterate is to make incremental improvements, and at each increment in that process, you need to repeat the iterative design process. In more layman's terms, it kind of looks like constantly testing, tweaking, and improving. It also requires the willingness to jump back and forth in the design process a little bit. We'll talk about that. It's important to get into the habit of doing this process as well. So iterative design is not something that, it's something that inherently comes naturally to an extent, but to be proficient at it requires some level of diligence in practicing. And then a key component of the iterative design process is celebrating failures. We just talked about this with that quote from Kyle, but there's a big difference, I think, between what you do in FRC and really what you do in real life engineering and what you do in like the classroom. I think of my time as a student, and you kind of grow up as a student, getting graded on the level of perfection in your homework, the level of perfection on tests that you take, standardized testing, AP testing. You get a score, and your goal is to not make any mistakes in those environments. The iterative design process is entirely different. The iterative design process, the emphasis is on finding your failure points, identifying them, and then making and really revealing them, like not trying to hide them, but showcasing them, and then making corrective actions. So there's a big difference between the iterative design process and then I think a lot of students experience in the classroom on tests and homework and subjects and things like that. So what we found on 1678 is sometimes it can be an adjustment for students to be even willing to kind of step out and experience failure in one sense or another. So again, that's kind of why, why we're emphasizing this and why I think it's important for us to talk about iterative design. Okay, so iterative design can also be described in the PDCA model, which is one development tool in the professional world. It stands for plan, do, check, and act. And this is just a diagram I pulled off the internet. So in the plan phase, you identify your problems. This can be, and this can be at a macro level or a micro level, right? You could be having one problem where a bolt is stripping in a certain location, right? And so you identified that problem. Okay, we're stripping out this bolt. Why is that happening on this mechanism? You test potential solutions. Maybe we upgrade the size of the bolt or the materials or change something about the geometry of the design. And then you check the results of that potential solution that you just implemented. So maybe you try out the changing the material on the bolt first, and it still strips out when you go through the check process. So maybe you do up the size of the bolt, right? You check that and it doesn't fail. So the act thing is acting on implementing the best solution out of the bunch that you found to solve that particular problem. But what happens now is you fix that problem. Maybe that was a part of a broader mechanism, and you're allowed to. And now that you fixed the bolt stripping problem, you can use that mechanism for another couple hours. But then maybe something else in the mechanism breaks, and now you have to identify that problem and then plan out potential solutions for that issue. So you can imagine with something as complex as an FRC robot, whether or not you're aware of it, you're going through this plan, do, check, act process, tens, hundreds, thousands of times on small and large levels. Okay, before we get too deep into what iterative design can look like in FRC, we need to talk about what we're going to establish as our prerequisites, our baseline for the process. Prerequisite number one is reading the rules. So again, we're talking about what the iterative design, like some of the iterative design process is instinctual, some of it needs to be planned out and structured. If you're going to take the most advantage of the iterative design process in FRC, you need to have a plan for the whole season. And I'm just bringing up the 3 prerequisites that I think you need to have in order to move forward and have an effective iterative design approach to your season. So reading the rules is step number 1. We allow a couple hours for all the students to read the rules, and then we have a rules test. Every year we make the rules test public, so just keep an eye out on our social media or Chief Delphi every kickoff, and within a couple hours of kickoff, you'll see a rules test published by our team. You can look at past ones that we published. They should all be live and available for you to look at. But this reading the rules gets everyone on the same page and ready for prerequisite number 2. Okay, the rules test, I just kind of explained all that. Prerequisite number 2 is answering the what questions. I love this comic. If you can't tell, they're putting the cart before the horse. The what questions are what is our robot going to do in a given match regarding strategy and which game elements it interacts with and which areas of the field it goes to and what tasks the robot accomplishes and what areas does it score in, things like that. That's part of the defining your robot's technical criteria and essentially defining what your strategy is going to be at a high level for the season. And you need to know what you want to do before you can figure out how to do it. So and this is what we mean by putting the cart before the horse. If you aren't defining your criteria and you start wondering, okay, how am I going to pick up this ball? Like, should I use a mechanism wheel intake or should we use a straight over bumper intake? if you start thinking about all these specific mechanisms and hows, you could be building a robot for the wrong thing. And so you need to spend time after you've understood what the game is, breaking down the game and evaluating what are the best things for us to do in this game based off of the game and our criteria. And this is where strategic design comes in. And, Karthik's talks on this are really important. And, considering what your alliance partners can do. I won't go too in depth, but again, the process is important. You read the rules, you set up your list of what's, and then you set up your list of hows. So again, I'm going to skip this because these are not the point of this talk. But in summary, you need to figure out what does your robot have to do. An example list of the results out of the what section would be the 2016 game. We're going to shoot in the high goal. We're going to go under the low bar. We're going to traverse these certain types of defenses, and we're going to climb on the scale or something like that. And there could be some other lists in there of slight variance to that, like we're going to pick balls up off the ground. We're not going to take balls from the human player. You kind of specify all of those things in the what section and establish that very specific list of tasks. I wish I had a picture of one of them in this presentation. I used to. I don't know what happened there. But the key thing here is at the end of the what section, you have this specific list of tasks that the robot is going to be able to accomplish. And you have to stick to that list of tasks as you move forward through the rest of the season. This is really setting the direction for your entire season. So it's a very critical moment in the process. All right, now that we've determined what we're going to do, we need to answer the how question. This is where we really start to get into, what you might understand more of as the design process. We have individuals and small groups on kickoff weekend start sketching out robot ideas and figuring out ways to share design ideas with the rest of the team. Sometimes this can be like a quick Crayola sketch in a CAD program, but more often than not, it's just hand sketched drawings on graph paper. Since we have everybody present their ideas, it's important that everything's to scale. So we hand out graph paper and kind of decide on a scale. And then each group gives small presentations on their design ideas. And some mentors will present ideas as well to the broader team for discussion and asking questions and things like that. It's a time to kind of blue sky ideas on, now that we've decided the criteria of what the robot needs to accomplish, here's some cool ideas on how we might be able to get that done, some cool mechanism ideas, some cool robot shapes, things like that. We take some time to discuss the merits of the design. So like we have a list on the whiteboard, a running list, and we add on additional things as they're described during teams' presentations. We also have the opportunity to ask for clarification on people's ideas, to say, hey, what did you mean by that? Like, what would that mechanism actually look like? And then it's also important to think about, okay, this idea that's being shared, is this actually like a practical idea? Do we know that we could accomplish something like this? Is it too sophisticated for us, etc.? And then after we've listed all these ideas out, they've all been shared with the group, we look at what those really popular, like those ideas that came up often are, like what were some of those really popular ideas that seem like they stand a good chance at working. We also kind of take another round of considering other options that might not have been listed out on the board. And then we try to narrow it down to a short list of ideas and approaches. Now, this has kind of developed over time on our team, but now what the process looks like is we generally have about 5 prototyping teams that will start meeting right after we conclude this step 3, the how section. We want to try to leverage those prototyping groups to be as effective as possible in getting us the results we need to build a competitive robot. So in a game like, let's say a game like 2019, where we needed to have a way to lift the the game elements up to the different levels on the field. We kind of decided early on that we were not going to prototype an elevator because our team had built elevators before and we'd seen other teams build elevators. So even though it was, you know, it was pretty much known from the start that we were going to use it, that we were going to want to use an elevator for that year's game, we didn't have to assign a prototyping team to that specific project because the elevators at this point are recycled year to year, essentially. So those 5 prototyping teams were more focused on things like intakes and scoring mechanisms and the climbing system, things that were more new and novel that needed to be fleshed out further before they went to the design process. So that's what we focused our prototyping groups on. And it's kind of how we optimize for reducing risk in the development process. And a part of that, frankly, if you want to take it at a macro level, if we look back at our PDCA iterative design cycle, the elevators in FRC have gone through that PDCA cycle, you know, hundreds of times. There's so much so that there's actually products available off the shelf that you can buy for elevators. So you don't really need to spend more time fleshing out the elevator designs unless you are doing something really fancy, which you probably shouldn't be. You should probably be doing something more mainstream. So. Okay, so setting the scope. This is kind of related to what we just talked about, but I like this quote from Steve Jobs. He says, "You have to pick carefully. I'm actually as proud of the things we haven't done as the things I have done. Innovation is saying no to 1,000 things." So this goes, I think what Steve Jobs was getting at with this quote is your ability to make an effective product is just as related to your design and development aptitude with the things that you choose to do as it is with your willingness to say no to things that you should be avoiding. So when it comes to FRC, a big thing is saying no to doing everything in the game, right? Saying, okay, we're going to limit ourselves to X, Y, or Z tasks and be the best we can at those things. What I like to say is, you know, as I mentioned earlier in the summary of the what section, you need to establish a specific list of tasks that your robot's going to accomplish. I like to also encourage teams to write a list of the things they're not going to do, right? And if anything, you should get more excited the more things that are on the "we will not do" list. It seems a little counterintuitive to celebrate saying we're not going to do the high goal and we're not going to do a double climb, right? Like, you know, those things would be really cool, but you should get pumped about every single task that your team commits to not doing, because inherently what that means is your team is going to have more energy and resources to put towards the fewer things that your team has committed to doing. And what that's going to mean is, given the exact same amount of resources and time, you will be doing a better job at those fewer things. So get pumped when you say no to stuff and when you reduce your scope, because that's going to result in a better product for the things that you do choose to do. And this is saying exactly that. Too many ideas give no time to perform effective iterative design on any of the ideas. That PDCA process, the plan, do, check, act process, that every time you go around that circle, it takes time. And we're going to talk about this more, but robots go through the PDCA process hundreds of times. Each mechanism is going through the PDCA process tens, if not hundreds of times, in small and big ways. And your time is limited, your amount of resources is limited. So you need to be making the most of it. And by limiting the number of mechanisms and tasks that you're trying to accomplish with your robot, you give more time to complete that PDCA cycle a bunch and develop a more effective robot. All right, let's talk a little bit about failing faster, totally related to the scope topic. Thomas Edison said, a famous quote, "I've not failed 1,000 times. I've successfully discovered 1,000 ways not to make a light bulb." Thomas Edison, famous American inventor. So fail faster. Why is failing faster important? Because time is limited, it's important to continue to use your failures as an opportunity to guide your path forward. One of, just as an easy example, but it's honestly probably one of the most common mistakes that I see in FRC. A team will they'll decide on a robot design they want to do. Maybe they'll do some prototyping, but then their designers will head off and their designers will be designing the robot in CAD for like 4 weeks straight. And during those 4 weeks, nothing's being built on the robot. And then after those 4 weeks, they say, all right, we got the robot design done. It's all fleshed out. Let's build it, right? And so then you spend another week building all your mechanisms. And then you're at the end of the build season. The robot's just coming together. And you're turning on your intake for the first time, your shooter for the first time, your indexer for the first time, all at the same time. And none of these final design ideas have been fleshed out in advance. What that means is you have ahead of you, you have another 30, 40, 50 PDCA iterations that you haven't gotten to yet. If you spend 4 weeks without any PDCA iterations on a mechanism, you're doing something wrong. You need to be going through that development cycle, multiple times a week, if not multiple times a day, regardless of how much final CAD you're hoping to get done on the robot. So, what does that look like? Well, we'll talk about the prototyping in a little bit, but let's talk a little bit more about why failure is so important. The thing that the way I began to view it probably 3-4 years ago is every failure gives you like another failure dollar or failure buck, right? And the more failure dollars you earn, the better your robot's going to be. So every time you're failing is another opportunity to improve the robot, go through the PDCA process, and come up with a better, or have a better product on the other end of that development cycle. What I learned through this process and observing some of the best teams in FRC like 254 operate is it's not like when they go out onto the field. I mean, 254 hits the carpet and everybody watches because it's just amazing what they're able to do out there. What you see on the field isn't the result of perfect designers and perfect mentors and students developing a perfect machine. It's the result of hundreds and thousands of small failures that 254 was able to produce, identify, and correct and eliminate before hitting the carpet. So what I like to say is when our robot goes out there and we score a couple of balls and then something doesn't go right, a cable gets caught and our intake gets stuck, right? And 254 is in the same match and they're going no problems through the whole match. It's not just because they're a perfect team, it's not that they're a perfect team. It's just that they've failed more times than we have, right? The fact of the matter is, if we had failed by catching our intake on that string in our shop, we could have corrected that problem before we got out onto the field. But we probably didn't finish our robot fast enough. We probably didn't do enough development time. We probably didn't test it enough. And so we didn't find those problems. So, what you're looking at when your robot's dead in the water out in the field and the best team at the event is running circles around you, there's probably more of an issue with not identifying the failures in your equipment before sending it out onto the field. So, again, this is why I like to view it more in how quickly can you fail, how many times can you fail in the shop, because every time you fail in the shop and you correct the problem, it's one less way that your robot could fail in the competition. A good example of this was 2011. It's kind of a weird example, but 2011, we had this like flip up elevator for 1678, and we were practicing in a shop or in an area that had these like tapered roofs, and they were a little bit too low for our elevator. We were doing some driver practice, and the kid got too close to a wall and literally like chopped the arm off at the pivot. But we realized in that moment that the pivot was just too weak in general, and it sheared way too easily. So we beefed it up with a thicker plate before our first event. We wouldn't have identified that problem if we hadn't done that driver practice, and there's a good chance that our arm would have broken in a match at some point at our regional or at championships. So this celebrating failure, this more failures equals more failure dollars. The more failure dollars you collect, essentially the more experience you have and the more times you've gone through that iterative design process. So it's actually a good thing, and it's something to recognize that teams that are maybe ahead of your team in one or another are likely there not because those individuals have like some perfection gene that you don't have. It's just that they've probably failed. Those teams have probably failed more often than your team has. So focus on your team failing more rather than wondering how to be perfect, because perfection is not going to happen, but you can fail a lot more and learn from those and improve your robot that way. So. Okay, let's talk a little bit about prototyping. So I'll break it up into two things. So we have like early prototyping. Those are small groups of students. Usually ours are around 4 or 5. And those groups are broken off onto specific mechanisms. You need to have an experienced leader in each one of those groups, someone who's familiar with FRC, more holistically. And having some adult support is important there as well. That group can use, a bunch of different prototyping materials, plywood, PVC tubing, slotted metal extrusion, cardboard, tape, wood screws, whatever your team has that's easy to use. A lot of times a good trick is just, some pieces of plywood, some holes drilled in it with some shafts, and then you can actually, depending on the size of the shaft, you can chuck shaft into your drills and run a drill to power shafts and like test intakes and, things like that. Another fun, kind of hack is actually using old robots for prototyping. In the past, for example, in 2017, there were these gears, hard plastic gears you had to pick up off the ground. The gears were almost the same size as the hard plastic frisbees we picked up 4 years earlier in 2013. So for the 2013 or 2017 prototyping phase, we actually rolled out the old 2013 robot, powered on the intake, and just ran it into a gear and actually found that it picked up the gear quite well. So we used that as the initial prototyping tool for that particular mechanism. The prototyping process, it's very similar to the PDCA process. Emphasis is on speed, so getting to results quickly. FOSS is Steve, our other lead mentor's acronym. It's fail often to succeed sooner. Kind of same concept to what we just talked about with the fail faster. It's important to stress the limits of your prototypes and your design in general. What I mean by that is, let's say you're making an intake for, let's say, the 2020 game where you're picking up all these power cells. Rather than just putting the intake prototype on the ground on the carpet and just rolling a ball slowly at the intake and watching it go up, there's a couple of ways that you can stress the design. One way is that you can hold up to 5 balls. So what's it like when you shove 5 balls in there all at once? How does the intake behave in that condition? Another stress would be what happens when a ball comes at the intake from the side or on the very edge? Rather than, of course, it's going to work when the ball's going right up the middle every time. But if there's a ball on the side, how does it behave? Another stress for an intake would be sure, maybe the intake works when a ball is rolling at the intake, but what happens when the intake is rolling at the ball? Because, more often than not, your robot's going to be driving at the ball, not the other way around. So if your robot's driving at 10 feet per second at a ball, does it pick up the ball or does the ball fall under the robot? That's a very common mistake we see most years, is teams are not testing their intakes at speed. So that's another way that the design isn't being stressed. Specifically for the prototyping process on 1678, because that's informing the design of the robot, our prototyping teams are documenting everything with pictures and video and uploading them to Google Drive. We often will have one main Google slide presentation for each prototyping team, and they'll just share a couple pictures and some text description on each slide for a new day of testing, taking measurements and things like that of specific key dimensions, distance between the rollers, key consistency measurements, how accurate is the shooter, prototype, things like that. The thing I wanted to talk about with prototyping in particular, and I kind of alluded to this earlier, FRC is interesting because you're really only making one robot. And so in the professional world, you develop prototypes before you go to production. And so you're making, limited runs of units for evaluation. You make changes, you evaluate those changes, and then maybe you're making, 10 million iPhones or something like that, right? And then you go live to production, and there's you massively up the scale. With FRC, it's different because you're only making the robot for your team. In general, you're only making one. Maybe you make a practice robot, but in reality, the robot is always in the prototype phase because there's never been anything like it, and you're not going to mass replicate this. So really, this robot's the only thing you're working with. So all of these lessons on PDCA and prototyping and failing faster never stop in the FRC world. You're essentially working on a prototype from day one until the end of the championship event. And so for us, this kind of testing quickly, stressing the design, documenting everything, this doesn't stop when our formal prototyping teams stop meeting. This keeps going and keeps going. We're always looking for ways to test up the design. Stressing the design is an important part of the iterative design process. So, I like to kick the robot and test the robustness of intakes and other mechanisms that are at risk. We try to really test the limits of, okay, how far can we shoot from? How close can we shoot from? How fast can the shooter go? We're shooting at 1 ball a second. Could we up that to half a ball a second? What would that look like? What would start jamming? Things like that. I think it's really important to continue to stress test, even when the robot has come together and you think it's all working, to continue to stress test it, drive it over bumps, play full matches, things like that, to identify all of the potential issues. There's one thing I don't have a slide for here, but related to robot testing, kind of that phase towards the end where you have a full robot together and now it's in the testing phase, you're running driver practice, things like that. There's one significant trap that teams can fall into. I don't have a great name for it, but it's kind of like the ease of correction trap, where you have a robot, it's built, you have some sort of test area, maybe it's like a corner of a carpet, or you have a full practice field, and you're running the robot in that test area, you're picking up balls, you're shooting them, maybe you're trying to run a simulated 2.5-minute match, for example, right? Let's say you run auto, you run one cycle, and then a ball jams up in your intake, right? Maybe as a drive team, you're more focused on getting driver practice. So you're like, all right, let's hop on the field, unjam the ball, reset, go again. The risk there is if at the same time, you're not effectively noting and sharing that result of a jammed ball that essentially shut down your match, there's a risk that you don't effectively address that problem, and that problem can pop up again. The issue is it may not really register on your radar when a ball gets jammed in your home shop because you can just unjam it and keep going, but you're really going to feel the pain if a ball jams during a match and you can't score for the rest of the match. And I know that's a weakness of our development process, and I think we see that elsewhere too, where a problem or a similar problem pops up during a real match. It's something we may have seen before, but we didn't properly address because there wasn't that stress or that impetus to do that in our practice sessions. But once we hit the real field and that same failure pops up, if we haven't addressed it and gone through the PDCA cycle, we lose an entire match. And it could be completely unnecessary if we had already seen the problem in the shop. So I think what that highlights is it's not enough just to fail. You need to fail and correct. And that's where that plan, do, check, act process becomes really important. Now, I'm not saying that every time you have a failure on your robot during your practice sessions, you need to solve that problem in full right then before you move on with more practice. That may not be the wisest use of your time, but you certainly need to note that there's an issue and have a group address it at some point before you get to the competition, or else you're liable to repeat that failure at your event. Okay, so I think there ends up being an open question on, when does the iterative process end, and when do we know that we've, met our goals? I think it's important to focus on your what section of the brainstorming process, that prerequisite number 2 we talked about earlier. Refer back to your list and ask yourself, are we meeting the items on this list? Like, does the robot do the things that our strategic evaluation told us that we needed to accomplish? And then I think I kind of repeated myself here, unfortunately, but there is a difference between running a robot and testing a robot. You really want to test it and find its limits, test a bunch of different scenarios. And while you're in your shop, don't be afraid to break it. I think there's a tendency to want to baby the robot because there's so much blood, sweat, and tears that goes into every team's robot, and there's a lot of pride in what has been made. But it's still important to put it through its paces and test its limits. Do things that make the kids nervous when you're doing it, like driving over defensive barriers and stuff like that at full speed. You want to try to shake things loose, find those weak points and address them in the shop, so you don't have those pop up in an untimely manner at an event. Okay, so that is all I had prepared. My contact info is up here if you want to reach out with any other specific questions. But Mira, I'm not sure if we had any questions come through on the chat that we can address.
Yeah, I don't have any other questions right now. I think you already answered the one about how far into build season does the iterative design process go? Yeah. And like I said, like it really, at least, in FRC, it really doesn't end. There is a, teams are even iterating at competition, right? You're always like adding tape places, zip tying things up, like trying to make those small improvements. But the nature of FRC is that you have a living prototype that you're working with all season long, and it really just doesn't stop. It's a matter of knowing what your end goals are, and at a certain point, it becomes less about core competencies and more about reliability as far as what your robot's able to accomplish. You move from, okay, our robot
has done all the different things we said we need to be able to do, but can it do it every time? And you kind of move from one page to the other.
Okay, I have another question, which is, have you ever over iterated on a design?
Over iterated on, so yeah, and I think it kind of goes back to what I just said about the difference between like core capabilities and reliability. So, and you know what, like every time I give a talk like this, I think about new things that I want to include in talks like this. But there's a huge difference between iterating in order to add additional functionality and iterating to flesh out that functionality and make it competition ready. So a good example was in 2020. I think we over iterated on our spindexer mechanism and on our shooter, and we barely had those things even put together before our competition. And so we didn't have the ability to make our systems, or we didn't have the we didn't go through the PDCA process hardly at all on reliability of those systems. We were just trying to improve the functionality of them. And so we were in a spot where at competition, things could have been falling apart every single match because we hadn't effectively tested the reliability of systems, just the ability to actually do the basic task. So if we had focused, spent more time on reliability, less time on adding functionality, to try to meet our original goals. Sometimes you have to just cut yourself short and focus on reliability of your system. So yeah, maybe that's, we never stopped iterating, and both answers are, or both scenarios, you're still iterating the whole time. But if you're not iterating on the right problems, then you could put yourself into a bad spot when you get to the competition.
On a different side of the spectrum, what's a subsystem that you're particularly proud of 1678's iteration on?
Oh, okay, that's a good question. Probably the can grabbers on our 2015 robot. We knew from day one that winning the race to the cans was going to be important, but for the first 6 weeks, we were building a massive 20-foot wide mechanism to grab all 4 cans at the same time. And right at the end of build season, 3310 released a teaser video of their quarter-second can grabbers where they grabbed 2 super quick and hopped off the step. It was so fast that, when we first watched the teaser video, we didn't even believe that it was real. We're like, there's no way that that's possible. Turns out it was true. And literally that day, we took this mechanism that, probably 10 students had been working on for 6 weeks. We put it literally we put it in a symbolic trash can and threw the whole thing out and started from scratch. And even from that point, we ran multiple iterations of a motor-driven design for our 3 regional events that we went to. It was a different design at all 3 events. And while we were developing the 3rd regional design, we were also developing the championship surgical tubing powered design. And the motor design was good. It was good enough to win regionals, but we knew champs was going to be a matter of milliseconds. And so the surgical tubing design packed a ton of surgical tubing and a crossbow style release mechanism. And so we were actually developing that while we were attending the 3rd regional. Like, it was started development before that 3rd regional, went all the way through to champs, took a ton of testing and trial and error. We had a couple different 4-bar geometries that we were trying out, eventually settled on one that was easy to reload. And then we ended up winning champs that year, and we never lost a can race. So it worked out well. But man, the iterative design process, it requires you to kind of check your ego out the door in a lot of ways and be willing to accept the results. And when we saw that video of 3310, we had to own up to the fact that we had been going down the wrong path for 6 weeks and course correct. So that was probably one of the best iterative design processes we've gone through so far.
Thank you. That's a great story. Let's see. I have another question. How would you set up a channel for communication to prevent missing failures to iterate on?
Yeah, we have a robot status channel. It's one of our like top level channels on the team, and it's useful for sharing like updates on how far we're getting on various elements of the robot development. But it's also a great place to share results of driver practice tests and any notes, and you can tag other team members right there. So for like, we haven't had it for too long. Maybe we've done it for 1 or 2 seasons. I think 2 seasons now. But it's a great place to say, hey, was running the robot for 3 hours today, or like one of our mentors who's supervising maybe is running it or is watching the drive team practice and just says, hey, I noticed the intake, got unplugged 3 times today. We need to adjust our wire routing, or the shooter was acting funky today, like it was missing shots. So we kept practicing to get the drive time in, but we really need to look at that problem. So that robot status channel can be really helpful for those sorts of things.
Thank you. Okay, I'm going to put these together because they're sort of similar questions. How do you get your new students excited to fail? And how do you help students learn from failures in previous seasons?
Yeah, that's a tougher one, because everybody wants, like I was saying earlier, like it's more of a mentality thing. And even as someone who's been doing this for many years, like, I can like, there's moments where I am not excited about failure. Like I see it as a setback and it can be frustrating. And I think that same, instinct is present in, all of our team members, new and veteran. But this kind of this iterative design, this failure, celebrating failure is something we at least talk about a lot. So we do general meetings before every meeting, and often, I'm up there giving just a short bit about how, okay, we're at X, Y, or Z point in the design process. We need to be moving quickly. Let's identify the areas that aren't working, and let's really get excited about these failures that are going to be coming up, right? And in the prototyping process, same way. It's something where it's a lot of both trying to model that as best you can, and then also communicating the principles as often as is practical. So it takes a little bit of both. Obviously, if you're not modeling it at all and you're not willing to fail yourself, then it's not going to do a lot of good. But if you're not talking about the concepts, it's not going to get into the students' heads either. So I really try to make fail faster, kind of like, I say fail, you say faster sort of thing. Like they kind of associate the two, and they know that a big way our team works is by quick failures and identifying issues quickly.
What's your favorite accidental success? Something that technically failed but ended up like working well.
Oh, geez. Accidental success. I don't know if this is this may qualify. In 2017, the challenge that year in part was scoring those wiffle balls into the goal. Speed was really important that year because the balls were worth 3 times as much if you scored them during the autonomous portion of the game. We had a design that basically we drove up to the spot where you got the balls, and we expanded our hopper out to trigger the switch and let the balls roll into the hopper. But our sorting mechanism wasn't wasn't the best. It was using surgical tubing. It was a little bit janky. There were definitely better like ball indexing and sorting systems in FRC that year. But because we also had these flaps that expanded in and out, we found that if we, at the same time as running the surgical tubing, were like toggling the flaps in and out a bunch to kind of like flapping our wings, we could shake the balls around enough to like keep our balls per second fast enough to get all the balls out during the autonomous portion. So like, I guess it was kind of like a failure in the sense of we didn't have the perfect ball sorting system down below, but you know, we were able, just through kind of sheer luck, and it was not something we planned to do, but just by kind of sheer luck and testing, we figured out that if we also shook our flaps at the same time while we shot a couple times a second, we could shake the balls up enough to keep our speed up. So it's not really like a direct, I guess it is. I mean, it was a failure in the sense of our original system we thought could do the thing we wanted it to do, couldn't do it fast enough. But based off some luck in how we developed the rest of the system, it worked out okay.
All right, that's all the questions I have for now. But if anyone else has questions, feel free to add them to the chat in YouTube. And we can wait another moment or so to see if anyone has any more.
You know, actually, another failure that I just thought of too, back to that 2015 can grabber story, the other like lucky thing that happened that year was we were trying to grab all 4 cans at once. And so we knew that was going to take a really big mechanism with a lot of metal, and it would need a lot of space. So we actually like divided our robot in half, and the front half was for all the cans and the stacking, and the back half was for this massive can grabber wing. And we knew that we had to keep the rest of the robot below like 90 pounds so we could have 30 pounds for this massive wing that we were building. When we threw that whole thing in the trash can, we had all of this available space for us, right? We had the full back half of the robot, and we had 30 pounds to work with. So a lot of other teams that were later to the can race, they were having to like, and I think 971 is a good example of this. 971's can grabbers that year are like these carbon fiber 1 pound like pieces of art that were like, I think they wrapped the carbon fiber or whatever like custom with the can grabber shape, and they kept everything nice and light and everything like that, and they packed it into like the one spot it would fit on the robot. There was no way we were going to pull off a design like that. So but we had like a ton of volume and weight to work with on the back of our robot. So even though that large wing was a total failure and never saw the field, what it allowed us to do was build a heavier, more robust can grabber in the back area with surgical tubing power that other teams weren't able to do because they just didn't have the space.
All right, I don't see any more questions. So looks like we're gonna go ahead and wrap this one up. Thank you so much for your presentation. I hope everyone enjoyed watching that. Yeah, we really appreciate it.
Thanks for having me, Mira. It was a pleasure. And yeah, good luck with the rest of the presentations, and have a great rest of the day.
Thank you.
All right, bye.
And just a reminder for everyone who's watching, if you haven't already had a chance, please check out the 24 Hours of STEM challenge at our website. 24, that's the numbers 2 and 4, hoursofstem.org. The challenge is open to all ages and groups, and 4 lucky teams will win a LEGO Mindstorms EV3 kit. All right, we're gonna wait a few more minutes before starting our next presentation. It looks like we're still waiting for one more person. So All right, and while we're waiting, we will have a short video to watch coming up in a few moments. All right, so it looks like we're ready to get started with our first alumni panel. I'm Mira, and I'm going to be moderating this panel, and we have first alumni, Christina, Andrew, and Steph. Would you all like to start off by introducing yourselves a little bit?
Yeah, sure. I can go first. My name is Christina Rolfe. I am an alumnus from Team 1098, which is based out of St. Louis, Missouri. So probably you've never heard of them. Since my participation in first, I've continued to participate through college and grad school as a volunteer and mentor. And I guess my background is I'm a biomedical engineer and I'm currently getting my PhD in that field.
Hi, I can go next. My name's Andrew. I started first in First LEGO League and then next went on to First Tech Challenge in middle school. And finally, in high school, I was a member of Frog Force Team 503 from Novi, Michigan. So I was a member of that team for 4 years, and then I went on to the University of Michigan to study computer science. I just finished up my 7th semester, so I will be graduating soon, hopefully, and moving on to software engineering.
Awesome, thank you. And I think Steph joined us a little later, so I'll give you a second if you need to get caught up with where we are. Oh, I guess we can start off with both of you.
Oh, I think I'm here.
Oh, awesome. All right,
Hey.
do you want to briefly introduce yourself?
Yeah, sure. My name's Steph. I was part of 3132 when I was in high school, which is 8 years ago now. I am currently working at Waymo on detecting people around our vehicles.
Awesome. Well, we're so excited to have you all here. And I think you all mentioned what your career or field of study is. And so one of the questions we have is, how did first inspire you to pursue that field?
Yeah, sure. So I guess when I first so I guess my field of study, like I said, is biomedical engineering, and what I specifically do is I look at biomechanics, and so that's like how the bones and the muscles and all of that contribute to movement. And so with my field of study, I specifically apply that to animals. Like right now, I'm actually studying how horses get injured after jumping. And I think when I first this thought of like what career I wanted, I really wanted to be a veterinarian. Like that was my dream goal. And I also had heard about FIRST, like my dad started taking me to FRC competitions when I was like in 1st grade, and we didn't really have options for FTC or FLL at the time. So I was just like waiting to be able to like participate in high school. And the moment that I like was able to, and after 4 years of participation, I was like, you know what, like I still want to be a vet, but I really want to start out in engineering somewhat. Like I love building things. I love designing things. And it sort of turned into me deciding to try to merge engineering with veterinary medicine with this field of biomedical engineering. And then through 4 years of study in that field, I realized, you know what, I don't want to be a vet anymore. Like I really want to stay in here and focus on like designing things, still applying it to animal medicine, but doing it more the engineering route rather than the veterinary route.
I can speak to a little bit of a different route than I think a lot of FIRST alumni might take. So in FIRST Tech Challenge, which was in middle school, I believe, I did a lot of like programming on the robot. And that I think cemented my idea that I wanted to go into software engineering. But in high school in FRC, I actually did not do much programming at all. Instead, I focused on a lot of like outreach and chairman's award submission type stuff, which is not very related to my intended field of study at all. But I don't think this is a bad thing at all. It was definitely great for me to be able to learn to like develop my soft skills, so public speaking, interviewing, stuff like that. Writing was really great for helping with job applications, college applications. So I think it's very it makes a lot of sense to have a correlation between what you study in FIRST and what you want to study in school or work on as a career. But I think it's also important to not forget that there's a lot more that FIRST can teach you, and that can be impactful in your career, no matter what you choose to do as well.
Yeah, I guess I can speak to my experience a little bit. I think it's probably a bit different than Christina and Andrew because I joined FIRST in my last year of high school. And so I guess I was already really excited about robots from some other programs, but what FIRST gave me was such a large community of people my own age who loved doing engineering and programming and solving problems like that. And I think when you're part of a bigger group, you can have sort of a larger sense of community and really get to enjoy sort of problem solving and working with a larger group. And I think that's important for seeing like whether you're actually going to enjoy working in this as a field, because when you work with a large group of people and you solve problems. So I think it's a good exposure for that.
Awesome, thank you guys. It sounds like you all had very different paths and different experiences with FIRST to end up where you are. Some of you touched on this a little bit, but what skills have you learned in FIRST that you've ended up using in your career or field of study?
We can just keep going in the same order. I think that works best. So I would say that for me, I use a lot of things that I learned in FIRST on a pretty regular basis. So in graduate school, one of the big things that I had to do was design a device that can actually test what the mechanical properties of these track surfaces that the horses are jumping on, and understand how those mechanical properties of the surface relate to injury. And so my first sort of order of business was figuring out, okay, how do I design something? How do I build something that can measure these things that I want? And I basically made myself like a little robot. So like I was in the machine shop, actually like drilling and milling and lathing things, like, which is, I didn't know how to do before FIRST. And it was actually kind of fun because there was like a whole machine shop training course that we had to go through at UC Davis. And I just blew through that because I already knew how to use all the machines. Like I'm figuring out like how to, like what motor I want to use for this. I'm figuring out electronics, soldering things, like, and for me, like doing this as my PhD, it's a very independent sort of study type thing. So I was really the only one that was like, I had my like primary investigator, my boss, who was like helping me out with parts of it, but she doesn't know all the technical engineering stuff. And so a lot of it was on me to basically learn everything or use everything that I had learned to figure out how to solve this problem, which was really a cool experience.
Thank you. So I can talk to so I haven't started a full-time career yet, right? I'm still a college student, but as a student, my on-campus job is I'm a teacher's assistant, or TA. So basically for one of the sophomore level computer science classes at Michigan, I teach a lab section and I like help run office hours and stuff like that. And so I learned a lot about like how to be an instructor for college students from being a mentor for like, elementary school and middle school first students, right? So again, kind of speaking to those soft skills that you might not just learn in a technical sense. Wherever you find yourself in your career, I learned a lot about like, being patient and being understanding, helping to like see things from the other person's perspective. So even if, I don't end up becoming an educator in my future, which I don't plan on at this point, there's still going to be opportunities, right, where I'll probably be, trying to teach someone or train someone. And so FIRST has definitely given me a lot of experience with that, which I'm super grateful for.
Yeah, I think one of the biggest things for me was meeting a bunch of sort of people going into engineering degrees, and we ended up sharing a lot of opportunities that we found and were really valuable to each other. So I found out about a Google internship through a friend I made at FIRST. Shout out to Sarah. And without hearing about that, I never would have had that opportunity. Same with some of the mentors. They helped us build some of the projects we were dreaming about in college, and we could go back to them and ask them for advice, and they could help us. And so those connections really helped us sort of grow even beyond FIRST, which was really great. And then for my experience when I was in high school, being exposed to all these different areas of engineering was really valuable to try and understand like what things do you reckon I would enjoy in university, what things I should try out more, investigate more. So I think that was super valuable for me.
The next question I have is kind of a fun one. What's your favorite memory from being part of FIRST?
Yeah, so I guess My favorite would go back to our team's first time at champs, and we ended up just like getting in off the wait list, but it was like a great experience because our team had never been to the championship before. And at that point in time, it was actually in Atlanta, back in Georgia, and in this big like football stadium, and you just see all these fields and like thousands, hundreds of thousands of people doing robots. And I don't know, that was just like a really cool experience to be able to, be able to see the magnitude of what FIRST was. Because like even at the regional competitions, like you're only seeing like 30 or so teams, and it's really cool to see the international aspect, like all the teams from China and Australia, and you really get that at championships, which I think will last with me for quite a while.
I'm going to share a similar experience as Christina. My first champs was definitely a super, super memorable time because for me, the first champs I ever went to was in First Tech Challenge. I was in 8th grade. So on my team of like 9 or 10 students, right, that was a huge experience for us to just like, in a basement, be able to develop a team and a robot that like went all the way to the World Championship. And so that year it was in St. Louis. And so besides the fact that like, we were all 14, I think, 13, I don't know how old we are, exploring the city of St. Louis, which is super fun, but also just like, the fact that we went from, competing in Michigan with other Michigan teams who are mostly our age to go into the world stage and seeing First Tech Challenge teams, which were so advanced and so just like out there that I think maybe some teams might have been intimidated, and it was probably true that we were too, but it was definitely cool to see like how much further we had the ability to go. So I think that was an inspirational moment for us to realize like, with your, if you put your mind to it, you can like really go super far and do a lot of crazy, awesome things in this program.
Yeah, I guess I was thinking about my, most enjoyable moment was, or exciting moment was probably when I was a mentor for a group of an FLC team a couple of years into college, and I think we were working on a challenge where you had to sort of pull your robot up to a bar, and the group of teenagers I was working with wanted to build a grappling hook. I was like, this is ridiculous. How can this possibly work? And they were like, no, this is happening. And they just kept going through so many different prototypes of trying different things. And they ended up having trying the different pneumatic pistols and then sticking things on the end that would fly off and auto grab onto the bar. We went through so many different iterations and tests, and by the end of it, they managed to get something that worked pretty well. And then a guy with sort of like sailing experience came in and helped do the ropes and stuff so it would latch on and they could climb up. I think it only latched once during competition, but I think it was such a cool engineering solution to the problem. We had a lot of fun. I think the one time it climbed, we had everyone cheering for it to go up. So I think that was my favorite experience.
That's great. I love all of those. Yeah, championship is definitely an unforgettable experience. I'm sure something everyone who's been to one can relate to. How has FIRST changed since you were a student, and what changes do you predict might happen in the future, next few years?
So the biggest thing I would say is just the magnitude. Like I thought it was huge back in Atlanta where there were 4 fields at championships and each field had like 80-ish teams. And now we're to 2 championships with 6 fields each. Like it's just like gotten so much bigger. There's so many more, countries participating at this point. I think it's truly starting to become an international sort of program rather than mostly being in the United States with a few international teams back when I was a student. And I think another really cool thing is that it's a lot, like it feels a lot more attainable now. Like all the resources through different like workshops, being able to hear about things on 24 hours of STEM. Like there's so many resources now that allow teams to really come off the gate even in their first year with a really strong robot. And I think that was something that was always a struggle back when I was a student, is like your rookie season, you produce something and it's usually not very good. Like And you have a lot of fun doing it. Like it's a great experience, but the more you do it, the better your robots become. And I think now with all the resources, you can have a really strong start. And I think that's a good opportunity. And I guess I don't know what the future is going to look like, but my hope is that keeps getting better and better. So to even the playing field for everyone sort of in this competition.
Yeah, I'm going to agree a lot with what Christina said about kind of the accessibility of FIRST. That's something that I have noticed has gotten a lot just better, I think, especially like when I started out in FIRST, a lot of your performance was kind of correlated to like if you had mentors who had done FIRST before or students who had done FIRST before, which is not necessarily a bad thing. But I think if you're a team that doesn't really have a lot of exposure at all, you're really going to notice that because you just don't, you spend so much time trying to get your head on right and understand like what's going on around you that you have less time and energy to devote to building the robot. And so I think that now, both in terms of like resources available online, either whether that's like tutorials that teams have made or pre-built modules that you can purchase, it's in addition to like teams who are directly reaching out to other teams to like mentor. I think that FIRST has kind of taken hold of the fact that teams just benefit much more when they work together and help each other out. So I think that's one change that I've seen FIRST go through that I think is really positive. And I really hope that, again, like Christina, I hope that in the future that change kind of continues in that trend.
Yeah, I definitely agree, especially sort of the part of international teams becoming way more popular and support going out for teams. I think, especially, I guess, from my background, which is from the Australian teams, we went from one team to 6, and now I don't even know how many teams there are. There's 2 regionals. It's just crazy. And I think it's amazing how they all work together and share information. I think just sort of geographically being close to each other makes a huge difference. And I think that for teams in Australia now, there's a lot of opportunity for people to reach out and get support and grow and learn from each other, which I think is awesome. And I hope that's happening in other parts of the world as well. As far as what would be really cool to see in the future, I think it would be as sensors and stuff are becoming cheaper. I really hope that the teams can build more and more interesting autonomous robots and doing autonomous tasks. I think it's really hard to get started from nothing, but slowly, so there's more and more sort of machine learning sort of things that are pre-built and set up for kids, and hopefully that means they can detect objects and sort of maybe navigate on the field maybe one day, but by using sort of kits and stuff people have set up. So hopefully that's something that becomes more accessible and easier to do for everybody.
I see that there are now 47 FRC teams in Australia, which is incredible. And I had a request to ask Steph about the driving couch. Do you want to share that memory?
Sure. So I guess when we were I think it was on an FRC team trip, possibly, I think it was when we went to Hawaii, we were all joking about, whilst we were on a hike, so we're all joking about things we'd like to build. And something that came up was a robotic couch that went on a pair of sort of Omni wheels that could go in any direction. It was just a silly discussion and a joke, and then we figured that maybe we could actually make this happen. And then we sort of started university. We managed to get funding to do this. And we came together with, so some of the mentors from the 3132 helped us out, a whole bunch of students who had just started university. We all worked together to build this couch, which ended up being this IKEA couch. And then these 4 big omnidirectional wheels from AndyMark. And then we got some really interesting motors we just found on Alibaba and shipped them over to Australia. And just managed to build this couch, which got up to probably like a jogging pace. But along the way, it caught fire multiple times. Like it destroyed a table. I don't know, there was a lot of effort and iterations and to get this thing working, but I think it was, I don't know, really silly and fun activity.
That's a great story. let's see. Oh, I think Christina touched on this for the last one. That there's so many more resources available to students in FRC, and so people even in their first year can do so much more. And so the next question I was going to ask was, what are some of the best resources for students who want to go deeper into programming, mechanics, electronics, that type of thing?
Yeah, so I mean, yeah, there are tons of resources, and I'm going to talk to a few even outside of FRC, I think. So for mechanics, like recently I had to do a qualifying exam, which basically is sort of an oral exam that you have to take when you're getting your PhD, and you're basically questioned on every engineering subject you've learned from undergrad and grad school. It's really intimidating. But one of the resources that I used to prepare for that was actually the MIT OpenCourseware. They have a lot of really good resources, like if you want to learn about statics and dynamics, which can be really useful to understanding like how load should be distributed on your robot and stuff like that. And those are really great resources where even as a high schooler, you can get a jump start on some of these classes that you might take if you decide to pursue an engineering degree in college. As far as electronics, I think like I've done a lot of like playing around with like Arduino and Raspberry Pi. They are really cool little systems, and you can buy like kits that come with the Arduino module, a little booklet that tells you how to like hook up sensors to it, and that sort of teaches you programming and electronics at the same time. And there's even one Arduino kit I think that's building a little robot. So I think that's a really cool resource as well if you're wanting. Well, Christmas is almost here, but like for a birthday gift, maybe I might suggest getting one of those if you're interested in playing around a little bit with robots at home to learn some more.
So one resource that I think for FRC teams is really cool is what's called the Limelight, which is a basically fully like ready, competition ready smart camera for FRC. And I'm really bummed that this kind of came out after I left FRC, because I would have loved to have been able to play with it as a student for sure. But basically, it's a great way for especially rookie teams to kind of get a strong basis for like their programming division and for some autonomous control, because that's I think one thing that really sets apart the average FRC team and some really great FRC teams. So it's even if you don't end up using the Limelight camera on your robot, playing around with it, being able to learn how it works and learn from it, and even if you can design your own system based off it, I think that's a really great opportunity that FRC teams could take a look at.
Yeah, I guess it's been a while since I've been either a student or really heavily involved in a team, so I can't give any first specific answers apart from maybe talk to your local teams, especially ones that have been around a while. Often they're super helpful and friendly, and maybe able to give you support in ways you can't imagine. But as far as technical resources, I guess recently I've been doing a lot more machine learning, especially maybe a couple of years ago I was teaching myself from really not knowing anything at all. And a couple of really great resources were from, say, Coursera. There's a bunch of great courses there from really beginning how to program to machine learning and beginning courses there. I really enjoyed the Fast AI courses. They really go from nothing about machine learning. It's a really practical course to teach you how to do and understand deep learning algorithms. And it's a series of lectures that are really practical focused, and they were excellent. I learned so much. And another one is Kaggle, which is a competition a programming series of programming competitions where you solve machine learning problems and you can compare your results to others around the world. And I think it's really excellent because it encourages you to practice your skills, compete against others. It's sort of similar to FIRST, where you get continuous feedback about how you're doing. You can talk to others. So if you're interested in any of those areas, I really recommend those resources.
Thank you. Those are definitely great resources, and I hope people listening that you check some of those out if you're interested. Let's see. Another question I have, what advice do you have for current students in first?
I think my biggest piece of advice is to probably try everything. So like I mostly was on the mechanical sub team on my team, but I also did electronics for 1 year. I dabbled a little bit in programming, at least to understand what they were doing. Like I helped with the judge presentations. And I feel like that's the whole point of first. Like I would recommend maybe not getting like super deep into a specific sub team, because like during high school, you really want to learn what inspires you. Like what do you want to do for your future career? And first gives you so many avenues that you can explore in a pretty safe environment. And so that maybe by your senior year, you can like focus in the one that you really want to focus on. But yeah, I would say take advantage of the opportunities, and then also remember, just because you're like on the programming sub team or on the mechanical sub team, like you are a team and need to work together. And I know like in industry, we all the time we have to work like as a biomechanics person, I have to work with people that do programming and with people that do electronics, and we come together to figure out what the problem is. Because I know on my team, we a lot of times ended up blaming each other. And so being able to understand, what's going on with the other sub teams and trying to come together as a team to work out problems and troubleshoot rather than just like pointing fingers at people, I think is a really probably more effective way to deal with conflict, and also something that will help prepare you for industry and the rest of your career.
So with first, I think probably the biggest piece of advice that I give is that you get out of first what you put into it. It's a lot of students, I think, maybe not a lot of students, but there are definitely some students who will join a first team and not put in a whole lot of time and effort and just kind of expect that they are going to, magically learn a lot about robotics or get into their dream college. And it doesn't really work that way. You generally have to put in the effort to make those things happen. And I think it's pretty easy to see a lot of people who have, first success stories, and they, got a lot out of it. They got to go to a school or a career that they really want to. But those students, what they all share in common is that they all put in a lot of effort when they were first students, right? They put in, a lot of hours into working on their robot, or they went to a lot of outreach events and, led initiatives. So while first is certainly a hugely beneficial experience, it doesn't just happen. It doesn't just fall into your lap. As a student, you really need to be proactive about your own experience, making sure that you are, trying to be a team leader, stepping up whenever possible, even if it's to do something that you don't necessarily want to do that bad, because you're going to get a lot more out of first, and you'll be able to see, the benefits of what you've done, as opposed to just kind of joining the team and not having too much to do, and then you're kind of like, oh, what's the point of that, right? So if you are in first right now, or if you're thinking about joining first, I really recommend that you kind of go at it with your full effort, because you'll definitely get the most out of it that way.
Yeah, I guess I think one really important thing is persistence. Is the first time you try anything, you're not going to be very good, and that's okay, right? You just need to keep practicing and trying again and again. And each iteration of a design or your attempt at a problem, you'll learn something new. And as long as you can apply what you learn or what you find out to your next time you try it, you're going to get better. And I think it's just this practical experience of trying and retrying and keep going and refining. And even if it does work, how can it be better? Could it be more efficient? Could it be lighter? Could it be faster? So I think that's really important. And then the second thing I wanted to say is that trying to understand what you're doing and why you're doing it is really important. You might have a better insight into the problems, or maybe you don't even need to solve that particular problem if you really understand what you're trying to achieve at the end of the day, right? Like maybe having building a shooter that shoots balls the full length of the field, maybe that's not even a problem you need to solve. Maybe you need to approach the game in a different way, or think about the situation in a different way, or use a different technology. So I think that's the two things: persistence and really understand what you're trying to do.
That's really awesome advice. I think this is sort of a similar question, or similar, like asking for advice question. How did you choose your undergrad college, and what advice would you give students for that process?
Yeah, so I did my undergraduate degree at Texas A&M actually, and then am now doing my graduate degree at University of California, Davis. And I think when I was choosing my undergrad college, like I had the major that I wanted to do in mind, so I knew I wanted to be a biomedical engineer. And I really just like looked at the different biomedical engineering programs, and for me it was choosing the program that fit with what I wanted to do. So I want to focus mostly on like biomechanics, things like with the skeletal system, bones and muscles and stuff like that. And Texas A&M had a really strong program for doing that. And so I think yeah, for me it was mostly just which school has sort of the best like major that's what I want to do with my career.
So for me, and I think a lot of people, or like a lot of people, choosing your undergraduate school has a lot to do with finances. It's a part of reality. So for me, looking at kind of the price tag was a huge part of it, and so I ended up going to the University of Michigan, which part of the reason why I was able to go there was because especially with First's huge push towards getting students to apply for scholarships, that definitely made it easier to decide when I could like have the whole picture of like finance on the table. And so a lot of that picture in terms of finances, a lot of it came from my experience in First, being able to apply for scholarships that were either First specific or where I could talk about my experience in First. So at least in that aspect, First definitely helped me just like be able to sort things out a little bit more.
Yeah, so my undergraduate, I did a degree in computer engineering, and I think throughout high school, I really enjoyed both the programming aspect, and I wanted to learn more electronics, and this was sort of a degree to do both of that. As far as which university I chose, I went to the University of New South Wales, and they had outreach programs with their own robotics competition, as well as a course where you could do the first semester of computer science, one of the courses they have for that, and they will teach you that in your sort of second last year of high school, with a bunch of other high school age students, and I had a really, really good experience with that. The university had a good reputation, and I applied for some scholarships at the university and got one that was research focused, so I could work my summers with a research lab and a big variety of projects, and I'd get paid a stipend as I was studying. And so the combination of all these things made me choose a university, and I had a really great experience there.
Okay, I've got a couple of fun personalized ones. So it seems that Andrew is known for his Twitter skills on 503. Can you tell us a little bit about that?
Yeah, so at least when I was in FRC, most teams had like a Twitter account or social media presence to, do public relations for their team in terms of like, connecting with their district or connecting with other teams. And so that was one of my responsibilities, was that public relations aspect. It's definitely a lot of fun because you get to, just mess around with other students who run their own Twitter, or who run their team's Twitter accounts, as well as kind of the actual important stuff, which is, making sure that your district, your local newspaper, or the head of your school board is informed, inviting them to competitions. So it's a lot of fun, and it's certainly a skill, right? It's kind of like one of those soft skills I talked about before, that even if you don't directly apply it to your technical career, you're still going to benefit a lot from it in First. In college, for one of my student orgs, I did public relations for them for a year and did a lot of work, trying to get like members to join, just like how I did in FRC. So even if you're not, coding or building the robot, you still can learn a lot of stuff in First that like might not seem super useful and important, but you're definitely gonna build off of that in the future.
Sounds like that was a fun one. And then Christina, we hear you love to design games and escape rooms. How did you get started in this, and how have you used your first skills to help you?
Yeah, so wow. I don't know if everyone knows what an escape room is, so I guess I can start there. So basically, escape rooms are like hour-long experiences where sometimes they lock you in the room, but usually that's considered kidnapping, so they can't legally do that. So they just put you in a room that you can totally get out of. And then you have to solve a bunch of puzzles to like find the hidden gem or the pirate's treasure or whatever the theme of the game is. And I think I did my first escape room back in like 2013, I think. And since then, I've actually done about 100 games that I've played. And about 2 years ago, we decided that we wanted to help out with like building some of these puzzles. A lot of the puzzles are electronic and use things like RFID chips and like sensors and stuff like that in order for the puzzle to function. And it gives like this magic element to it. So if you put like the 4 boxes in the correct order, it will trigger the RFIDs correctly and like something will pop open. And so I mentioned it earlier, but that's actually how I've learned a lot of the Arduino and Raspberry Pi, like about Arduino and Raspberry Pi microcontrollers, is in the process of building escape room puzzles for different companies that we worked with. So if you're interested, again, if you're interested in learning more about programming or electronics, I think those microcontrollers, like they're pretty cheap actually, like to get, and you can learn a ton through them. Like beforehand, I had known like how to program mostly through like MATLAB, which is a C language. And now I also know Python and different languages through my experience building escape room puzzles. So I guess it kind of goes to show that you can do fun things too, even in your spare time with the skills that you learn in first.
Yeah, for sure. And I think that goes back to Steph's story with the driving couch as well, that you can do lots of fun things with your skills from first. Okay, I've got one more question from our prepared list. And let's see, what is the biggest unsolved challenge in your career or field of study?
Yeah, okay. So for me, on the sort of medical side of things, I think the biggest challenge that we really see with anything we do with orthopedics or like creating implants is this idea that we don't have a perfect material that can replicate what the body can do. So any material we might use for like a hip replacement or a knee replacement, like those materials are going to have like different properties, like different stiffness, different modulus, stuff like that, than what the human body has. And that can cause problems when we try to implant these things because there's like this mismatch of what the native tissue is and what our replacement is. And so solving this biomaterials problem and trying to recreate true tissue properties with man-made materials, I think is probably the most up and coming challenge that we're really trying to deal with in my field.
So in terms of like, my full-time career, I don't exactly have a field yet. So I think I'd rather speak to like my part-time job that I spoke about, which is being, a TA, an educator. And so I think the biggest problem that like my core staff and I run into is just like how to get concepts across to students, right? Because a big challenge in, university teaching is that you can have like 1,000+ students in a course like we do, and 4 professors, lecturers, right? So how do you, attack that challenge of like that huge mismatch in numbers? And so I think a big part of it, besides increasing your manpower, which is not always possible, is that when you're creating educational resources, you have to be really smart and kind of intentional about how you are reaching out to students. And so a large part of like what some of the professors I've worked with and taught under have worked on is educational resources specifically for teaching computer science. So for instance, one tool that we've worked with is an online, basically a C++ interpreter. So what it does, it kind of shows the status of your memory in the browser, and it can walk you through like visually what's going on. And so something like that, while it probably doesn't compare to like, being able to sit down with the student one-on-one and walk them through a problem, it's certainly more scalable when you have 1,000+ students and, growing every semester that are trying to take computer science.
Yeah, so I don't think I can speak to the biggest challenge in my field. Don't think I know nearly enough. I work on self-driving cars, and so this is still a really fast evolving field, and there's lots and lots of challenges to make, not only make it work, but also make it how are we super confident that it's going to be safe as we scale, and how do we make it scale to different locations and places and situations. And so I think there's a huge amount of work to do that, and I imagine probably students in first today are probably going to still be working on these problems once they graduate and if they go into this field. I think I guess a lot of my work is focused on detecting people specifically, and I think we think a lot about like how do we make sure we cover every possible situation, and what do we need to do that, and how do we think about it, and what do we need to solve. And so it's not just a research problem about like what do we need, what new deep learning techniques do we need to do to make this to work better than ever before, what situations do we need to care about, how do we measure and evaluate this. So there's sort of the engineering problems that go along with the sort of research problems as well. Yeah, it's a lot of problems. I don't think I can put my finger on the biggest.
Yeah, that seems like a fitting question to end with, like leaving people with something to think about, a new challenge that maybe they'll need to come up with solutions for. So with that, we're gonna wrap up our panel. Thank you all so much for participating. It was really fun to hear all of your stories and chat with you. And for everyone else watching, we're starting to see submissions for the 24 Hours of STEM challenge come in, from card games to portable solar systems. So be sure and submit your solutions on the 24 Hours of STEM website, which is 24 the numbers, hoursofstem.org. And thank you so much to everyone for watching.
Cool. Thanks for having us. See ya.
Yep.
Thank you.
We hope everyone has enjoyed these presentations over the past 24 hours, and it helped you learn something new and entertain you during these uncertain times. We had over 100 people working on this event, from the presenters to the host teams, and I want to give a huge shout out to everyone who gave their time and talents for this event, as well as the teams who helped co-host this event with us. So until next year, this is Team 971 signing off. Have a great evening.